All right, and welcome to the Android Application Development course for beginners. I will assist you throughout this course, so without any further ado, let's start to learn. So first of all, I should explain, before you get too far in this course, who should take this course. So this course is an absolute beginner course, which means that you do not have to know anything about Android programming to begin. In fact, it would be better off if you didn't. That way you'll think that I'm an expert. And really, who doesn't want to learn from an expert? Anyway, you will learn everything that you ever wanted to know about Android development, and even if you do not know how to write code, it's okay, because you're going to learn how to write code and programming concepts. This course is basically designed to teach you how to think like a programmer, how to write code, and how to build an application, and everything like that. Also, who are you if you want to take this course? You want to know something about coding and you want to learn Android app development. For example, if you know C programming language or Java programming language, this is good for you because you can use your programming experience to develop great applications. You can combine what you knew before, what you're learning now, and what you will learn in this course. So if you want to be an Android developer, you should also take this course because you will learn how to become an Android developer, which is basically how to design an Android application and how to build a good and in-demand application. Now, you're probably scratching your head wondering, all right, you got me so far, but what am I going to learn in this course? So first of all, you will learn Java programming as a language because we will use Java to build Android applications in this course. Now, of course, there are two popular programming languages to build Android applications. You know what they are? Of course, Java and Kotlin. Okay, so why will we use Java and not Kotlin? Because Java is a programming language that's been used for many, many years. You can find a lot of resources about Android development with Java. And if you have some trouble with your code, then you can find solutions from the internet. Also, pro tip here, most of the software companies who are looking to hire developers like you're going to be, they use Java in their application development process. So it is a skill that you must have. Now, because of all the reasons I've explained, we will be using the Java programming language. And without knowing this language in particular, you cannot develop an Android application. Have I made myself clear? Okay, so if you do not know Java, it's okay because you're going to learn it in this course. Well, you're going to learn the basic information about Java and programming concepts as well, okay? So if you do know Java as a programming language, then you can skip this part and go right to the Android application development chapter. All right, so you with me so far? After you learn Java programming, we will start to learn Android Studio. Android Studio is the official integrated development environment, or IDE, for Android application development. So we're going to learn Android Studio platform and its working system. Then you're going to learn the Android ecosystem. So Android is an operating system like Windows, but for mobile devices, right? And its popularity is increasing every single day. This is not your daddy's Android. Android is not only for phones anymore. It also uses tablets and smartwatches, smart televisions. And with the increasing use of the Android operating system, the need for new Android applications is increasing as well. So for all these reasons, and probably more that I've neglected or edited out to mention, the need of Android application developers is also increasing, right? You get that. That's logic. So after recognizing the Android ecosystem, you're going to learn Android components. The Android application components are the essential building blocks of an Android application. You'll learn how to build Android applications in these chapters, and you will see every Android component and how to build a perfect Android application. I said perfect. So, in case you haven't understood me so far, you're going to learn from scratch how to build an Android application. Throughout the length of the course, you will develop 2 Android applications, and they will be absolutely complete. And what did I say? Perfect. You will also learn how to publish your app on Google Play. You're going to learn how to open Android developer accounts and how to publish your app. All right, so I hope that I've generated some kind of excitement with you to continue on through this course. So after the introduction is done, which I hope is pretty soon, we're going to start the new chapters. Now look, I really sincerely hope that all of you will be good Android application developers. I'm going to look for you in the Google Play Store. Android is a Linux-based mobile operating system developed by Google, so it serves as its mobile operating system. Today, the platform is the foundation for a wide variety of modern technology, such as mobile phones and tablets, wearable tech, TVs, and other smart devices. Typical Android builds ship with a range of pre-installed apps and support the installation of third-party apps through the Google Play Store and other marketplaces. It's free, it's open source, and its source code is known as Android Open Source Project, which is primarily licensed under the Apache license. The Android OS is divided into various version numbers, implying significant jumps in features, operation, and stability, which usually have code names. The history of Android begins in October 2003, well before the term smartphone was widely used and, well, several years before Apple announced its first iPhone and iOS. In 2005, the next big chapter in Android's history began when the original company was acquired by Google. And of course, in 2007, Apple launched the first iPhone and ushered in a new era in mobile computing. At that time, Google was still running on Android in, secret. So that year, the company slowly began to reveal plans to compete with Apple and other mobile platforms. And the public beta of Android version 1.0 launched for developers on November 5th, 2007. By September 2008, the very first Android smartphone was announced, the T-Mobile G1, also known as the HTC Dream in other parts of the world. The first official generic codename for Android didn't appear until the 1.5 Cupcake release was released in April of 2009. Now, naming Android versions after sweet candies and sweets traditionally belonged to Ryan Gibson, the project manager at Google. I don't know if you're like me, but I can certainly whet my appetite during Android versions. But I'm going to continue to list them and maybe grab some snacks along the way. But I'm sorry if you're somewhere where you won't be able to, imbibe. But anyway, Google quickly launched Android 1.6 Donut in September 2009. So the new OS now offered support for carriers using CDMA-based networks, and this allowed Android phones to be sold by all carriers around the world. In October 2009, Google released version 2.0 of the OS with the official codename Eclair, and one of my favorites, I must say. So this version was the first to add text-to-speech support and also introduce live wallpapers, multiple account support, and Google Maps navigation, among many other new features and improvements. Android 2.2 Froyo was officially launched in May of 2010. Now, Dalvik JIT compiler that compiles bytecode into native machine code at runtime was added to Froyo. So it also has several new features, including Wi-Fi mobile hotspot functions and push notifications via the C2DM service, or Android Cloud to Device Messaging Service. Of course, Flash support and some other things. Now, Android 2.3 Gingerbread was launched in September 2010. The OS received a user interface refresh under Gingerbread. It added support for using near-field communication, or NFC functions, for smartphones with the required hardware. By February 2011, Honeycomb was introduced. It was created for tablets and other mobile devices with larger displays. And then another of my favorites, Ice Cream Sandwich, was released in October 2011. It included a Favorites on the home screen, along with the first support for unlocking a phone by using its camera to take a picture of its owner's face. That kind of biometric sign-in support has evolved and certainly improved considerably since. The Jelly Bean era of Android began in June of 2012 with the release of Android 4.1. There are new notification features that display more content or action buttons, along with full support for the Android version of Google's Chrome web browser. Android 4.4 is the first version of the OS that actually used a previously trademarked name for a piece of candy. KitKat officially launched in September 2013, and it was optimized to run on smartphones that had as little as 512 megabytes of RAM. So this allowed phone makers to use the latest version of Android on much cheaper handsets. Then Android 5.0, or Lollipop, launched in the fall of 2014. The Android runtime became the default runtime for devices running Android 5.0 and higher. So Android 5.0 Lollipop was also a major shakeup in the overall look of the operating system. It was the first version of the OS that used Google's new material design language. In the fall of 2015, Android 6.0 Marshmallow was released. It included features such as native support for fingerprint biometric unlocking, USB Type-C support, the introduction of Google Pay, and so much more. Version 7.0 of Google's mobile operating system launched in the fall of 2016. Android Nougat supported the Vulkan API for faster 3D rendering. In March 2017, Google announced and released the first developer preview for Android Oreo. So it packed in lots of visual changes into the settings menu, along with native support for picture-in-picture mode, notification channels, new autofill APIs for better management of passwords and fill data, and again, a whole lot more. On August 6, 2018, the company officially launched the final version of Android 9.0, giving it the official code name of Pie. Android 9.0 Pie included some new features designed to help extend your smartphone's battery life. Now, that was achieved with the use of on-device machine learning, which predicts which apps you're going to use now and which you won't use until later. On August 22, 2019, Google announced a major refresh of the Android brand, and that included a new logo and, more importantly, the decision to ditch the traditional dessert name for the next version. So, as a result, I go without dessert, and Android Q is officially known just as Android 10. Android 10 had a number of new features and improvements, as well as a number of new APIs, and that included support for the rush of then upcoming foldable phones. Then, of course, finally, The final version of Android 11 was launched on September 8th of 2020. Now, Android 11 has arrived with plenty of new features, and that includes a new conversations notification category where all of your chats from various apps are collected in one place. You also have the option to save every notification that has appeared on your phone in the last 24 hours. A brand new feature lets you record your phone's screen, complete with audio, without needing a third-party app. There's also a new section of Android 11 dedicated to controlling smart home devices. It's come a long way, baby. Android ecosystem. Wonderful. Hello, everyone. We're going to talk about the Android ecosystem in this particular video, so we'll start without wasting any time trying to generate excitement. Android is an operating system designed for use on mobile devices. You knew that, but Android operating system was originally created for use in digital cameras. Bet you didn't know that. So, flash forward, this is how fast digital moves. The Android operating system now is developed primarily for use on smartphones, touch tablets by Android and Google, because Google bought Android back in 2005. The Android operating system was released in 2008. Now it's used by more than 100 languages today. Now, although the Android operating system was developed for, cameras, smartphones, tablets, today it's being used in Android televisions, smartwatches, Android Auto, as well as Android Wear devices. So Android Auto is, it's car smart multimedia systems. More than 2 billion people use Android operating systems as of May 2017. Google Play has more than 2.8 million applications published. More than 6,000 applications are published on Google Play every day. One of them is going to be yours. More than 20 million application developers will be needed by 2020. You're going to be one of them. So that means that you need to learn Android application development pretty quickly. So I think that this course is going to be great for your learning process. Then after the course, you will be a good Android developer. So let's speak about salaries. Now, I know you wonder, okay, well, all right, that's all fine, great, but how much am I going to get paid? I'll tell you, a junior Android developer salary is more than $55,000 per year. I believe you're going to make more. The middle-level Android developer salary is more like $100,000 and up. Senior-level Android developer salary, that's about $130,000 every year. I think you might know what to do with that. So now what I would like to do is show you how widely Android is used in the world in figures. So the percentage of widespread use of Android will show us a number of users who should care about mobile security and the importance of ensuring Android security in particular. So an ecosystem in market terminology refers to the independence between demand and supply. So let's examine this on a chart. So this graph shows the mobile operating system's market share worldwide from January 2012 to July of 2020. As you can see here in the graph, check it out. Android is the leading mobile operating system worldwide in July of 2020, taking a 74.6% share of the entire mobile operating system market. Android and Apple iOS, of course, jointly possess almost 99% of the global market share. 1.6 billion of the 3.5 billion people using smartphones all over the world are Android users. And the number of available apps in the Google Play Store is 2.96 million. These are huge numbers, wouldn't you agree? So let's have a look at which versions of Android are used most widely. So this graph here shows the Android operating system share worldwide by OS version from 2013 to 2020. As you can see here, Pi 9.0 is indeed the most popular version of Android operating system as of April 2020, with a total market share of 31.3%. But look at this. Despite being released in the fall of 2015, Marshmallow 6.0 was still the second most widely used version of Android's operating system on smartphone devices. Now, you may remember that developers at Google previously named Android versions after certain items of confectionery, but in a break from tradition, the latest release in September 2019 is simply called Android 10, which had a share of 8.3% 7 months after its first release. Now, the question may pop into your head here, why are older Android versions still being used? Well, of course, it's considered good practice to install the latest version of the software onto your smartphone, especially for security reasons. But Android updates vary by device, manufacturer, and mobile carrier. Now, it's also true that older devices cannot always run newer Android versions. In fact, around 60% of Android devices are running a mobile operating system that is over 2 years old. That's a fun fact for you, huh? Especially if you are in the digital security sector. In any event, since Android Pi 9.0, because it's the most widely used, I'm going to be using Pi 9 here during the course. But you can also use Android 8 and 10. So this chapter was just to give you some, general information about the Android ecosystem. Hope it was useful. After this video, we're going to start to install Android Studio. If you're ready, let's go. So let's have a look at Android software stack because it's composed of several different layers. So each layer defines interfaces and offers specific services. So let's briefly examine Android's architecture from the bottom up. As you can see in the figure, Android is built on top of the Linux kernel. As in any Unix system, the kernel provides drivers for hardware, networking, file system access, as well as process management. Now, on top of the kernel, the hardware abstraction layer defines a standard interface for interacting with built-in hardware components. So this is the basis for allowing applications to interact with the device's hardware. For example, it allows a stock phone application to use the device's microphone and speaker. Android Runtime, also known as ART. So this is an application runtime environment, replacing Dalvik, which was the process virtual machine that was originally used by Android. So ART performs the translation of the application's bytecode into native instructions that are later executed by the device's runtime environment. I'll explain this process in much more detail in the next lecture. Many core Android system components and services, such as ART and HAL, are built from native code that requires native libraries written in C and C++. The Android platform provides Java framework APIs to expose the functionality of some of these native libraries to apps. Android's core Java libraries are originally derived from the Apache Harmony project and just happen to be the next layer on our stack. Now, on top of native libraries and Android runtime, there is Android Framework. So Android Framework includes Android APIs such as user interface, telephony, resources, locations, content providers, and package managers. It provides a lot of classes and interfaces for Android application development. Now, on top of the Android framework, there are applications. All applications such as browser, camera, calendar, home, contact, and settings are using the Android framework that uses Android runtime and libraries. Android runtime and native libraries are using Linux kernel. So let's look at some of the details of Android runtime and the compilation process of an APK with a lifecycle diagram. Android apps are usually written in Java and compiled to Dalvik bytecode, which is somewhat different from the traditional Java bytecode. The Dalvik bytecode is created by first compiling the Java code to class files, then converting the JVM bytecode to the Dalvik DEX format with the DEX tool. DEX OPT does some optimizations on the DEX file, and the result of DEX OPT is an ODEX, or optimized DEX file. Then it's packaged into APK files with APK Builder. So let's have a look at that, because APK, it stands for Android Package Kit, and also Android Application Package. So it's a file format that Android uses to distribute and install apps. It contains all of the elements that an app needs to install correctly on your device. So just like exe files on Windows, you can place an APK file on your Android device to install an app. ODEX files and DEX files are executed by Dalvik. Dalvik also uses just-in-time compilation, which was introduced in Android 2.2 Froyo. Just-in-time compilation adversely affects performance because compilation must be performed every time the app is executed. Now, to improve performance since Android 5.0 Lollipop, Android executes this bytecode on the Android runtime, or ART. The Android system uses a tool called DEX to OAT, which converts DEX files into ELF files, which can be executed natively. So instead of having bytecode that is interpreted by a virtual machine, it now has native code that will be executed natively by the processor. So this is called ahead of time, or AOT compilation. Now, as the name would imply, apps are pre-compiled before they are executed for the very first time. This pre-compiled machine code is used for all subsequent executions. AOT improves performance by a factor of 2 while reducing power consumption. ART increases battery performance to such a large extent because of the AOT. So while Dalvik uses the JIT or JIT approach, it results in much more battery utilization. So the key difference between Dalvik and ART is the way the bytecode is executed. So it's also very important to know about the basics of file structure of an Android application. So in this lecture, some important files and folders and their significance we'll go over so that you can easily understand the Android Studio work environment. So Android Studio is the official Integrated Development Environment, or IDE, for Android app development. Android Studio provides the fastest possible turnaround on your coding and running workflow. Now, throughout the course, we will be using Android Studio mostly as an Android emulator. So this Android emulator simulates Android devices on your computer so that you can test your applications on a variety of devices and Android API levels without needing to have, several physical devices scattered across your desk. My desk gets smaller and smaller every day. No, I won't show you a picture of it. So the emulator provides almost all of the capabilities of a real Android device. So it's definitely worth a look. However, we need to install it first. So I want you to find your favorite browser, search for Android Studio. And the first website is indeed the official website of Android Studio. So just click on it, scroll down a little bit, and quickly browse for the features. And okay, so here you see the layout editor. So this enables you to quickly build layouts by dragging UI elements into a visual design editor instead of writing layout XML by hand. Android Studio also includes an APK analyzer, and this provides immediate insight into the composition of an APK after the build process completes. Using the APK analyzer can reduce the time while debugging issues with DEX files and resources within an app. It also will help you reduce an APK size. Now, like I said before, it's thanks to the emulator feature that you can simulate incoming phone calls and text messages, specify the location of the device, simulate hardware sensors, access the Google Play Store, and, well, just about anything you can think of. Android Studio also has a flexible build system and real-time profilers. Now scroll down a little bit more, and here are the Android Studio download files. So you can download it here depending on your operating system. And here you can download the package suitable for your particular operating system. So these are the system requirements to use Android Studio. So once you've read it through a little bit, let's go ahead and download. And of course, before downloading, we'll agree to terms and conditions. Click on download and save the file. Okay. So now we just wait a little bit. And it is now downloaded, so we can click on the downloaded disk file. And I'll move it to the application folder. And this is good. So installation is now complete. Okay, so go ahead and open Android Studio. And there's a couple of steps that we need to step through to get set up. Next. I'll choose the standard type. Next. So I do like dark theme. And next. These are the installation settings, so let's review them. And it all looks good to me, so let's go ahead and click Finish. So now it's downloading the components. And you might need to allow a little time for the installation. All right, so now I've got to allow some extensions from the security preferences. Use password or fingerprint and allow from here. Now we can lock the changes. Okay, so installation is complete. Let's go ahead and open it. Okay, let's create a new project. So after that, you're going to see a new page. This page is where you can select a template for your particular Android application. But in this part, we're going to choose Empty Activity and then click Next. And then on this page, we're going to give our project a name. So I'm going to put my name as my first project. And you can give your project whatever name you want. And the second line is for the package name. So package names start with com dot. So after com dot, you should write your company name. And then you can give a name that you want here. So my company name is in here. And after com dot company name dot, you should then write the project name. And Android Studio should have written itself, my project name, deleting gaps. But if you want, you can change it here. And don't forget, the package name must be unique, right? So when you want to publish it in Google Play Store, for instance, it will be published with the package name. That is something to keep in mind. Now, on the third line, you're going to see the project save location. Android Studio will give you a saving location on your computer, but if you want, you can change this location. Now here we are on the fourth line. You're going to choose the programming language. What are we going to choose? We choose Java. Right. On the fifth line, here are all the API levels. So we should choose the API level for our Android application. Now, you'll see here that if I choose API level 15, my Android application will work on 100% of Android devices. That's how they guarantee it. So if I choose API level 16, my Android application will work on 99.6% of Android devices. And if I choose API level 22, my Android application will work on 80% of Android devices. So in other words, when I choose higher level APIs, the working rates on Android devices will start to drop. So this is the part where you need to be careful, because when you choose a higher level API, you can use advanced features on your application, but also your application work rate on Android devices will drop. You see the correlation? I knew you would. So it, of course, depends upon your application features. If you develop an app and this app just needs to have basic features, you can choose a lower API level. But if you develop an application with advanced features, you should obviously choose a higher API level. Also, you can change your API level later. So the initial API level 15 is probably good enough for what we're going to do for us. So just click Finish. And when you click Finish, Android Studio will create a new project for you. And this part can take a few minutes. It depends upon your computer speed. Okay, great. So now our project's ready and we can develop an application right this second. But I'm going to finish the video here and we will continue the rest of the lesson in the next video. So in a basic sense, apps are designed in order to run either directly on the platform for which they're designed, on top of a smart device's mobile browser, or even by mixing the two. So in this lecture, we're going to define characteristics that qualify an app for its respective place in mobile app taxonomy, as well as discuss the differences for each variation. Let's have a look at native apps. So mobile operating systems, including Android and iOS, they come with a software development kit, or SDK, in order to develop applications specific to the OS. A software development kit, or SDK, is a collection of software development tools in one installable package. Such applications are referred to as native to the system for which they've been developed. So when discussing an app, the general assumption is that it is a native app implemented in a standard programming language for the respective operating system, Objective-C or Swift for iOS, and Java or Kotlin for Android. Now, there is some ambiguity that exists when discussing native apps for Android, as the platform provides two different development kits. So there's the Android SDK and Android NDK. The SDK, which is based on Java and Kotlin programming languages, well, this is developed for developing apps. The NDK, or Native Development Kit, is a C development kit used for developing binary libraries that can directly access lower-level APIs. So it's possible to develop C and C++ apps using the Android Native Development Kit. Now, the most obvious downside of native apps is that they target only one specific platform, right? To build the same app for both Android and iOS, one needs to maintain two independent code bases, or maybe introduce often complex development tools to port a single code base to two different platforms. It's up to you. Web apps. So mobile web apps are websites designed to look and feel like a native app. These apps run on top of a device's browser and are usually developed in HTML5, much more like a modern web page. Launcher icons may be created to parallel the same feel of accessing a native app. However, these icons are essentially the same as a browser bookmark, simply opening the default web browser to load the referenced web page. The biggest advantage is reduced development and maintenance costs associated with a single code base, as well as enabling developers to distribute updates without engaging the platform's specific app stores. Hybrid apps. So hybrid apps work across multiple platforms and behave like native apps. So a hybrid app is essentially a combination of a native app and a web app, although this type of app can be installed on a device like a native app. It technically is a web app. These types of apps run in an embedded web browser, commonly called WebView, and these are built with HTML, CSS, or JavaScript and run in a web view. So here's certainly not an exhaustive list of more popular frameworks for developing hybrid apps. You may be aware of some of them. There's Apache Cordova, React Native, Iconic, jQuery Mobile, Google Flutter, Framework 7, NativeScript. So now we get into progressive web apps, or PWA. Well, these load like regular web pages, but they differ from usual web apps in several different ways, actually. For example, it's possible to work offline, and access mobile device hardware is possible. Usually, or traditionally, it's only available to native mobile apps, right? But they're built using common web technologies, including HTML, CSS, and JavaScript. Progressive just means that it works for every user, regardless of browser choice, using progressive enhancement principles. So PWAs combine different open standards of the web offered by modern browsers to provide benefits of rich mobile experiences. A web app manifest, which is a simple JSON file, can be used to configure the behavior of the app after installation. And it will specify the name of the web application, links to the web app icons or image objects, the preferred URL to launch or open the web app configuration data, the default orientation of the web app, as well as the option to set the display mode, for example, the full screen. Welcome to Java World. Java is one of the best choices as a programming language because Java is a fast, efficient, secure, easy to learn, and fun programming language. Now, Java is used to create desktop applications, web applications, enterprise applications, mobile applications, computer games, embedded systems, smart cards, scientific applications, and almost anything else you can think of. There are lots of applications and websites that just won't work unless you have Java installed, and more are created every day. And pretty soon, they'll be created by you. From notebooks to data centers, mobile phones to tablets, game consoles, scientific computers, cell phones to the internet, Java is everywhere. In this course, not only will you learn the Java fundamentals in detail, you'll also get a whole lot of practice with a whole lot of exercises and projects. So let's start with this section, we're going to learn about the technology that's behind Java. We'll learn what is Java programming language. And then we'll be learning what is the Java Development Kit, or JDK, Java Runtime Environment, JRE, and Java Virtual Machine, or JVM. So let's take a look and see just what is Java and the Java platform. So as I said before, Java is a programming language, and it's a computing platform for application development. It was first released by Sun Microsystem in 1995, and then it was later acquired by Oracle Corporation. And now it's pretty much one of the most used and popular programming languages. Java Platform is a collection of programs that help to develop and run programs written in the Java programming language. Java Platform includes an execution engine, a compiler, as well as a set of libraries. So that means that Java is a language that is platform independent. So it's not specific to any processor or operating system. It is intended to let application developers write once and run anywhere. Okay? So that means basically that a compiled Java code can run on all platforms that support Java without the need for recompilation. For example, you can write and compile a Java program on Unix and run it on Microsoft Windows, Macintosh, or a Unix machine without any modifications to that source code. Write once, run anywhere is achieved by compiling a Java program into an intermediate language called bytecode. The format of bytecode is platform independent. Java is an object-oriented language. So in Java, everything is an object. Now, since it's based on the object model, Java can be easily extended. Java is designed to be easy to learn, and if you understand the basic concept of object-oriented programming, it'll be easy to master. So we're going to cover object-oriented programming concepts in the following lectures. All right, so let's have a look at what is JDK, JRE, and JVM. So the Java Development Kit, or JDK, is a software development environment which is used to develop Java applications. So that means this package includes all the tools that you'll need to develop with Java. If you want to develop and run the applications, you are required to set up JDK on your machine. It'll contain Java Runtime Environment as well as the development tools. So the development tools are compilers, like Java Debugger, etc. Java Runtime Environment, JRE, is a software package which bundles the libraries and the Java Virtual Machine, as well as other components to run applications written in the Java language. The JRE is the runtime portion of Java software, which is all you need to run it in your web browser. It contains Java Virtual Machine, or JVM, and libraries. Java Virtual Machine is the virtual machine that runs the Java programs. So when you run the Java program, Java compiler first compiles your Java code to bytecode, and then you get this bytecode by compiling the .java files into .class files. The .class files contain the bytecodes understood by the JVM. So just briefly, if you are a Java programmer, you will need JDK to develop and run the applications, and this package will include JRE and JVM as well. But if you're just a normal user who likes to play online games or run only the programs that are written in the Java language, then you'll only need the JRE, and this package will not have the JDK in it. Installing Java on Windows is very easy. We will use the latest version of Java, which is JDK 11. So this video was prepared for Windows 10, but it's not important which version of Windows you have in order to install Java. Don't worry, because the settings are all the same. So now go to your favorite search engine, which is Google, and search Java JDK 11. And in the search results page, choose the first link, and you'll see the Java Standard Edition Development Kit 11 downloads page on the Oracle site. Now, there are a lot of download links on this page. So my system is a 64-bit operating system, and if you know your operating system type, you can choose the .exe version that will best suit you. If you don't know your operating system, you don't know whether it's 32 or 64-bit, just click the search button on your desktop and write device specifications into the search box, and you'll see your operating system type in the system type section. Okay, so let's go back, and we've returned to the installation page. Now we have to choose Accept License Agreement as our option to start the download. And of course, we choose the .exe version of Java for Windows operating system. And there it goes, the download starting. So it takes a little while according to whatever network speed you're working with. But now, as if magically, the download has been completed. So open this file, and we are now ready to install the JDK 11 on, my system. Hopefully you're following along and you're ready to do it with your system. Otherwise, just pause the video and I'll wait for you. All right, so click this button, Next, and click the next button again. Installing Java on the system, it takes a while according to not only your network, but your system performance as well. Okay, yes. Java JDK 11 is now successfully installed in the system, and we can go ahead and click that close button. All right, so after installation of Java, we have got to set up the environment variable. So in order to do this, open up the control panel and then choose System and Security section and click on System. Now, do you see that on the left-hand side, click Advanced System Settings, and then click the option Environment Variables. Now, on the System Variables, select the Path option. Now, just double-check to be sure that the Path option is the one in System Variables, and then click on the Edit button. Okay, so now we have to add Java JDK location into our system. So for that, search PC, and then open the C drive and choose Program Files, the Java folder, and JDK 11, and go to the bin folder. All right, so now copy this path from the address bar and return to the environment variable page and click New. Okay, good. So paste the path to this location and click OK. And all of these pages, and then close all of them. Now open up the command prompt to check and write Java-version on the command prompt. And if everything goes right, you will see the last version of Java. Congratulations, your screen looks like this, right? Now, in order to install Java JDK 11, which is the latest LTS version, first, we have to add its package repository. So let's write sudo add apt repository ppa : Linux uprising / Java as the command on the command line. Now, when you add the repository, you'll see a message. So press Enter to continue, and then update your package list. And then on the command line, write sudo apt update. And then after the package list updates, we will install Java 11. So now write sudo apt install oracle-java 11-installer on the command line. And then your system will download the JDK from Oracle and then ask you to accept the license agreement. So, of course, you're going to accept the license agreement, and JDK will be installed. Okay, great. Now, let's look at how to select which version of Java you're going to want to use. So you can have multiple Java installations on one server. You can configure which version is the default for use on the command line by using the update alternatives command. So, write sudo update-alternatives --config Java on the command line. And now you can see all the installed versions of Java as a result. So now choose the number associated with the Java version to use it as default, or you can always press Enter to leave the current settings in place. Now you can do this for the other Java commands, such as the compiler, javac. So write sudo update-alternatives -config javac, or javac if you want, on the command line. So this command shows each installation of Java along with its installation path. So copy the path from your installation, then open /etc/environment by using Vim or your favorite text editor. And in Vim Editor, press the I key to pass the insert mode. And then go to the end of this file and add a line and pass the Java path to this line. So modifying this file will set the Java_home path for all users on your system. And now you can hit the escape key and type :WQ to save the file and quit the editor. Now, reload this file to apply the changes to your current session. And write source/etc environment on the command line. So let's check if the Java home is set properly. First, we'll execute the echo command again, and you will see the Java path. So now write on the command line Java --version. And if everything goes right, you now see the last version of Java. Congratulations are in order. So open up the terminal and check whether the Java JDK is installed or not on your system. Java -version is the command that shows the installed version of Java on our system. The terminal says, "No Java runtime present. Requesting install." And then the following message pops up automatically. So now we can click on the More Info button to visit the JDK download website. And on this page, just click on the download button. On the download page, if you scroll down, you can see macOS versions of Java. And now just choose Accept License Agreement as our option to start the download, and choose the .dmg file for the Mac operating system. And sure enough, the download's starting. And again, it's going to take a little while according to your network speed. All right, so now that the download has been completed, we can double-click to open this file. And please wait a moment while the DMG file is opening. And yeah, so now we're ready to install JDK 11 on our Mac OS. So just double-click on the icon to install Java Development Kit, and then click the Continue button on the Welcome page, and then click the Install button. So Mac OS X asks you to enter a password to go on and click Install Software. So now the installation is starting. And it takes a while according to your system performance. But sure enough, yes indeed, we can now verify that Java JDK 11 has been successfully installed on the system. So we can go ahead and click the Close button. All right, so now go back to the terminal and enter java-version as our command. And sure enough, you see that Java JDK 11. So after the installation of Java, we have got to set the environment variable Java_home, right? So execute the echo command to check to make sure that the Java home is already set or not. Sometimes it is. If the output is empty, then we do indeed need to set the Java home variable. So pretty much the best way to find out if the Java home directory is using an executable called Java home, it is located in the library executable directory, or libexec. So the output of this executable is our Java home directory. So let's go ahead and add this path to the bash profile file to be valid for all the users on our system. Well, on your system, on both of our systems. So we need to open the bash profile in the Vim editor. Now also you can use any other editor to open this file. The bash profile is just a file which is in the home directory, and its name starts with a dot. Type vim.-profile. Then just copy the Java home command full file path and hit enter. And now we can use the export command to create an environment variable and set the home path of the Java JDK. So in Vim editor, press the I key to pass the insert mode. And let's write the export code, and in between the $sign and parentheses, we'll paste the Java home path. And now assign this result to the variable Java home. Right, so hit the escape key and type :WQ to save the file and quit the editor. All right, so let's close the terminal and open it up again to apply the changes. So let's check to see that the Java home is set properly. Execute the echo command again. And there you have it. We have now set the JDK path by adding it to the bash profile file on Mac OS. Development environment. So in this section, we're going to learn about the Java development environment. So first, we're going to learn what integrated development environments are. Then, we're going to download and run Eclipse. Then we're going to write our first Java program by using Eclipse. Then we're going to learn how to compile and run Java programs. And then we're going to review our first Java program and pop the cork on champagne and congratulate ourselves for doing a great job. Well, the champagne's on you. So let's take a close look at what is the integrated development environment, or better known as IDE. So IDE is a software application that combines all of the features and tools needed by you, the software developer. A developer may debug, run, and test applications with IDE because it provides a useful debugging and testing feature set. IDE helps us in quickly navigating to a particular type without needing to worry about our projects. It also provides auto-completion. That means that whenever you type part of a function or class name and then press a shortcut combination, the rest of the name is automatically typed for you. So all these features are a great reason for you to prefer an IDE. The most popular and pretty much the best known IDEs for Java are Eclipse, NetBeans, and IntelliJ. So in this course, I'm going to side with Eclipse. So what I'll do is I'll introduce Eclipse to you, and then I'm going to write some Java programs on Eclipse throughout this course. Download and run Eclipse. Eclipse is famous for Java Integrated Development Environment, IDE. Eclipse is powerful, and it's an advanced text editor with a lot of plugins and tools. With Eclipse, you can write your Java programs much faster and execute them with just the push of a button. Also, the plugin architecture gives you the ability to constantly add to the development tools you need. Also, there are lots of features in Eclipse. If you want to learn more, just check out the official Eclipse help documents. Because, this isn't a course just about Eclipse. So installing Eclipse is pretty easy. If you don't have Java JDK installed on your computer already, first, please take a moment and do it. So now we're going to install Eclipse on the Windows operating system. So if you're a Linux or Mac user, don't worry about it because there's not going to be that much that's different or difficult. And you can follow similar instructions on the Eclipse website to install Eclipse on Linux or Mac as well. So now go to whatever your favorite search engine, Google, is, and search Eclipse. And on that result page, choose the download link. Now on this page, we choose the proper link according to our particular operating system and type. Right, so my system type is Windows 64-bit, so I'm choosing download 64-bit. Now, if your system is 32-bit, you're just going to have to download the 32-bit version. Now, on this page, we'll just choose download again. And sure enough, the download is starting. And of course, it's going to take a while according to your network speed, but I can fast forward. So we've downloaded the Eclipse installer. Eclipse installer, a new and more efficient way to install Eclipse. It is a proper installer, so that means there's no zip files, with a self-extracting download that leads you through the installation process. Bada boom, bada bing. So once the download is finished, just open up the file and start the Eclipse installer executable. Now you may or may not get a security warning to run the file. If the Eclipse Foundation is the publisher, you are good to go and select Run. And the new Eclipse installer shows the packages available to Eclipse users. So we can search for the package that you want to install, or you can scroll through the list. But I know what we want, so we're going to choose Eclipse IDE for Java developers from the list. Now specify the folder where we want Eclipse to be installed. The default folder will be in our user directory. And then we select the Install button to begin the installation. So it takes a while, of course, according to network speed, system performance. But in the installation process, the installation has created a window with the title, "Do you trust these certificates?" So select the certificate in the window and then press Accept Selected in order to move on. All right, so once the installation is complete, we can now launch Eclipse. So now we have to choose a workspace for our projects. A workspace is pretty much a folder on your hard drive where Eclipse stores your Java projects. So I'll advise you to create a folder named Java Projects on your disk. And I'll choose this folder in my user folder. And then during this course, our projects and source files will be stored in this particular workspace. So that's it. We have now successfully installed Eclipse on the system. So you're going to see a welcome screen with links to guides and help materials. You may wish to read some of them or just close the screen for now, because I'm going to show you a couple of things. But before closing, if you don't want to see the welcome screen at the startup, just uncheck right here, always show welcome at startup. Okay, so now you can close the welcome screen. Now, do you see the Package Explorer on the left side of the screen? The Package Explorer view allows you to browse the structure of your projects, and it allows you to open the files in an editor with just double-clicking on the file. So you see this empty area here? This is your code area. That's where we're going to write Java codes. The Problems view shows errors and warning messages. And we can just go ahead and close the other views for now. Now, let's customize our Eclipse by adding some views. So first I want to add Console view via Window, Show View, Console. The console is used to display program output. And of course, I want to add a Project Explorer view via the Window, Show View, Project Explorer. The Project Explorer view allows you to browse and modify files of Eclipse projects. And any change in the Project Explorer is directly applied to the files. For example, if you rename a file, the file system is directly changed. Now, Eclipse has typical menus on the menu bar. These menus are File menu, Edit menu, Navigate menu, Search menu, Project menu, Run menu, Window menu, and Help menu. So we will use Eclipse in our exercises because it's simple and we don't need to worry about professional editors' configurations. We just want to focus on learning Java for now, right? So yes, now get ready because we are ready to write our first Java program. So let's launch Eclipse from the desktop shortcut or your favorite Java development editor. And then choose a path for the workspace. I'll choose the default path. And sometimes you have to wait while Eclipse is being opened. Hello World will be our first program. Now, of course, it's the tradition in the programming world to create a small program which writes Hello World as the phrase to the console. So in order to create a Java project, please choose the File menu and New, and then choose Java Project, and then enter the project name. My first Java project. All right, so you can use the default location or select the other location. If you have multiple versions of Java runtime environment, you can always choose the JRE that your project is targeting. And by default, the newest JRE will be selected. So we choose the first option. There's no need to change any of the other options. And then click Next on the screen. And in fact, uncheck Create Module Info.java file. And then click the Finish button. And yeah, our new project was created in the Project Explorer view. So after that, from the source folder, SRC, on the Project Explorer pane on the left side of the Eclipse IDE, just right-click on it to show the contextual menu and choose the menu item New and Class. So now on this screen, enter Hello World as a package name. So package can be thought of as a folder, and the package name starts with the lowercase letters. So let's give Hello World as our name for the new class, and also check the box Public Static Void Main. And what that does is it lets Eclipse create a main method, and then we can click the Finish button. So now you see the Hello World class with package in the Project Explorer view. And also you'll see a comment line on the code area to do auto-generated method stub. Told you it was a language. So this is the Eclipse code template that is automatically created. Now, if we don't like this template, we can change the templates via the Window, Preferences, Java, Code Style, and Code Templates. Select Code and Method Body, and then just press Edit to edit the template. And then remove the To Do comment. Then press Apply and Close, and let's see what we get. So let's change the code of the helloworld.java file to the following code. System.out.println. Inside double quotes, hello world. And what this method does is it prints the contents inside the double quotes into the console and inserts a new line after. Now, in Java, it is necessary to add a semicolon at the end of the statement. And yeah, that's all. To execute the Java Hello World program, right-click on your program file and choose Run As, Java Application. And if everything's correct, you're going to see Hello World in the console window just like that. Congratulations, we did our first Java program. Okay, so let's understand how our Java Hello World source file was compiled and then executed. First, we wrote the Java source code in the helloworld.java file using Eclipse IDE. Then the program has to be compiled into bytecode. The Java compiler compiles the source code and then generates the helloworld.class file. And then this class file can be executed in any platform or operating system by Java Virtual Machine. I love it. So Java Virtual Machine translates bytecode into native machine code, which machines can then execute. Oh, also let me mention that library code is executed by the Java Virtual Machine. We have understood how to run a Java program. Why don't we take a closer look at the program that we've written? The Hello World application consists of two primary components. First, the Hello World class definition and the main method. Public class Hello World is the first line of our Java program. Every Java application must have at least one class definition that consists of the class keyword followed by the class name. And the code for each class appears between the opening and closing curly braces. Now, we will discuss the subject of classes in further detail in some of the upcoming lectures, but right now, it's just enough to know that every Java application begins with a class definition. Public static void main string args, or arguments. So this is our next line in the program. In the Java programming language, every application must contain a main method whose signature is, well, just like that. Also, we'll cover how to define a method in Java in the next upcoming lectures. And then finally, the line system.out.println hello world. So the print method prints the contents inside the double quotes into the console and inserts a new line after. So it uses the system class from the core library of Java. Now, don't worry if you don't get it at first. We're going to learn a whole lot more about classes and methods in the next lectures. Course outline. So why don't we have a closer look at the main Java subjects that we're going to learn in this particular course. First of all, of course, we will introduce the basics of Java syntax. So we're going to learn what are variables, data types, operators, and a few other subjects. Then we're going to cover control flow statements that include decision-making statements, looping statements, as well as branching statements. Then we're going to be using methods. So in that section, we will learn just how to declare and call methods. We'll also work on method return types and method overloading with lots of exercises. The next topic is the introduction part of object-oriented programming. It's a concept that includes class, object, access modifiers, naming conventions, constructors, packages, as well as a few other subjects. Then, we're going to cover the most important topic of Java, and that is object-oriented programming. So in that section, we will work on inheritance, abstract classes, interfaces, polymorphism, encapsulation, and other subjects with real-life examples. And then we will learn about strings, wrapper classes, autoboxing and unboxing subjects in Java. In that section, we're going to work on what string is and also creating string objects. Also, we'll practice on useful methods of string class. Also, we will introduce the wrapper classes in Java. We're going to learn what a wrapper class is, as well as conversion of types. And I think you're going to really enjoy working on autoboxing as well as unboxing subjects with examples. Then we're going to learn about exception handling as a concept. So in that section, we will try to understand how to handle exceptions in Java. We'll also introduce types of exceptions and useful exception methods. And then we'll introduce the Java desktop application design, and that is called Java Swing. So in that section, we will learn basic Swing components by doing examples. And then finally, we'll introduce enum types in Java. So in that section, we will learn how to declare an enum type. We'll also work on key points of enum types, and we'll do some code exercises using enum types. Are you ready? Let's get started. Variables. Now we're starting main fundamentals of Java programming language. So one of them is variables. In this section, we'll first learn what a variable is. Then we'll learn how to declare and initialize variables. And then once we get that, we'll be learning different types of variables, instance variables, static variables, as well as local variables. Then we'll get used to working with Java keywords. So first, like I said, we're going to start with the question, what is a variable? So a variable, it can be thought of as a container or a box which holds value for you, right, during the life of a particular Java program. So it means that when you create a variable, you basically reserve some space in memory. Every variable is assigned a data type, and it holds quantity of value. So here we have two steps to use a variable in a program. They're called declaration and initialization. In order to declare a variable, you must specify the data type and give a unique name to the variable. So in our example, we declare the variable age with int data type. And of course, we're going to cover data types in the next slides, but just stay with me. So in order to initialize a variable, you must assign it a valid value according to its data type. So here we use the equation sign. It means that value in the right side will be saved into the variable on the left side. So in our example, we'll assign value 37 to a variable age. Now, in order to declare more than one variable, use a comma to separate identifiers. Java programming language has rules and conventions for naming variables. So while declaring variables, please note that Java is a case-sensitive programming language, which means that the upper or lower case of letters in your Java programs matter. So the variable age that consists of all lowercase is different from the variable age that consists of first capital letter and the rest lowercase. So a variable name can begin with a letter, a $sign, or underline mark. Now, if you declare a one-word variable name, go ahead and use all lowercase letters. It's not mandatory, but it helps keep things organized. And if you declare a variable name having more than one word, use all lowercase letters for the first word and then capitalize the first letter of another word. Now let's look at different types of variables. We have three types of variables in Java. First one is instance variables. So instance variables are defined in a class, but outside of a method declaration. They're also defined without the static keyword. So then guess what the second one is? It's static variables. Static variables are initialized only once at the start of the program execution. These variables should be initialized first, before the initialization of any instance variables. Also, they're defined in a class, but outside a method declaration. We'll cover some static keywords in detail in the next coming slides. And then the last one is local variables. Local variables are declared inside the body of a method. So that's just an introduction. Don't worry, we're going to cover methods as its own subject in greater detail in some of the upcoming slides. Java keywords. Now, as in every other programming language, Java has some reserved words, and these are called keywords. We cannot use them as names for variables, methods, classes, or as any other identifier. Now you can see Java keywords on the table here. Each keyword has a specific meaning in the language. So we're going to practice with these keywords in the next exercises. So you ready? Let's start coding. So why don't we start with variable examples? So first, let's create a new Java project. And specify the project name as exercise. And let's not change any of the other options and just click on the Next button. So in this section, uncheck Create Module Info.java file option, and then press the Finish button. Okay, so in this project, right-click on the source folder and then select New Class. Okay, so specify the package name as variable and the class name as variable, and then select the checkbox to add a main method. Then just click on the Finish button, and then Eclipse will generate a Java class. Okay, so now we're getting somewhere. Now we can start coding. So let's declare 3 variables with the int type. First up, A, and assign 10. Second, B, and assign 20. And last, C, and assign A plus B. So now let's print variable C on the screen by using the print method. Eclipse actually has a quick shortcut for you to write this method. So type sysso, then hit Control space in combination from the keyboard. So this is named as code completion. All right, so it allows us to quickly complete statements in our code. We can use this key combination in all the other parts of the program, such as variables and methods and classes and wherever you are. Okay, so let's run the code now. So right-click on variable.java and select from the contextual menu Run as Java Application. And then the result will print result equals 30 in the console. So also we can define variables that are separated by commas. So let's run the code again using a shortcut. And the result is the same. Also, we can directly write A plus B to the output. But herein lies a problem. Compiler considers a statement as a string and concatenates them. So in order to solve this problem, we must use A plus B between parentheses. All right? So let's run it again. Now the result is correct. See that? So let's have a look at some naming rules for variables. We will study the variable age. Int age is valid. Int underscore age is valid. Int $mark age is valid. Int age3 is valid. But int a space GE is invalid. And 3age is invalid because variable names cannot use spaces, and a variable name cannot begin with a digit. Also, we cannot use Java keywords as a variable name, so int break is invalid because break is a keyword. Int do is also invalid because do is a keyword, and int public is invalid because public is a keyword. Don't worry, you'll get to know your keywords. Java Basic Output. So in this section, you're going to learn some simple ways to display output. We can simply use system.out.print, parentheses, system.out.printin, parentheses, or system.out.print F parentheses to send the output to a screen. But first, let's learn the features of these output methods and why you'd use one over another. Print is the method that prints a string inside the quotes. Print in is a method that prints a string inside quotes similar to the print method. However, after printing, the cursor goes to the beginning of the next line. The printf method provides string formatting. In the exercise project, right-click on the source folder and select New, Class. Specify the package name as Input Output and the class name as Basic Output, and then select the checkbox for the main method. So the first message is, Welcome to Java Programming, by using the print method. Now here, print is a method that displays the string inside the quotes, right? So let's run the code. Okay, the result is true. Now we can copy-paste a line into a new line in Eclipse without having to highlight the entire line. We can use the key commands Control-Alt-Down arrow for this, and it's perfect. Also, we can concatenate the strings by using a plus sign as the operator. So the first string is welcome to, and the plus operator, and the second string is Java programming. So let's run that code. Okay, the result is the same. Now let's copy with these new lines and change text like that. Now here we have two print-in methods and two print methods. Okay, so let's run the code. Now you can see the result. After print-in methods, the cursor moves to a new line. But after print methods, cursor remains on the same line. So why don't we look at the printf method, and we'll define three variables. First, int x and assign 5. Second, int y and assign 3. And last, int z and assign x plus y. So in the printf method, we'll use the %mark with the D character. That represents a decimal integer. So let's run the code and show the output. Java basic input. Now there are several ways to get input from the user in Java. So in this section, we're going to learn just how to get the input by using the scanner object. Now, in order to use the scanner class, first, we're going to need to import the scanner class by using import.java.util.scanner. Now, don't worry if you don't quite understand it yet. We're going to learn more about classes and how to import them in the next lectures. But stay with me. Then we're going to create an object of the scanner class. Then the next int method of the scanner class is used to get integer input from the user. And we'll assign this input to a variable number. And then finally, we'll display that number on the screen by the print method. I know you can handle it. Let's do it. So let's do some examples by using the scanner class. So go to the exercise project, right-click on Input-Output package, and select New, Class, and specify the class name as Basic Input, and select the checkbox for the main method. Okay, so let's look at the Java input. So we will use the scanner class for getting input from the user in Java. First, we need to import scanner class. And if you just place your mouse or hover over the scanner word, do you see the import options are shown? So, of course, we'll choose Import Scanner Class in Java.util package to import the scanner class. Excellent, excellent. So now we've got a message to enter a number by using the print method. So we can declare a variable number with int type and assign next int as the method of scanner class to this number. And we show the value of number by using the print method. Then finally, we should close the scanner object by using the close method. Okay, so let's run the code. In the console screen, we enter 5, and it shows that you've entered 5. So now there's no need to assign the next int method to a new variable. We can directly use the input number.nextInt method in the print method. So let's run that code, and yes, the result is the same. Also, we can get a string input from the user. String is a series of characters. Okay, so let's change the code. For a string input, we'll use next as our method of scanner. And we declare a variable text and assign next as a method of scanner class to this text. Okay, so now let's run the code again. And in the console screen, we enter Java, and it shows you entered Java. So there's no need to assign next as a method to a new variable because we can directly use the input text.next method in the print method. Okay, you got that? So let's just run the code again, and you'll see here that the result is the same. Java comments. Now, in this section, you're going to learn about Java comments and why and how to use them. The comments can be used to provide information or by way of explanation about any statement, variable, method, and class. Now, please note that comments should contain only relevant information to read and understand the program, no Easter eggs. Writing comments is a really good practice, and it will help others to understand what our code is. It will also help us when we return later to our own code and have to rewrite something. The comments can also be used to hide program code in some cases. They are completely ignored by the Java compilers. But basically, I'll tell you that there are two different types of comments in Java: single-line comment and multi-line comment. What, you thought it was going to be the name of a blockbuster movie or something? So the single-line comment is used to comment only on, check it out, one line. It starts with a double slash symbol. Okay, very important. The compiler ignores everything from double slash to the end of the line. So this, of course, is the easiest type of comment. The multi-line comment is used to comment on multiple lines of code. It starts with a slash and asterisk and ends with an asterisk and a slash. So that way the compiler ignores everything between a slash, asterisk, and asterisk, slash. Say that 3 times fast. All right, so go back to the exercise project, right-click on the source folder, and then select New Class. Specify a package name as comment and the class name as comment, and then select the checkbox to add it to the main method. First message is, Welcome to Java, by using print line. So let's run the code. You see Welcome to Java as a text in the console. So now let's add 2 single-line comments above the printin method. What do we use? Double slash to add a single comment. And then let's run the code again. See how the compiler ignores these comments? Also, Eclipse has a quick shortcut for you to add a single line. You can just use Control plus 7 as the key combination from your keyboard. If you use this combination on the code line, Eclipse automatically adds double slash at the beginning of the line. Now, if you do use this key combination on the same line again, then Eclipse removes comment marks. So let's add a multi-line comment above the main method. To do that, we'll use multi-line comment between slash and asterisk and slash. And let's run the code again, and the result is the same. So we can add multi-line comments to a code block. First, let's declare 3 variables with int type. First, A, and assign 5. Second, B, and assign 2. And last, sum, with initial value is 0 and assign A plus B to sum. Right, so now let's print the variable sum on the screen by using the print method. All right? Okay, good. So let's run the code. Now, if we want to add multi-line comments to a code block, first we'll put slash and asterisk, and then also at the end of the code block. So let's run the code. So you see that only Welcome to Java is our text because compiler ignores the comments block. So that pretty much covers it. I certainly think that we don't need to go into greater detail. That pretty much covers comments in Java clearly. In this section, we will learn data types. Data type defines the values that a variable can take. Based on the data type of a variable, the operating system allocates memory and decides what can be stored in the reserved memory. Therefore, by assigning different data types to variables, you can store integers, decimals, or characters in these variables. In Java, we need to define the data type of a variable to use it, and you cannot assign incompatible data types. Otherwise, the compiler will give you an error. So let's have a look at this diagram. There are two data types available in Java. First one is primitive, and the second one is non-primitive data types. Non-primitive data types are also called reference data types. Class, interface, string, enum type, and array are non-primitive data types, and we'll discuss them in the upcoming lectures. Here we'll discuss the primitive data types and literals in Java. Primitive data types are predefined by Java programming language, and they're named by a reserved keyword. Java provides 8 primitive data types. These are Boolean, char, byte, short, int, long, float, and double. Primitive data are only single values. They have no special capabilities. Byte, short, int, and long data types are used for storing whole numbers. Float and double are used for fractional numbers. Char is used for storing characters. Boolean is the data type used for variables that holds either true or false. Now, looking at this slide, you see Java data types in the table. Byte. The byte data type is an 8-bit signed 2's complement integer. The byte data type is useful for saving memory in large arrays. It has a minimum value of -128 and a maximum value of 127 inclusively. The default value of byte is 0. Short. The short data type is a 16-bit signed 2's complement integer. Similar to byte, uses short to save memory in large arrays, especially in situations where memory savings actually matters. It has a minimum value of -32,768 and a maximum value of 32,767 inclusively. It also has a default value of 0. Int. The int data type is a 32-bit signed 2's complement integer, which has a minimum value of -2 to the 31st and a maximum value of 2 to the 31st minus 1. Long. The long data type is a 64-bit 2's complement integer. The signed long has a minimum value of -2 to the 63rd and a maximum value of 2 to the 63rd minus 1. And you can use this data type when you need a range of values wider than those that are provided by int. Float. The float data type is a single precision 32-bit floating point. If you need to save memory in large arrays of floating point numbers, you should use a float instead of double, which is double. The double data type is a double precision 64-bit floating point. For decimal values, this data type is generally the default choice. Boolean. The Boolean data type represents only one bit of information, either true or false. char. The char data type is a single 16-bit Unicode character. So why don't we do some examples with data types? So in the exercise project, right-click on the source folder and select New, Class. Specify the package name as data type and the class name as data type, and then select the checkbox to add main method. Now let's start with data type. Boolean A equals true. The Boolean type, of course, has two possible values, either true or false. Char B equals capital R. So the char type declares a character. Okay. Byte C equals 12. Remember, byte type can have values from -128 to 127. Short D equals -356. The short type can have values from -32,767 and 32,767. Int E equals 43,543. So the int type is generally used for numeric values. So now let's declare variable f with a long data type. The long type is used for large values. So capital L is a specific suffix for the long type. Another variable G with float as the data type. Remember that the float type is used for large values with single precision, and a capital F is the specific suffix for the float type. Another variable, H, with the double data type. So the double data type is used for large values with double precision. Okay? So now let's print the values of these variables on the screen by using the print method, which we know so well. And for that, we can use Control, Alt, down arrow as our keyboard shortcut combination to copy the print method. Okay, so now let's change the variable name from A to H. All right, good. Let's run the code. And look at that, you see the results in the console. Stack and heap. So stack and heap are used for allocating memory in Java. So in this section, we will completely understand how they work and when to use them for developing better Java programs. So basically, local variables, methods, primitive data types, and references of objects are all stored in a stack space of memory. Whenever a method is invoked, a new block is created in the stack memory for the method to hold local primitive values and reference to other objects in the method. Objects and reference types are stored in heap. So whenever we create any object, it's always created in the heap space of memory, and stack memory contains the reference to it. All right? So we're going to cover heap memory on the next few slides. I just want to make sure that you understand the difference. Stack memory size is much less compared to heap memory size. So if you know exactly how much data you need to allocate before compile time, and this data is not, too big, you should pretty much use stack. If you don't know exactly how much data you're going to need to allocate at runtime, or If you need to allocate just lots and lots of data, you should then, of course, use heap. So in this section, you'll learn how to work with arrays in Java. You're going to learn how to declare, instantiate, initialize, and access array elements. So what's an array? It's a container object that holds a fixed number of values of a single type. For instance, you can create an array that can hold 200 values of int type. Okay, so let's have a look at how to declare an array in Java. The array syntax is data type, square brackets, array name, or data type, array name, square brackets. Both are valid declarations. Data type can be primitive data like int, char, float, double, byte, etc. Array name is an identifier just like a variable. So in our example of an array declaration, int square brackets age means that age is an array that can hold int values. But how many elements can an array hold? So we defined in the initialization part of the slide, we allocate memory for array elements. So in our example, the length of the age array is 7. It means that it can hold 7 elements. The important point here is, after the creation of an array, the length is fixed. So what does that mean? It can't be changed in the program. Each item in an array is called an element. And each element is accessed by its numerical index. So shown here in the slide, index begins with 0. The 5th element, for example, would therefore be accessed at index 4. Initializing array values. So in Java, we can initialize arrays during declaration, or we can initialize later in the program. So in our example, this statement creates an age array and initializes it during declaration. The length of an array is determined by the number values provided, which is separated by a comma. The length of the age array is 7. Also, we can easily access and alter array elements by using a numeric index. And here in our example, we alter 2 values of age array at index 0 and at index 3. And new array values are located in the new area. Okay, so let's try to understand Java arrays with a few examples. That's my favorite method. So in the exercise project, right-click on the source folder and select New and Class. Specify package name as Array and the class name as Array, and select the checkbox to add main method. Right, so let's declare an int array, and its name is numbers. Size of numbers array is 4. And what does that mean? It can hold 4 numbers. So let's assign values to the elements of the array. So the first element of an array, and assign 4. Second element, assign 6. Third element, assign -3. And then the last element, assign it as -2. All right, so let's calculate the sum of array values. So now declare the variable sum with the int type, and assign array elements by adding an index. Now let's print the sum of array values by using the print method. Okay, so let's run the code. And we see sum equals 5 in the console. So there's no need to assign a new variable. We can use elements of an array directly between parentheses in the print method. All right, so let's run the code again, and there we go. We see the same result. So now let's try to add an element with a fourth index. So let's run the code, and we get an error. Now, if we want to add an index that is either negative or greater than or equal to the size of the array, an array index out of bounds exception is thrown. So it's thrown only at runtime. The Java compiler does not check for this error during the compilation of a program. So let's declare an int array where its name is number with initial values 4, 6, -3, -2. We alter the value of the second element of the array with a new value, 12. So let's print the new sum of the array values by using the print method. And let's run the code. So the previous sum is 5, and after altering, the new sum is 11. All right, pretty cool, huh? Operators. So now the operators are special symbols that perform specific operations such as arithmetic, logical, etc. The value that the operator operates on is called the operand. For example, in the expression x plus 4, x and 4 are operands, and plus is an operator. So in this section, first we're going to learn the arithmetic, assignment, and unary operators. Then we're going to play with equality, relational, and conditional operators. Then we're going to learn operator precedence. Arithmetic operators. The Java programming language provides operators that perform addition, subtraction, multiplication, division, and remainder. So these are basic mathematical operations that you probably know and can do in your head. Plus is an additive operator. It adds two operands. Minus is a subtraction operator. It subtracts the right operand from the left. Asterisk is a multiplication operator. It multiplies two operands. / is a division operator. It divides the left operand by the right one. The type of division result is float by default. Now percent is a remainder operator. So this symbol might look new to you. It divides one operand by another and returns the remainder as its result. Okay, so let's try to understand Java operators with examples. So in the exercise project, right-click on the source folder and then select New and Class. Specify package name as Operator and the class name as Arithmetic Operator, and then select the checkbox to add main method. All right, so now let's declare 3 variables with the double type. First, number 1, and assign 8.4. Okay, second, number 2, and assign 4.2. And then last, result, with the initial value 0.0. So now you want to first assign number 1 plus number 2 to the variable result. All right, so let's show the result value by using our print method. And we may run the program after all the operations. Great, so let's copy the code and change the operator to the subtraction operator. And now change the operator in the print method. All right, so let's make changes for multiplication. Good, and we'll change it for division. And finally, let's change it up again for remainder as our operator. Okay, that's all. So let's run the code. And you see the result in the console. Number 1 plus number 2 equals 12.6. Number 1 minus number 2 equals 4.2. Number 1 multiplied by number 2 equals 35.28. Number 1 divided by number 2 equals 2.0. Number 1% number 2 equals 0.0. So the remainder is 0. Assignment operators are pretty much the most common operators. An assignment operator assigns the value on the right to the operand on its left. Okay? So equal to is a simple assign operator. It assigns values from the right side operands to the left side operand. Plus and equal is an add and assignment operator. It adds the right operand to the left operand and assigns the result to the left operand. Minus and equal are subtraction and assignment operators. So it subtracts the right operand from the left operand and then assigns the result to the left operand. Asterisk and equal is a multiply and assignment operator. So it multiplies the right operand with the left operand and then assigns the result to the left operand. The / and the equal is a divide and assignment operator. So it divides the left operand with the right operand and then assigns the result to the left operand. And that leaves us with the % and equal. Now it's a modulus and assignment operator. So it takes modulus using 2 operands and then assigns the result to the left operand. So I think that'll become clear with a few examples. So let's do up some examples with assignment operators. So go back to the exercise project and right-click on the operator package and then select New Class. Specify the class name as assignment operator and then select the checkbox for the main method. Okay, so let's start to code. We're going to declare here 3 variables with the int type. So first, x and assign 20. Second, y and assign 15. And then last, z with initial value 0. Now let's assign x plus y to variable z. I know, some of you guys say z, but I say z. So this is a simple assignment operator. So let's print the result by using our print method. And we may run the program after all the operations. Now let's copy the code and change the code with z plus equals x. So now this is an add an assignment operator. It's the same as z equals z plus x. And now let's change the code with z plus equals x in the print method. Let's copy the code and change the code with z minus equals x. And then this is a subtract and assignment operator. So it's the same as z equals z minus x. Now we can change the code with z minus equals x in the print method. So let's copy the code again and change the code with z asterisk equals x. And now we have the multiply and assignment operator, which is the same as z equals z multiply x. And now we can change the code with z asterisk equals x in the print method. Now we'll copy the code again and change the code with z divide equals x. And now we have a divide and assignment operator. So it's the same as z equals z divide x. Now we can change the code with z divide equals x in the print method. Now let's copy the code and change the code with z percent and equals x. So now this is the modulus and assignment operator, and it's the same as z equals z percent x. Now we can change the code with z percent and equals x in the print method. Okay, so that's it. So let's run the code, and you can see what happens right here in the console. X plus y equals 35, so the value of z is 35. The value of x is 20, and z equals z plus x equals 55. Z equals z minus x is 35. Z equals z multiply x is 700. Z equals z divided by x is 35. Z equals z percent x is 15. And that means that the remainder is 15. Good job. Unary operators. The unary operators require only one operand. They perform various operations such as incrementing and de-incrementing a value by 1, negating an expression, or inverting the value of a Boolean. So let's have a look at these operations. Plus. This is a unary plus operator. It's used for giving positive values. It's only used when deliberately converting a negative value to a positive. Minus. This is a unary minus operator. It's used for negating the values. Plus plus. This is an increment operator. So it increments a value by 1. Minus minus. This is a decrement operator. It decrements a value by 1. Exclamation mark. So this is a logical complement operator. It inverts the value of a Boolean. So why don't we do up some examples with unary operators? In the exercise project, right-click on the operator package and select New, Class, and specify the class name as unary operator, and select the checkbox for the main method. Okay, so let's start to code. Let's declare two variables. First, the number with double type and assign 7.6. So second is check with Boolean type and assign true. So now in the first print method, we'll use a unary plus operator. So let's copy the print method by using the shortcut Control-Alt down arrow. And in the second print method, we can use unary minus as our operator. In the third print method, we'll use the increment operator. In the fourth print method, we can use the decrement operator. And in the last print method, we can use the logical complement operator. All right, so that looks right. So that's pretty much it. Let's run the code. And remember that the value of the number variable was 7.6. And as you see right here in the console, plus number equals 7.6, so there's no change. The minus number equals minus 7.6. It inverts the sign of the number variable. Plus plus number equals 8.6, so that increments the value by 1. Minus minus the number equals 7.6, so that decrements the value by 1. So not isCheck equals false. The first value of isCheck was true, and then it inverts the value of the Boolean. So in Java, we can also use plus plus and minus minus as operators for both prefix and suffix. However, there is a significant difference when using increment and decrement operators as prefix and suffix. So why don't I show you by an example? So why don't we declare the variable result with double type and assign 4.7 to it. In the first print method, we can use the increment operator as a prefix and then write result plus plus. In the second method, and we'll just write result. So in the third method, we'll use the increment operator as a suffix and write plus plus result. And in the last print method, we'll write only the result again. All right, so that's all. So let's run the code, and you see the result in the console. When the first print is executed, the original value is evaluated first. The result is increased only after that. So we got 4.7 as our output. So when the second print is executed, the increased value 5.7 is printed. However, when the third print is executed, the result is increased by 1 first before it's printed on the console. And then when the last print is executed, 6.7 is printed. Equality and relational operators. The equality and relational operators determine if one operand is greater than, less than, equal to, or not equal to another operand. So let's have a look at these operations. Equal, equal. This operator checks if the values of two operands are equal or not, and if yes, then the condition becomes true. Exclamation mark and equal. So this operator checks if the values of two operands are equal or not, and if the values are not equal, then the condition becomes true. Greater than sign. this operator checks if the value of the left operand is greater than the value of the right operand, and if yes, the condition becomes true. A less than sign. This operator checks if the value of the left operand is less than the value of the right operand, and if yes, the condition becomes true. Greater than or equal sign. This operator checks if the value of the left operand is greater than or equal to the value of the right operand, and if yes, then the condition becomes true. Less than or equal sign. This operator checks if the value of the left operand is less than or equal to the value of the right operand, and if yes, the condition becomes true. So I'll show you some examples with equality and relational operators. So go back to the exercise project and right-click on the operator package and select New Class. Specify the class name as Equality Relational Operator and select the checkbox for main method. Okay, so let's start to code. We'll declare two variables with the int type. First, A, and assign 2. Second, B, and assign 5. In the first print method, we'll use the equal to operator, A equal to B. And let's copy the print method by using shortcut Control-Alt down arrow. And in the second print method, we'll use the not equal to operator. And in parentheses, A not equal to B. Now in the third print method, we can use the greater than operator. A greater than B. And in the fourth print method, we'll use greater than or equal to as our operator. A is greater than or equal to B. And in the fifth print method, we'll use the less than operator. A less than B. And in the last print method, we can use the less than or equal to operator. A less than or equal to B. All right, that's all. So let's run the code. And what do you see in the console? A equal to B is evaluated to be false. A not equal to B is evaluated to be true. A greater than B is evaluated to be false. A greater than or equal to B is evaluated to be false. A less than B is evaluated to be true. A less than or equal to B is evaluated to be true. So why don't we change the value of the variable with a 5. So now A equals 5 and B equals 5. And let's run the code again and compare our results. A equal to B is evaluated to be true. A not equal to B is evaluated to be false. A greater than B is evaluated to be false. A greater than or equal to B is evaluated to be true. A less than B evaluated to be false. A less than or equal to B is evaluated to be true. Conditional operators. So conditional operators are used for checking multiple conditions together. So why don't we have a look and see what we can understand about conditional operators. Conditional AND operator. So this operator is represented by the symbol ampersand ampersand. Now in this operation, the result is true if both operands are true. So this operator doesn't check the second condition if the first condition is false, right? It'll check the second condition only if the first one is true. The conditional OR operator. So this operator is represented by the symbol double pipe. Now in this operation, the result is true if either of the operands is true. Does that make sense? This operator doesn't check the second condition if the first condition is true. It checks the second condition only if the first one is false. Ternary operator. This operator is represented by the symbol $?:. So this operator consists of 3 operands and is used to evaluate Boolean expressions. This operator can be thought of as a shorthand for an if-then-else statement. Now, we're going to get into that a little deeper in the control flow statements of this lesson. But first, let's make some examples with conditional operators. In the exercise project, right-click on the operator package and select New Class, and specify the name as Conditional Operator, and select the checkbox for the main method. Okay, so let's start to code. So we'll declare 3 variables with the int type. First, number 1, and assign 5. Second, number 2, and assign 8. And lastly, number 3, and assign 12. Okay, so let's declare a variable result with the Boolean type. The default value for a Boolean is false. So we'll use the conditional AND operator and assign the result to the variable result. If number 1 is greater than number 2 and number 3 is greater than number 1, then the result is true, else the result is false. Now, in order to get the result to be true in the conditional AND operator, all Boolean expressions must be true. So now let's print the result value by using the print method. Okay, so now we can run the code, and you see it in the console. Result equals false, because number 1 is not greater than number 2. So now if we use the conditional OR operator, we can assign the result to the variable result. So if number 1 is greater than number 2, or number 3 is greater than number 2, then the result is true, else the result is false. So in order to get the result to be true in the conditional OR operator, at least one expression must be true. So we'll copy the print method. Alrighty, so let's run the code. And you can see that in the console, the result equals true, because number 3 is still greater than number 2. Now let's have a look at the ternary operator. So we can use the ternary operator, and we can assign the result to the variable result. If the number is less than number 2, then the result is true, else the result is false. So let's copy the print method. Okay, we can run the code. Result equals true, because number 1 is less than number 2. All right. Operator precedence. Now, it's important to remember and to know how Java interprets the symbols you use to perform specific operations and in what order it interprets them. Otherwise, we could write a program with one result in mind and receive an entirely different result, right? So as you can see here in the table, the priority column is the most important because it defines the strict order in which Java interprets the symbols displayed in the operator column. An operator higher in the table always takes precedence over an operator that's lower in the table. Now, here's the important and key point in this part. If you want to change the order in which an expression is evaluated, you have got to use parentheses. So any part of an expression that is enclosed in parentheses is evaluated first. So let's see how that works with an example of operator precedence. In the exercise project, right-click on the operator package and select New, Class, and specify the class name as Operator Precedence, and then select the checkbox for the main method. And let's declare a variable result with the int type and assign 5 plus 2 multiply by 4. Okay, so let's print the result value by using the print method. Now we can run the code. Result is 13, not 28, because precedence of multiplication operator is higher than the additive operator. So here multiplication is performed before adding, and the result value is 13. So I'll show you another example. So let's assign in the parenthesis 5 plus 2 and multiply by 4 to the variable result. And let's copy the print method. Okay, let's run the code, and the result is 28. So here the expression enclosed in parentheses is evaluated first, and then the multiplication is done. So first, 5 plus 2 equals 7 is done, and then 7 is multiplied by 4, and the result equals 28. So let's do another example with the unary operator precedence. So why don't we declare 4 variables with the int type. First, x, and assign 8. Second, y, and assign 4. Third, z, assign 2. And the last, sum, assign 0. So let's assign x plus minus minus y plus minus minus z to the variable sum, and let's copy the print method. Okay, so let's run the code, and the result is 12, because the operator precedence of the unary operator is higher than the additive operator. Now, in this section, we will learn about Java expressions, Java statements, differences between expressions and statements, as well as Java blocks. So now that we understand the variables and operators and how they work, it's easier to learn about expressions, statements, and blocks. You may ask, why is that? Well, we might actually combine variables and operators to form expressions. That's right. Expressions are the core components of statements, and statements may be grouped into blocks. That's why it's important to stay organized, right? Expressions consist of variables as well as operators and method calls, and those evaluate to a single value. So you'll see some examples of expressions illustrated in red. So here, max speed equals 280 is an expression that returns int and data type. Int is not part of an expression. So typically, accept data type and semicolon forms an expression. Result equals 5 plus 8 is an expression, and the result is now 13. In the brackets, x plus y multiplied by 2.5 is an expression. Also, it is named a compound expression. Now, when writing compound expressions, please be careful to indicate with parentheses which operators should be evaluated first. Number 1 equals to number 2. Now, that's an expression that returns a Boolean. Similarly, equal is a string expression. All right, so let's look at statements. A statement forms a complete unit of execution. Note here, please, that it's necessary to add a semicolon at the end of a statement. Now, expressions are part of statements. So you see examples of statements in the slide. All the examples are statements, so they are illustrated in red. Okay, so finally, let's have a look at the blocks. So a block is a group of 0 or more statements that is enclosed in curly braces. And you see an example of the block in the slide. Now, there is one statement inside the block. A block may contain a whole lot of statements. Control flow statements. Now, I promised you earlier, so in this section, we're going to learn the fundamentals of Java programming language. And we're going to learn decision-making statements, such as if statements and switch case statements. Then we're going to have fun with looping statements, such as for each, while, and do while as loop statements. Then we're going to learn the branching statements, such as break, continue, and return. Decision-making statements. Decision-making structures have one or more conditions to be evaluated or tested by the program. So if you look at the diagram, it shows if some condition occurs, check the condition. If that condition is true, execute the conditional code. If the conditional is false, pass the conditional code, and then continue. Make sense? So there are two types of decision-making statements in Java. They are if statements and switch statements. If statements are used to test the condition. So it'll check the Boolean condition true or false. There are various types of if statements in Java. We can classify these statements as if statements, if-else statements, if-else if-ladder statements, and a nested if statement. So why don't we take a closer look at the if statement and the if-else statement syntax. First up, Java if statement tests the condition. If the condition is true, it executes the if block. And then secondly, the Java if-else statement also tests the condition. If the condition is true, it executes the if block. Otherwise, the else block is executed. So why don't I show you some examples of the if-else statement. So in the exercise project, right-click on the source folder and select New and Class. Specify the package name as Decision Making and the class name as if-else statement. Select the checkbox for the main method. So here we're going to use the scanner class for getting input from the user in Java. Now first, we'll need to import the scanner class. And if you hover your mouse over the scanner word, the word scanner there, see how the import options are shown? So if we choose import scanner class in java.util package to import the scanner class, we get a message to enter the number by using the print method. And we'll declare a variable number with the int type and assign next int as our method of scanner class to this number. So now let's start to write the if statement. In the if statement, we'll check the number, whether this number is even or odd. So if a number is divisible by 2, then it is even, otherwise it's odd. So we'll use a modulus operator to find the remainder. If the remainder is 0, then the number is even, right? And finally, we'll close the scanner object by using the close method. Okay, so let's go ahead and run the code. In the console screen, we'll enter 8, and 8 is an even number, so the condition is true, and codes inside the body of the if are executed. Okay, so let's run the code again. And in the console screen, let's enter 7. 7, of course, as you and I both know, is an odd number, so the condition is false. And the codes inside the body of the if are not executed. So now let's add the else statement to the code. If the condition is evaluated to be false, the else statement is executed. And we'll add the print method to include number is odd text in the else block. Okay, so let's run the code. On the console screen, we'll enter 12. And we get number is even, and that's the message from the if statement. And that's good. So let's run the code again, and we'll enter 13, and we get the number is odd, and that's the message from the else statement. All right, so I hope you feel like we're getting somewhere, because we are. Let's have a closer look now at the if, else, if ladder statement, as well as the nested if statement syntax. So first, the Java if, else, if ladder statement executes one condition from multiple statements. And then secondly, the nested if statement represents the if block within another if block. So here, the inner if block condition executes only when the outer if block condition is true. All right, so let's stop talking and do up some examples with the if ladder and nested if statements. In the exercise project, right-click on the decision-making package and select New Class. Specify the class name as If Ladder Nested If Statement, and select the checkbox for the main method. Now first, we'll need to import the scanner class for getting that input from the user, right? And we'll choose Import Scanner Class in java.util package to import the scanner class. And now we get a message to enter age by using the print method. So let's declare a variable, your age, with the int type, and assign the next int method of scanner class to this variable. Now let's start to write the if statement. If your age is less than 13, then we'll print you are a child to the output. Else, if your age is less than 19, then we will print you are a teenager to the output. If your age is greater than 19, else statement is executed, and we will print you are an adult to the output. So if all test conditions are false, the codes inside the body of the else statement is executed, right? Okay, so let's run the code. On the console screen, we enter 8, 8 being less than 13. So the first if statement is executed, and the output is you are a child. Let's run the code again, and we'll enter 15. The program checks first the if statement. 15 is less than 13, so The first if statement is not executed, right? The second if statement is checked. 15 is less than 19, so yes, this condition is true, and the statement is executed. So the output is, you are a teenager. So let's run the code again, and let's enter 45. The program checks the first if statement. 45 is greater than 13, so that condition is false. Then it checks the second if statement. 45 is greater than 19, so the condition is false. Then the else statement is executed, so the output is, you are an adult. Now let's add a nested if statement into the else statement. If your age is less than 65, then we will print, you are an adult to output. And then when we add the else statement, that means that if your age is greater than 65, we will print out, you are a senior to the output. Okay, so now let's run the code. And in the console screen, we'll enter 56. Else statement is executed because 56 is greater than 13 and 19. And the else statement, 56 is less than 65, so the if statement is executed, and the output is, you are an adult. All right, so let's run the code again. Let's enter 68. In the else statement, 68 is greater than 65, so the else statement is executed, and the output is, you are a senior. See how that works? So now let's write a Java program to find the largest of three numbers and implement a nested if statement. We'll use the scanner class for getting input from the user, and we'll show a message to enter three numbers by using the print method. So let's declare four variables that their names include number 1, number 2, number 3, and largest number with the int type, and assign the next int methods of the scanner class onto these variables. So now let's start to write the if statement. If number 1 is greater than or equal to number 2, this is outer if. So if we add the nested if statement, if number 1 is greater than or equal to number 3, then assign number 1 to the largest number, else assign number 3 to the largest number. Okay, so let's continue with the outer else statement. So we add nested if statement again. If number 2 is greater than or equal to number 3, then assign number 2 to the largest number. Else assign number 3 to the largest number. All right, so let's print the largest number to the output by using our print method. And then finally, we'll have to close up the scanner object by using the close method. Okay, so let's run the code. Now, on the console screen, we'll enter 6, 5, and 12. So our program checks the outer if block first. 6 is greater than 5. The condition is true, so the outer if block is executed. And then in the outer if, the program checks the inner if 6 is less than 12. The condition is false, so the inner if is not executed, and the else statement is executed. You with me? And then 12 is printed out as the largest number. All right, so let's run the code and enter different numbers, such as -2, 1, 0. Largest number is obviously 1. So sure enough, in this lecture, I think you can play them back again, but I think that we did enough examples to understand the if statements. But to get used to it, to make it repetitive, to make it a habit, you should do some more exercises. Now, in this section, we're going to learn how to use the switch case statement and understand how to control the flow of our program's execution. Switch case statement. It'll execute one statement from multiple conditions. So it's like an if-else, if-ladder statement that you learned in the previous lecture. But the switch case statement works with primitive data types such as byte, short, int, and long. Remember those? So it also works with strings as well as enum types that we're going to get to in the following lectures. So have a look at this diagram. The switch case statement starts with a switch keyword and a conditional expression between brackets. So if case condition 1 is true, code block 1 is executed. If case condition 1 is false and case condition 2 is true, code block 2 is executed, right? So if case condition 1 is false and case condition 2 is false, if case condition n is true, then code block n is executed, right? So if all case conditions are false, the default code is executed. Now, there are a few important points to remember when we use the switch statement. There can be one or n number of case values for switch expression, if you remember your simple algebra. Now, the case value must be of a switch expression type only. All right, the case value must be literal or constant. We cannot use variables. So also, one of the new features added in Java 7 is the capability to switch on a string. So the case values must be unique. Otherwise, a compile time error will happen. Each case statement can have a break statement. Break statement is not mandatory. It's optional. Also, when control reaches out to the break statement, it jumps the control after the switch expression. So if a break statement is not found, it executes the next case. So how about a nice juicy example? Let's make the days of the week with a switch case statement. So go into the exercise project, right-click on Decision Making, Package, and select New Class. Specify class name as switch case statement. And select the checkbox for the main method. And then before coding, let's move the console panel to the right side of the screen to view the code examples, better. Okay, so that looks good. Why don't we get started? So first off, we're going to need to import the scanner class for getting input from the user. And we'll choose Import Scanner Class in java.util package to import the scanner class. Now we do get a message to enter a day number of the week by using the print method. And we'll declare a variable day number with the int type and assign next int as our method of the scanner class to this variable. Now, let's declare a variable day with a string type. So now we can start to write a switch case statement. A conditional switch expression is day number. So in the first case, we'll assign Monday to variable day and use the break keyword. All right, so let's copy the code and make some changes for case values and other days of the week. Now, we can also use the break keyword in each case condition because we don't want to execute each case condition, right? So we have 7 days in a week. So if the user enters a number that is greater than 7, we should warn the user by using this default keyword. So in the default part, we'll assign invalid day choice to the variable day. And let's display the value of day by using the print method. Also, remember to close the scanner object by using the close method. Okay, so let's run the code, and we'll enter 3 for a day number of the week. Case condition 3 is executed, and day is Wednesday is the message that we have displayed. So let's run the code again and enter 5. Case condition 5 is executed, and day is Friday is the message that we have displayed. Okie doke. Finally, let's run the code and enter 8. And the default part of the switch statement is executed, and invalid day choice is the message we have displayed. So we're going to do a lot more examples in the next exercises by using the switch case statement, but I just wanted you to make sure that you were comfortable with it. So sure enough, we're at the point where we're going to do our first project. Are you ready? It's a simple calculator, but it is built on everything we learned and also gives you an idea of some of the power of this language. So a calculator is pretty much one of the first things a programmer will learn how to build in their introduction to coding. Our calculator will be just doing some basic arithmetic operations, addition, subtraction, division, multiplication, as well as modulus. So first, let's create a new Java project and specify the project name, and we'll call it calculator. Now, don't change the other options, just click the next button. Now in this section, just uncheck create module info.java file, and then press the finish button. So in this project, just right-click on the source folder and select New Class, and then specify the package name as calculator and the class name as calculator, and then select the checkbox to add it to the main method. Now, as you may recall or know, calculators take inputs from users and it makes a calculation, right? So that means we need to take inputs from the user by using the scanner class. And in the first print method, we'll write a title for the program output. And let's call it calculator, all uppercase. And we get a message to enter two numbers using the print method. So we'll declare two variables, number 1, number 2, with the int type, and assign nextInt as our method of scanner class to these variables. Okay, so we show a message to be chosen in an operation. Now the user may enter one of the plus, minus, asterisk, forward slash, and percent mark symbols. So also, we need to declare a char type operator, which will signify the operation that we want the calculator to perform. And assign the first element in char at method of the next method of the scanner class to this variable. The chart at method is used for taking a character input in Java. And we need to declare a variable result with the double type. Its initial value is 0.0. Okay, so if you're with me so far, let's start to write our switch case statement. Now, the switch receives the operator variable and, depending upon what it is, chooses a certain case. The first case value is additive operator in a single quotation mark. So we'll do the addition of two numbers. We'll assign number 1 plus number 2 to the variable result, and we'll want to use the break keyword. So let's copy the code and make the changes for the case values and other arithmetic operations, right? And now we'll use the subtraction operator, multiplication operator, division operator, and modulus operator. So we have 5 operators. Now, if the user enters anything except these 5 operators, we should warn the user in the default code block. So in the default part, we'll display invalid choice operator as our message to the user by using the print method. So now let's display number 1, operator number 2, and the value of the result by using the print method. Now, it's better to close the scanner object by using the close method. Okay, so let's run the code. So we'll enter 12 and 13 for our two numbers, and then we'll choose the additive operator. Result is 12 plus 13 equals 25.0. Dun, da, da, da. Okay, so let's run the code again. We'll enter 12 and 7. And let's choose the subtraction operator. Result is 12 minus 7 equals 5.0. Okay, let's run the code again. We'll enter 13 and 3. And let's choose the multiplication operator. The result is 13 multiplied by 3 equals 39.0. So far, so good. So let's run the code again. And we enter 15 and 5. So now let's choose the division operator, resulting in 15 divided by 5 equals 3.0. Alrighty then, so let's run the code, and we'll enter 8 and 5. So now let's choose the modulus operator, resulting in 8% of 5 equals 3.0. Okay, and finally, let's run the code, and we'll enter, 12 and 4. And we'll choose the illegal operator. Result is invalid operator choice. So this message is true. But also we get 12 illegal operator 4 equals 0. So this is actually a wrong message to the user. The user shouldn't see this statement. So in order to solve this problem, instead of using a break keyword, we'll use the return keyword in the default code block. You got it? So the return keyword is used to exit the current method. The break keyword is used to exit a switch statement. All right? Return keyword, exit the current method. Break, exit a switch statement. Cool. So we're going to use the return keyword in the next few exercises. So let's go ahead and run the code again. And we'll enter 12 and 4 and choose an illegal operator. And sure enough, we get only the invalid operator choice message. Good job. We finished our first project quite successfully. So let's move on. For loop. So when you need to execute a block of code a whole bunch of times, we use looping statements. So first off, we're going to learn how to use the for loop in Java. The for loop is a control flow statement that iterates a part of the program multiple times. So the general form of the for statement can be expressed like you see here in the slide. Initialization declares the initial value of the controlling variable. The controlling variable can be defined in line with the for loop or defined previously. Typically, the for loop uses an integer variable. The condition is a Boolean expression. So in other words, it must result in either a true or false output. If the condition is true, the loop continues to execute. Relational operators are what's used in the Boolean expression. So after each execution of the statements, the control variable is updated according to increment or decrement. Also, you'll see here on the slide the for loop execution flow. The first step, in for loop, the initialization part only executes once. The second step, condition in the for loop, is evaluated on each iteration. So if the condition is true, then the loop body gets executed. If the condition returns false, statements in the loop body do not execute, and the control gets transferred to the next statement in the program after the for loop. Third step, after each execution of the for loop's body, the increment-decrement part of the for loop updates the value of the controlling variable. And then the last step. After the third step, the control jumps to the second step and the condition is reevaluated. You'll see why in a minute. So let's do up some examples with the for loop. So in the exercise project, right-click on the source folder and select New and Class. Specify the package name as loop and the class name as for loop. and then select the checkbox for the main method. So let's start to write a program that prints int numbers from 1 to 10 by using the for loop. So we'll declare a variable I. We initialize this variable in for loop. Our condition is I less than or equal to 10, and it increments by 1. And we can use the print method to write our numbers to our screen. All right, so let's run the code. And you see the numbers from 1 to 10. So here, the variable I is declared and initialized to 1. Then the test condition is evaluated, and if this condition is true, the body of the for loop is executed and prints 1 on the screen. Then the update expression I++ is executed. Now the value of I is increased to 2. And again, the test condition is evaluated. 2 is less than 10, so the condition is true, and the body of the for loop is executed and then prints 2 on the screen. You with me? The iteration process runs until I is 11. When I is 11, since 11 is greater than 10, the test condition is false and the for loop terminates. So now let's write a program to find the sum of the numbers from 1 to 5. We'll declare a variable sum with the initial value 0. So in the for loop, we can use variable k, and we'll declare an initialized variable k with the 0 value. So our test condition is k is less than or equal to 5, and it increments by 1. And then we assign the sum plus k to the variable sum with the add and assignment operator. So the value of k is increased until k is greater than 5. All right, so let's print the value of k in the for loop by using our print method. And then finally, we'll use the print method after for loop to display the sum of numbers. Okay, so let's run the code. And you see the values of key and sum of numbers is 15. All right, then, so let's write a program to find the sum of even numbers from 1 to 10. So just go back and copy the previous code, and now make changes for the test condition and the increment-decrement part. Test condition is 10, and k increments by 2. So the variable k is always an even number. And then finally, we'll use the print method after the for loop to display the sum of the even numbers. Okay, so let's run the code. Now, you see the values of the key and the sum of even numbers, which is 30. For each loop. So in Java, the for each loop is another form of a for loop to work with arrays and collections. So we can say that it is an enhanced form of the for loop. You'll see what I mean. The use of the enhanced for loop is easier to write, and it makes your code more readable. So if you look at the syntax here, first we declare an array with initial values, and then we use the for each loop. So instead of an array, we can also use lists. In for parentheses, the first element is a single item from the array, and the second item is the list of an array. Colon is used between them. Please note here that if you do want to use the index of the element inside the loop, you have to use the for loops, and you cannot use the for each loops. So in our example, it'll iterate through each element in the numbers variable, storing it in the number variable and executing the loop body. So let's have a look and see how that works. We'll do up a few examples with the for each loop. In the exercise project, right-click on the loop package and select New Class and specify the class name as for each loop and select the checkbox for the main method. Now first, we'll do an example to iterate through elements of an array using the standard for loop. So let's declare a char array. Its name will be letters, and its initial value, let's call it H, E, L, L, and O. Now let's start to write the for loop. In for loop, we can use the variable I, and we'll declare and initialize variable I with the value of 0. And our test condition is I less than length of array letters, and we'll increase the value of I by 1. So let's print the elements of the array by using the index in the print method. All right, so let's run the code. And you see there the elements of the array in the console. Now, we can perform the same example using a for each loop. So let's copy the declaration part of the array from the previous code, and we'll start to write the for each loop. So in for parentheses, we declare a variable item with char type, and we'll add a colon as well as the letters array. Now let's add the variable item into the print method. Okay, so now we can run the code, and you'll see there the elements of the letters in the array in the console. So you can see the difference between the loops, right? In the for each loop, the code has reduced significantly. Also, we don't use the index and counter in the for each loop. So now let's expand in our example. Let's take a closer look at how the for each loop works. The for each loop iterates through each item in a given letters array, and it stores each item in the variable item and then executes the body of the loop. So let's do another example by using the for each loop. We'll write a program to calculate the sum of all elements of an integer array. Let's declare an integer array and call it numbers with initial values 6, 4, 3, and 5. And then we'll declare a variable sum. Initial value is 0. In for parentheses, we declare a variable num with int type, and we add a colon and numbers array. Now we assign a sum plus num to the variable sum with add and assignment operator. So let's print the value of the num in the for loop by using the print method. And then finally, we'll use the print method after the for loop to display the sum of the numbers. All right, so let's run the code. And you see the values of the num, and sum of the numbers is 18. While loop. So in the while loop, the controlling variable is defined previously. Condition is evaluated first, and if it returns true, then the statements in the loop body are executed. So generally, a loop body contains an update value for the variable being processed for the next iteration. If the condition returns false, the control comes out of the loop and jumps to the next statement after the while loop. So let's do some examples with the while loop. Go back to the exercise project, right-click on the loop package, and select New Class. Specify the class name as while loop, and select the checkbox for the main method. Now let's declare a variable, I, with the initial value of 5. So our loop condition is I is greater than 1. So we'll use the print method to display numbers. Now we need to update the variable I. So we'll decrease the value of I by 1. Okay, let's run the code. You see the numbers 5, 4, 3, and 2. So after 4 iterations, I will be 1. Then our condition I is greater than 1 is evaluated to be false, and the while loop terminates, right? Okay, so let's write a program to calculate the factorial of the first 5 numbers. So let's declare 2 variables. First, k, with the initial value of 1, and the second one is fact, with the initial value of 1. And let's start a while loop with the condition k is less than or is equal to 5. And in the loop, we'll assign fact multiply k to the variable fact with multiply and assignment operator. So now we can print the value of k and the fact variable by using the print method. We increase the value of k by 1. Okay, so let's run the code. The factorial of 1 is 1. Factorial of 2 is 2. The factorial of 3 is 6. Factorial of 4 is 24. The factorial of 5 is 120. Okay, so let's write infinite while loop examples. So an infinite loop just means a loop that never ends. So if we start a while loop with the condition true, this is an infinite while loop. For instance, we declare a variable d with the initial value of 100. If we start the while loop with the condition d equals 100, this is an infinite while loop. The do-while loop. The do-while loop is similar to the while loop, with the only difference being that It checks for the condition after executing the statements in the loop body. So there's no checking any condition the first time. After the execution of the statements in the loop body and update of the variable value, the condition is checked to be true or false. So if it is evaluated to be true, the next iteration of the loop starts. If the condition returns false, the loop terminates and then jumps to the next statement after the do-while loop. So the statements in the loop body are executed at least once before the condition controlling, and that is an important point. So do you want to see what I mean? Let's do up some examples with the do-while loop. So in the exercise project, just right-click on the loop package and select New Class, and specify the class name as do-while loop, and select the checkbox for the main method. So let's write up a program that prints int numbers from 1 to 15. First, we'll declare a variable number with the initial value set to 1. Now, let's start the do-while loop with do as our keyword. Now, in loop, we'll use the print method to display numbers. So we'll need to update the variable I. In order to do that, we increase the value of the number by 1. And now we add the loop condition with the while keyword. Our condition is number is less than or equal to 15. So let's run that code. Now you see the numbers from 1 to 15 on the screen. So in the do-while loop, the print process and increment part of the body are executed at least once before the condition. So let's write a program that chooses a fruit from a menu. So we'll need to take the inputs from the user by using a scanner class. Now we'll choose import scanner class in java.util package to import the scanner class. Now let's declare a variable choice with no initial value, and let's start to write the do-while loop. So in a loop, in the first print method, we'll write a title for the program output. Let's call it menu with all uppercase letters. And let's copy the print method and change the code. So the first option of the menu is apple. Second is banana. Third is orange. And the last option is exit. So in the last print method, we give the select and option message to the user. And we'll assign the next int method of the scanner class to variable choice. And now we can use the switch case statement for this part. And it's useful for menu operations like this one. Conditional switch expression is a variable choice. Now, in the first case, we display apple in the print method. And then we can add the break keyword. Now let's copy the code and make the changes for case values and other fruits, banana and orange in our case. So this loop is executed until the choice is not equal to 4. If the user enters 4 from the menu, the loop is terminated. So we add a while keyword with a choice not equal to 4 as a condition. So let's run the code. And then you see the menu in the console, right? So let's enter 1, and there's an apple. Enter 2, banana is displayed. Enter 3, an orange is displayed. Enter 4, no answer because the loop is terminated, right? Branching statements. Branching statements are used to change the normal flow of execution in some conditions. So Java provides 3 branching statements: break, continue, and return. Break, we've used it before. It's used to terminate loops or switch statements. Control of the program moves to the next statement following the loop. Continue is used to continue the loop. When the continue statement is executed, control of the program jumps to the end of the loop, and the loop condition is evaluated. So that leaves us with return, and that's used to exit from the current method, and the control flow returns to where the method was invoked. All right, so let's do some examples with branching statements. We're going to start with a break statement. So in the exercise project, just right-click on the source folder and select New Class. Specify the package name as branching and the class name as break statement, and select the checkbox for the main method. Okay, so first, we'll use a break statement in a switch case statement. Let's declare a variable a with the initial value set to 0. Conditional switch expression is variable a. We have 2 case values. First one is 0. And if the value of the variable is 0, then we will print hi to console, and we'll add the break statement. So let's copy the code and change the case value. And if the value is 1, then we will print hello to console, and we'll use the break statement again. So let's run the code, and you see hi as a message in the console. So let's change the value of the variable with a 1, and let's run the code. Now you see hello as the message in the console. So let's change the value of the variable with a 0. Now, if we don't use a break keyword in the first case, what will happen? So let's remove the break keyword from the code. And now let's run the code. You see the hi message and the hello message in the console. So all the cases will be executed until it sees the break keyword. That's why it's recommended to put a break after each case. So now let's use the break statement in the standard for loop. So in the for loop, we declare a variable of I with the initial value 0. Our condition is I is less than 10, and it increments by 1. So if I equals 7, we'll use a break statement to terminate the loop. And we'll use the print method to write the numbers to the screen. So now let's run the code. And you see the numbers from 0 to 6. So in this code, when the value of the variable I becomes 7, if the condition is evaluated to be true, then the break statement terminates the loop. Okay, so let's now use the break statement anywhere. Let's see what happens. So let's declare the variable number with an initial value being 100. So if the number equals 100, we will try to use the break statement. But look at that, we get an error because break cannot be used outside of a loop or a switch. Remember that. Okay, great. So let's do some examples with the continue statement. So back in the exercise project, just right-click on the branching package and select New Class. Specify the class name as Continue Statement and select the checkbox for Main Method. So let's use the continue statement in the standard for loop. Now in for loop, we declare a variable I with an initial value 0. Our condition is I is less than 10, and it increments by 1. So if I modulus operator 2 is equal to 0, that means that if I is an even number, we'll use the continue statement to continue the loop. So we'll use the print method to write the numbers to the screen. And let's run the code. And you see the odd numbers in the console. So in this code, if the number is divisible by 2, then it's even. And if it's an even number, then the continue statement is executed. So for this iteration, the execution of the print statement is skipped and control of the program jumps to the end of the loop. The iteration process runs until I is 10, and then when I is 10, the test condition is false and the for loop terminates. Okay, so let's try to use the continue statement in anywhere. Now, let's declare a variable k with the initial value 50. So if k equals 50, we'll try to use the continue statement. But we get an error. Why? Because continue cannot be used outside of a loop. Okay, are you ready for some examples with the return statement? Alrighty then, in the exercise project, right-click on the branching package and select New Class. And specify the class name as return statement and select the checkbox for the main method. So first we use a return statement in the switch case statement. And we'll declare a variable k with the initial value 1. The conditional switch expression is variable k. So we have two case values. First is 1. And if the value of the variable is 1, then we will print 1 to the console. And then we add the break statement. So now let's copy the code and then change the case value. And if the value is 2, then we will print 2 to the console. And then we can add the return statement. And then finally, we'll add the print method after the switch loop to test the statement. So let's run the code. And both of the print methods are executed and the messages are displayed. Now, because break is used to exit a switch statement, the second print method is executed, right? So let's change the value of variable k with 2, and let's run the code. So now only the first method in the second case is executed, and this message is displayed. Because the return statement is used to exit the current method. So the second print method is not executed. Okay, so let's try to use the return statement in anywhere. let's declare a variable bool with Boolean type, so its initial value is true. And in the print method, we'll write in before the return. So if bool means that the condition is true, then we add the return statement. And then we can add the second print method that includes this statement will not be executed. Let's run the code. Only the first method is executed and the message is displayed, because the compiler ignores every statement after the return in the same method. All right. So yes, we are doing our second project. Now in this project, we will learn a mathematical concept. It's called the Fibonacci series, and we will learn how to implement it in Java. So first, let's create a new Java project and specify the project name as Fibonacci series. Now don't change the other options, just click the next button. So in this section, uncheck create module info.java file, and then press the finish button. So in this project, just right click on the source folder and select the new and class. Specify the package name as Fibonacci and class name as Fibonacci. And then select the checkbox to add to the main method. Now before coding, let's remember the Fibonacci sequence, review it, or learn it for the first time, depending upon where you're at. The Fibonacci sequence is 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, and it goes and goes and goes and goes. The next number is found by adding up the two numbers before it, right? For example, the next number in the sequence above is 34 plus 55, and that equals 89. I know, you're way ahead of me. I just had to go over it. So let's start to code. First, we'll need to import the scanner class for getting the input from the user. And then we choose the import scanner class in java.util package to import the scanner class. And now we're looking at a message to enter the max sequence number by using the print method. And then we can declare a variable number with the int type, and then assign the next int method of the scanner class to this variable. So let's go ahead and declare three variables with int type. First up, fib previous with initial value as 0. Second up, Fibonacci with initial value set to 1. And last, sum with the initial value 0. Now the variable fib previous represents the first number of the Fibonacci series, and variable Fibonacci represents the second number of the Fibonacci series. Now we can start to write the for loop. So in the for loop, we declare variable I and initialize it, so its initial value is 1. Our test condition is I less than or equal to number, and it increments by 1. Then we use the print method to display the numbers of the Fibonacci series. So we use the variable fib previous for this. So on each iteration, we add first the number fib previous and then the second number Fibonacci and assign this sum to a variable sum. And then we just assign the second number Fibonacci to the first number fib previous. and we assign the sum of the last two numbers to the second number, Fibonacci. Okay, so let's run the code, and let's enter 10 for max sequence, and you'll see the first 10 numbers of the Fibonacci series in the console. So now let's debug the code. Debugging allows us to run a program interactively while watching the source code and the variables during the execution. So let's put a breakpoint ahead of the print method line in the for loop. Now, in order to define a breakpoint in our source code, right-click on the left margin and select Toggle Breakpoint. So we can also double-click on this position for the same operation. It's up to you. Now, in order to debug our application, we can use the Debug button in the Eclipse toolbar. So let's go ahead and click that Debug button. And let's enter 10 for max sequence. So Eclipse asks us if we want to switch to the debug perspective. So let's click Switch in the dialog window. And see how Eclipse provides debug buttons for controlling the execution of the program? So we have some shortcut keys to step up our code. And let's check the values of the variables in the debug perspective. So we click the Step Over button and display the values of the variables in the variable section. Now, at first, the fib previous is 0. Fibonacci is 1, and the sum is 0. So why don't we click the Step Over button again? No change. Let's click the button again. Variable sum is 1. So we'll click the button again. Variable fib previous is 1. And click the button now 4 times. Variable sum is 2. So let's click the button again. The variable Fibonacci is 2. Let's click the button 3 times. Sum is 3. And click the button again. Variable fib previous is 2. And let's click the button again. Variable Fibonacci is 3. And on it goes just like that. So let's click the Resume button to resume the execution of the program code until it reaches the next breakpoint. And let's click on this button until execution of the program finishes. And now you can see the Fibonacci series in the console. So I think you understand how to debug your code in Eclipse by doing this. It's pretty fun, huh? You can go back and do it again if you like it that much. Types of methods. So we basically have 2 types of methods in Java. The first one is standard library methods, and the second one is user-defined methods. So Java, of course, has a library of predefined classes and methods organized into packages. Now, in order to use these methods, we'll import the packages and use them directly in our program. We will cover packages in the next few slides. But let me just give you a quick example right now. Remember the first Java program that we wrote together? We used the print method to write hello world on the screen. Well, the printed method is just an example of a standard library method. Then, of course, in addition to using Java predefined methods, we could always write our own methods. In order to write a method, first you decide what you need to do. Then you write the definition of the method by providing the return type, name of the method, and the parameters. For example, the addNumber method that we defined in the previous slide is an example of user-defined methods. Method return types. So every method in Java returns something, right? Either some value or nothing. If it returns a value, this value can be either primitive or non-primitive. The void keyword allows us to create methods which do not return a value. These methods perform a set of tasks without a return value. So when a method does not return a value, it's indicated by the keyword void before the name of the method. If you declare a method with primitive types, your return type method must be the same, right? So primitive methods return char, byte, short, int, long, boolean, float, and double types. If you declare a method with non-primitive types, your return type of method must be the same, right? Makes sense. Non-primitive methods return reference data types such as object of class, string, stuff like that. So why don't we do some examples with methods? In the exercise project, right-click on the source folder and select New Class. Specify the package name as method and the class name as method example, and then select the checkbox for main method. Now, outside the main method, let's declare a static void method, show with two int parameters, num1 and num2. And then we add the print method to display these numbers. So let's add a comment to the void method, show, and our comment is displays numbers. And now let's declare another static int method, add, with two int parameters, num1 and num2, and what does it return? It returns the sum of two numbers. All right, so in the method, we declare a variable sum with int type. Now its initial value is 0. And then we assign num1 plus num2 as an expression to the variable sum. And we return the variable sum. So now let's add a comment to the int method, add. And our comment is returns the sum of two numbers. So now let's declare another static int method, min, with two int parameters, num1 and num2, and it returns the minimum of two numbers. Now in the method, we'll declare a variable, min, with int type. And if number 1 is greater than number 2, then we assign num2 to variable min, else we assign num1 to variable min. And then we return the variable min. So now let's add a comment to the int method min, and our comment is returns the minimum of two numbers. Okay, so now let's call these methods from the main method. So our main method is static. So what does that mean? We have to declare the other methods as static in order to use it in the main method. So first, we need to import the scanner class for getting input from the user. And we choose import scanner class in java.util package in order to import the scanner class. And then we show a message to enter two numbers by using the print method. So let's declare two variables, that are named number 1 and number 2, and then assign the next int methods of the scanner class to these variables. Now first, we'll call the void method show. We pass number 1 and number 2 as a parameter to this method. Now there's no need to assign the void method to a variable because the void method returns nothing. So secondly, we call the int method add. We pass number 1 and number 2 as a parameter to this method. Then we assign the add method to the new variable a with the int type. And for the last one, we will call another int method, min. We pass number 1 and number 2 as the parameter to this method. And we assign the min method to the new variable b with int type. So now let's write the print methods. In the first print method, we display sum of numbers. And in the second print method, we display the minimum number. Okay, so let's run the code. And we enter 8 and 12. First, the void method show is called and it prints you entered 8 and 12. Perfect. Then the int method add is called and it prints the sum of numbers is 20. And the last one, another int method, min is called and it prints the minimum number is 8. So there you go. It works, huh? Method overloading. When a class has 2 or more methods by the same name but different parameters, it's known as method overloading. So in this example, you will see 3 methods. These methods have the same name but different parameters. Now, if we call these methods by passing an argument value, the compiler knows which method to call on the grounds of the method input. So let me show you an example of method overloading. So in the exercise project, right-click on the method package and select New Class. Specify the class name as Method Overloading, and then select the checkbox for the main method. Outside the main method, let's declare a static int method add with 2 int parameters, x and y. And this method returns x plus y. Okay, so let's declare a static int method add with the same name but 3 int parameters, x, y, and z. So this method returns x plus y plus z. Now let's declare a static double method add with the same name but 2 double parameters, x and y. This method returns x plus y. These 3 methods have the same name but different parameters. So let's call these methods from the main method. Let's see what happens. So we can directly call these methods in the print method. So in the first print method, we call the add method with the parameters of 10 and 20 to display the sum of 2 int numbers. And the second print method, we'll call the add method with the parameters 10, 20, and 30 to display the sum of the 3 int numbers. And in the last print method, we'll call the add method with parameters 4.6 and 8.4 to display the sum of two double numbers. Okay, so let's run the code. Now, first, the int method add is called with two parameters, and it prints the sum of two numbers is 30, right? Then the int method add is called with three parameters, and it prints the sum of three numbers is 60. And the last, the double method add, is called, and it prints the sum of two double numbers is 13.0. And yes, it is time for our third project. Now, in this project, we will calculate the number of given numbers by using POW as a method of the math class. So, we will learn how to implement the POW method. So first, let's create a new Java project and specify the project name. Let's call it exponential number. Now, don't bother with changing the other options. Just click the Next button. And in this section, uncheck the Create Module Info.java file, and then press the Finish button. So in this project, just right-click on the source folder and select New and Class. Specify the package name as exponential and class name as exponential number, and then select the checkbox to add it to the main method. Outside the main method, let's declare a static int method, pow, with two int parameters, num and power. So in the method, we will use the pow method of the math class. And that way, the pow method returns the value of the first argument raised to the power of the second argument. So the pow method is a standard library method, and it's defined in the math class. Now, if we try to return the pow method of the math class to the int method, we get a type mismatch error because the pow method of the math class returns a double value. So in order to solve this problem, we will choose cast to int as our option to add code. Okay, so the problem is solved. Now let's call this method from the main method. First, we will need to import the scanner class for getting input from the user. And then we choose the import scanner class in java.util package to import the scanner class. And look at this, we see a message to enter an integer-based number by using the print method. So let's declare a variable base and assign nextInt as a method of the scanner class to this variable. Now we get a message to enter an exponent by using the print method, so let's declare a variable exponent and assign the nextInt method of the scanner class to this variable. Now we can start to write the for loop. So in for loop, we declare the variable I and initialize it. So its initial value is 0. Our test condition is I less than or equal to exponent, and then it increments by 1. Now we use the print method to display numbers and their powers. So we call the int method pow. We pass the number and exponent as a parameter to this method. And then finally, let's close the scanner object by using the close method. Okay, so now let's run the code. So we enter 6 for the base number and enter 5 for the exponent. And look at the results in the console. On each for iteration, we call the pow method to calculate the powers of a given base number. So let's have a look. 6 to the power of 0 is 1. 6 to the power of 1 is 6. 6 to the power of 2 is 36. 6 to the power of 3 is 216. 6 to the power of 4 is 1296. 6 to the power of 5 is 7,776. I was trying to do this in my mind faster than this, but you can see why. We'll do it like this from now on. And you can always test other alternate values for understanding to your heart's content. But if you got it good, let's move on to the next section. All right, so in this section, we will learn the object-oriented concept. First, we'll learn what is object-oriented programming concept. And then we'll learn the object and class. Then we'll learn the access modifiers. Then we'll learn some naming conventions. And we'll have a look at constructors. And then we'll play around with packages. And then we'll put together what is a static keyword and how the heck can I use it? And then we're going to cover nested and inner classes. So stick with me. This is going to be a bumpy ride. Object-oriented program, OOP, or OOP, is a method of designing and implementing software. So it covers a pretty broad range. But the primary purpose of object-oriented programming is to increase the flexibility and maintainability of programs. It simplifies the software development process and the maintenance process by providing some concepts. And these concepts are object, class, inheritance, polymorphism, abstraction, and encapsulation. So we're going to cover these subjects in detail in the upcoming slides. First, I want to start with the object-oriented concept. Object and class. So a class, it's a group of similar entities, right? An object can be defined as an instance of a class. So objects are often used to model real-world objects that you find in everyday life. A Java object is a self-contained component which consists of methods and properties. An object contains an address and takes up some space in memory. A class doesn't consume any memory space. So an object has 3 characteristics. It has a state, behavior, and an identity. So coming up in the next slide, we're going to try to understand the characteristics. Characteristics of object. So just as I promised, an object has 3 characteristics. It has a state, behavior, as well as identity. The state represents the data of an object. Now, the behavior represents the action of an object, such as start, stop, etc. Identity is used internally by the Java virtual machine to identify each object uniquely, right? So the value of ID is not visible to the external user. So let's think about maybe a car, and let's call it a Ferrari. The color is red. The model is 2015. These are the states, right? So this car starts and stops. So starting and stopping are behaviors. Object and class example. So let's make an example with objects and class. For instance, we define a car class, and the properties of an object car would be model, color, and year. An object also executes some actions. A car is capable of performing the following actions, right? Start, stop, and accelerate. Now, as you can see on the slide, for different values of properties, model, color, year, in the class car, we will get different car objects. So in our example, we have one class, but we also have 3 objects. Cool. Class declaration. Every Java application must have at least one class definition. A class is declared by use of the class keyword. The class body is enclosed between curly braces. The data of the variables are defined in the class, and these variables are called instance variables. The action code is written in the method, and all code blocks are in the class body. So variables and methods are defined in the class, and these are members of the class. Creating an object. An object is created from a class. In Java, the new keyword is used to create new objects. And as you can see here in the slide, we created my car as an object from the car class by using the new keyword. So car, my car, equals new car. And here, my car, the object, is the reference which holds the memory address of the car object. So in this section, we will learn access modifiers in Java. Access modifiers are used for setting the access level to classes, variables, methods, and constructors. There are basically 4 access modifiers in Java. First one, of course, is default, by default. So that means that we will not explicitly declare an access modifier for a class, field, method, and constructor. A variable, method, and constructor declared without any access control modifier is available to any other class in the same package. The second one is public. Public access modifier is accessible from everywhere, and this is the least restrictive access modifier. And the third one is private. The private access modifier is accessible only within class. So methods, variables, and constructors that are declared private can only be accessed within the declared class itself. Private modifiers are the most restrictive access level. So the last one is protected. The protected access modifier is accessible only within the same package and in addition from all subclasses of its class. So in this part, you see the restrictive level of accessibility of modifiers. And as you see here in the slide, the most restrictive modifier is private, and the least restrictive modifier is public. Default comes after private, and protected comes after default. So in this section, we will learn naming convention rules in Java. Java naming convention is a rule to follow how to name your identifiers, like class, variable, method, etc. But it's not enforced. You don't have to follow it. It's known as a convention, so that means it's just a mandatory rule. Guideline, if you're a fan of Pirates of the Caribbean. Anyway, As you see here in the table, the class name should start with an uppercase letter and should be a noun. For example, string, car, system, etc. The method name should start with a lowercase letter and be a verb. For example, start, stop, action performed, etc. The variable name should start with a lowercase letter. For example, first name, year, color, etc. And then by using standard Java naming conventions, you can make your code easier to read for yourself and for other programmers. The readability of a Java program is very important. It indicates that less time is spent on how to understand what exactly the code does. The most important concepts of naming conventions are case-sensitive and camel casing. So Java is a case-sensitive language. For example, hello with the first letter as an uppercase and hello with the first letter as a lowercase are, well, they mean completely different things in Java. Camel casing is a naming convention in which the first letter of the second word in a compound word is capitalized. So you have a name that is combined with two words. The second word will start with uppercase letter always. For example, action performed, first name, etc. Constructors. A constructor is similar to a method. It has the same name as its class. And when a new object is created, at least one constructor will be invoked. Every class has a constructor that is named default constructor. However, constructors have no explicit return type. Now, as you can see in our example, a class can have more than one constructor. So in order to understand the working of a constructor, take this for an example. Let's say we have a class car, and when we create two objects of car, in creating the first object, the new keyword here creates the object of class car and invokes the default constructor, has no parameter to initialize the newly created object. And then in creating the second object, also the new keyword creates the object of class car and invokes the constructor that has one parameter to initialize the newly created object. So let's show you some visual examples about working with constructors. So first, let's create a new Java project. And we can specify the project name as object-oriented. Now don't bother changing the other options and just click the Next button. So in this section, just uncheck the Create Module info.java file and then press the Finish button. So in this project, just right-click on the source folder and select New Class. So specify the package name as OOP concept, OOP concept, and the class name is car. Okay, so we create a car class. The states of the car are model and current speed. We declare them as a private identifier because we cannot have access to these variables from another class. So now let's declare a public constructor that's named car, and it takes one parameter, and its name is model. So we declare the constructor as public because we want to be able to access this constructor from another class. So in the constructor method, we assign a parameter to own variable model. This keyword is used to access the same class members. Now don't worry, we will cover this as a keyword in the next slide. So let's declare 4 public methods of the car class. And we declare it as public because, of course, we want to have access to these methods from the other classes. Now, the name of the first method is start with void type. In the start method, we use the print method to display car has started as our message by adding the variable model. The name of the second method is accelerate. So we add 20 miles per hour to the current speed variable by using the add and assignment operator. And then the name of the third method is stop. So in the stop method, we use the print method to display the car has stopped message by adding the variable model. Also, we can set the current speed to 0 because if the car stops, then its speed, of course, is 0. Now, the name of the last method is show speed. And in the show speed method, we can use the print method to display the current speed of the car by adding the variable model and current speed. So let's save the code. All right, so we're going to need to test this class. So let's create a new class. Right-click on OOP-Concept package and select New Class. Specify the class name as CarTest, and then select the checkbox for the main method. So let's create the MyCar object by using the new keyword. So we pass Ferrari as a parameter to the car class. This process invokes a constructor having one argument. So let's call the methods by using the MyCar object. We can access the properties of an object with a simple dot notation. So if we write MyCar dot, Eclipse automatically brings the properties of class, and we can choose them to add to our code. So we add the start method first, and then accelerate, and then show speed, and then stop, and again, show speed. Okay, so let's run the code in the test class. So you see the results in the console right here. The start method is called and it displays the Ferrari has started message. The accelerate method is called and it sets 20 to the current speed variable. The show speed method is called and it displays the current speed of the Ferrari is 20. The stop method is called and it displays Ferrari has stopped and set 0 to the current speed variable. The show speed method is called again and it displays the current speed of the Ferrari is 0. Okay, so you are now ready to learn the toString method. Been waiting for this. So let's declare two variables in the car class. The first one is color with string type, and the second one is year with int type. So let's declare a constructor that's named car, and it takes 3 parameters: model, color, and year. All right, so in the constructor method, we can assign the model to its own variable model, color to its own variable color, and year to its own variable year by using the this keyword. So let's declare the toString method of the car class, and the toString method returns string. Now, we return name, color, and the year variables by using the plus operator in this method. So let's save the code. Okay, so let's pass the test class car test, and let's create a new object. So its name is myCar1. Now we pass 3 parameters to the car class. They are Ferrari, red, and 2015. And now we add the object myCar1 to the print method. Now, if you print any object, the Java compiler internally invokes the toString method. So let's run the test class again. And do you see the result in the last statement? Of course. The toString method is called and it prints model is Ferrari, color is red, and year is 2015. So let's open the car class, and we invoke this constructor and the toString method of the car class. Packages. A Java package is a group of similar types of classes, interfaces, and other sub-packages. Now, if you have a large-sized project that consists of hundreds of Java classes, you really need to organize them into packages. You can think of packages like file directories in your PC. So this will allow you to categorize files, control access to your classes, and avoid potential naming conflicts. Classes with the same name can be put into different packages. So then packages avoid name collision. So the package keyword is used to declare a package. In our example, let's declare a package vehicle.car. So here, vehicle is a top-level package and car is a sub-package, right? Now, of course, there are some rules to define packages. Package declaration is done at the beginning of the source file. Only one package declaration can be done per source file, and if no package is declared, then the class belongs to the default package. And the package name must be hierarchical and separated by dots. Types of packages. So we have 2 types of packages in Java. Built-in package, the already defined package like java.lang, java.io, etc. They're known as built-in packages. You can also have a user-defined package. So the package we create is called a user-defined package. For example, the one that we used earlier, vehicle.car. That's a user-defined package. Import keyword. So we can use the import keyword to import built-in and user-defined packages into our Java source file. Our class can refer to a class that is in another package, and we can use its name directly in your class. We can access the classes and interface of another package with the import keyword. So we have two different ways of how to import any class into different packages. The first one, if you import the package name dot class name, then only this class will be available for use. For example, you see this on the slide. If we use import vehicle.car.ferrari, that means that we will use only the Ferrari class in the subpackage car in the top package vehicle. Yeah? So the second way to import, if you use a package name .asterisk, then all the classes and the interfaces of this package will be accessible, but the classes and the interface inside the subpackages will not be available for use. Now, there is one exception to the import rule. All classes in the java.lang package are imported by default. But that means that we do not need to import classes in the java.lang package into our code. The system class can be given as an example for this exception. The system class is predefined in the java.lang package, so we can use it in our code without importing. Sequence of program. So as you see here in the diagram, in Java, a Java source file can contain any or all of the following three internal parts: a package statement, import statements, and a public class declaration. A Java source file should have a public class declaration. All other statements are optional. The program should be written in a flow package with imports and class. So why don't we do some examples with packages? In fact, we did an implementation of packages in all of our earlier examples, but we do need to learn the package concept, I think, in detail. So let's get into it. So in the object-oriented programming project, just right-click on the source folder and select New Package. Specify the package name as package operation. Okay, so let's create a new class. Right-click on package operation and select New Class. Now specify the class name as multiply, and it means that the multiply class in the package operation package. So let's start to code. Let's declare an int method, multiply, with two int parameters, a and b. And we return a multiply b expression from the method. Now let's create a new package for the test. Right-click on the source folder and select New Package. Specify the package name as package test. Okay, so let's create a new class. Right-click on the package test package and select New and Class. Specify the class name as test and select the checkbox to add to the main method. Now, first we need to import the scanner class for getting the input from the user. And we choose the import scanner class in java.util package to import the scanner class. Java.util is a built-in package. And now we see a message to enter two numbers by using the print method. So why don't we go ahead and declare two variables that are named number 1 and number 2 with the int type, and assign the next int methods of the scanner class to these variables. Great. So now let's create an object from the multiply class by using the new operator. So the multiply class is not part of this package. So we got an error, right? You're expecting that? So what does that mean? We've got to import this class. Now, in order to import this class, just hover your mouse pointer on the multiply keyword and import options are shown. And we'll choose the first option, import multiply in package operation. Okay, so it looks like it's added after the scanner class definition. Now, this is what we would call a user-defined package. So let's print the multiplication of numbers, and we will call the multiply method of the multiply class, and we pass two numbers as parameters. Okay, so let's run the code. We enter 12 and 8. The multiply method in the multiply class is called, and it displays result is 96. So let's try to change the access modifier of the multiply method in the multiply class. So if we change the public to private, and let's save the class. So see how we get an error in the main method because the method multiply is not visible to the other class. So in these cases, Eclipse can show us a quick fix dialog. Now this dialog provides a whole list of possible corrections. Now, if we want to solve this problem, just select Change Visibility of the multiply method to public option. Okay, so let's open up the multiply class and see our changes. Let's create a new class and specify the package name as method operation and class name as add. Let's declare an int method add with two int parameters a and b. We return a plus b as the expression from the method, and we'll save the class. Now let's open the main class test. We have two classes in the package operation package, multiply and add. So if we use the asterisk mark after the package definition, we can access all of the classes in this package. So let's create an object from the class add. And see how we didn't get an error, so there's no need to import this class. Let's print the sum of the numbers. We call the add method of add class, and we pass two numbers as parameters. Okay, let's run the code. We'll enter 12 and 8. So the multiply method in the multiply class is called, and it displays result is 96. Add method in the add class is called, and it displays result is 20. In this section, we'll explore the static keyword of the Java language in detail. We'll learn how we can apply the keyword static to variables, methods, blocks, nested classes, and just see what difference it makes. So the static keyword is used for memory management in Java. It's a keyword that is very useful, and it's used for sharing the same variable or method of a given class. Static keyword usage. So have a look at this slide. We use the static keyword to declare static variables, methods, blocks, inner class. And also, we'll be able to define the static method in interface classes in Java 8 and later. Static variable is used for fulfilling the common requirement. For example, a school name of students. The school name is common for all students, so if we declare static school name variable, it'll allocate memory only once in the class at the time of class loading. A static variable can be accessed directly by the class name, and it doesn't need any object. Now, the static method is a method which belongs to the class and not to the object, right? A static method can be accessed directly by the class name and doesn't need any object, same as a static variable. Static block is a block of statement inside a Java class that will be executed when a class is first loaded into the Java virtual machine. And we will also cover nested class and interface in the next slides. But for now, let's make some real-life examples by using the static variables and methods. So in the object-oriented programming project, just right-click on the source folder and select New Class. Specify the package name as static example and the class name as car. So let's start to write a program that implements speed operations of a car by using static variables and methods, such as show speed, speed up, speed down, and stop actions. Now first, let's declare two static integer variables. First one is current speed with the initial value of 0. And the second one, max speed with the initial value set to 180. So now let's declare a static void method that's named showCurrentSpeed, and we'll give it a parameter that's named speed. So we will use this method to print the current speed by using the print method. And we're going to call this method from the other methods in this class. So we'll write a method once, and then we can use it multiple times, right? We do not have to rewrite the entire code each time. You remember that from earlier? So let's declare a static void method that's named speedup, and we'll give it a parameter, call it increase. So in this method, we'll assign the current speed plus variable increase to current speed by using the add and assignment operator. So if the current speed of the car is greater than the max speed, then we show the current speed. And also, we can give the please slow down message by using the print methods. So if the current speed is smaller than the max speed, that way we only show the current speed by calling up the showCurrentSpeed method. So let's declare another static void method that's named speedDown, and let's give it a parameter called decrease. So in this method, we'll assign the current speed minus variable decrease to the current speed by using the subtract and assignment operator. All right, that makes sense. So then we show the current speed by calling up the showCurrentSpeed method. So let's declare the third static void method that's named stop, and that one, of course, has no parameter. So in this method, we just assign a 0 value to the current speed variable, and we show the current speed by calling the showCurrentSpeed method. Okay, so let's create a new class for the test of car. Right-click on Static Example and select New Class, and specify the class name as Test, and then just select the checkbox to add it to the main method. Now, a static method can be accessed directly by the class name, and it doesn't need any object. So let's call the methods of the class by using the class name directly. So first, we call speedup and pass the value 60 as the parameter for increasing speed. Then we call the speedup method again and pass the value 100 as a parameter for increasing speed. Then we call the speeddown method and pass the value of 50 as a parameter for decreasing speed. And then finally, we can call the stop method. All right, so let's run the code and review the results. So the initial value of speed is 0, and look at that, we speed up to 60, and the current speed is 60. Then we speed up to 160, which is 60 plus 160, so the current speed is 220, and 220 is greater than the max speed value of 180, so we get the please slow down message. And then we speed down 50, and 220 minus 50, and the current speed is 170. And then finally, we stop the car and set 0 to the current speed. Wow, what a ride. So if we try to create a car object by using the new keyword, let's call the speedup method and pass a value of 40 as a parameter. Now, there's no error, but we do get a warning message that the static method speedup from the type car should be accessed in a static way. So this code works, but it's not recommended to do it this way. All right, so let's run the code, and you see the same results. So how about that? I think that greatly develops your understanding of what a static variable and a static method is. You can review the material, of course, or you can take what you've learned and move along to the next bit. Nested and inner class. So in Java, we may define a class within another class, and this class is known as a nested class. There are two types of nested classes in Java. First one is non-static nested class, and that's known as an inner class. And of course, the second one is the static nested class. So let's talk about non-static nested classes first. So non-static nested classes, or inner classes, may have access to all the members, such as static and non-static variables, methods of its outer class. Also, an inner class may access private variables and methods of its outer class. Static nested classes do not directly have access to other members, such as non-static variables and methods of the enclosing class, because it is, by its nature, static. I tell you what, let's clear it up by doing up some examples, and that'll help us understand it better. So in the Object-Oriented Programming project, just right-click on the source folder, select New, Class, specify the package name as Nested Class, and a class name as Static Nested Example. So let's start to write a program that accesses variables from the nested class. Okay, so let's declare a static int variable a with an initial value of 5. And let's declare a private static int variable b with an initial value of 10. Now let's declare a non-static variable c with an initial value of 15. Okay, so let's try to access these variables from the static nested class. Now we need to, of course, create a static nested class in this class. So let's create the static nested class that's named static nested class. So in this class, we create a void method, and we'll call that show. Now in this method, we can use 3 print methods. So in the first print method, we can access static variable A. In the second print method, we can access private static variable B. And in the last print method, we cannot access non-private static variable C. This statement gives a compilation error because the static nested class does not have, it cannot, it won't ever have direct access to a non-static variable. So what do? We'll put a comment on this line. Okay, so let's create a new class for the test of the static nested class. Right-click on the nested class package, and then select New Class. Specify the class name as Static Nested Test, and then select the checkbox to add to the main method. Now, in order to access a static nested class, we first use the outer class, and then we use the dot operator and nested class. Outer class is static nested example, and the inner nested class is static nested class. So now let's create a nested object by using the new keyword. And we'll call up the show method to print the values of the variables. Okay, so let's run the code. And you see the values of the variables, A equals 5 and B equals 10. So now let's do an example with inner class. Now, I always like to think of myself as having inner class. But let's create a new class. Right-click on the nested class package and select New Class. Specify the class name as inner class example. And then let's copy the declaration of the 3 variables from the static nested example class. Okay, now let's try to access these variables from inner class. We need to create an inner class for this class. So let's create an inner class that's named inner class. So in this class, we need to create a void method called show again. And we'll use 3 print methods. In the first print method, we can access the static variable A. In the second print method, we can access private static variable B. In the last print method, we can access non-private static variable C. This is an important point, right? In the static nested class, we couldn't have access to variable C, but we can access in the inner class, right? Okay, I'm glad we cleared that up. Let's create a new class for the test of inner class. So right-click on the nested class package and select New Class. Specify the class name as inner test, and then select the checkbox to add to the main method. Now, in order to instantiate an inner class, we must first instantiate the outer class. Then create the inner object within the outer object. So let's create an outer object by using the new keyword first, and then we'll create an inner object. Okay, so let's run the code. And you see the values of the variables. A equals 5, B equals 10, and C equals 15. Excellent. Very well done. In this section, we will learn object-oriented programming and its implementations. First, we will learn fundamental subjects of object-oriented programming, inheritance. Then we will learn method overriding. Then we will learn how to use super and this as keywords. Then we'll play around with how to use the final keyword. And then we're going to learn abstract classes. And then we will learn interfaces. And then we will learn polymorphism, which is not a religion. Then we will learn encapsulation. Inheritance. So inheritance is a fundamental concept of object-oriented programming. It's used when we have a is-a relationship between objects. In Java, all classes can inherit variables and methods from another class. Inheritance enables us to reuse existing code. So in our example, we have a superclass, vehicle. All vehicles have a type, model, and max speed. Also, all vehicles can start and stop, right? So this is the base class. Also, we have two classes that are named car and motorcycle. So the car and motorcycle classes are subclasses of vehicle. So we can use the extends keyword by the subclass to inherit the features of the superclass. So the car and motorcycle classes inherit variables and methods from the vehicle class. And there's no need to declare these variables or methods again for the car and motorcycle classes. The car class has its own variable that's named isAutomatic. And the motorcycle class has its own variable that is named motorType. So in the object-oriented programming project, just right-click on the source folder and select New Class. Specify the package name as Inheritance and the class name as Vehicle. So now let's start to write a program that prints the properties of subclasses by using inheritance. The vehicle class is a superclass. So let's declare 3 instance variables in the vehicle class. We declare 2 variables that are named type and model with string type, and the variable max speed with int type. Now let's declare a void type method, print, to display the values of type, model, and the max speed variables. And we'll use the print methods. So finally, we'll save that code. Okay, so now let's start to declare subclasses. Okay, so let's create a new subclass. Just right-click on the inheritance package and select New Class. Specify the class name as car. Now, in order to implement inheritance, we have to add the extends keyword after the subclass car. So our subclass car extends the superclass vehicle, and this just means that the subclass car inherits the print method and the variables from the superclass vehicle. So don't forget to save the code. Now, let's create another subclass. Right-click on the inheritance package and select New Class. Now specify the class name as motorcycle. Our subclass motorcycle extends the superclass vehicle. So this means that the subclass motorcycle inherits the print method and the variables from the superclass vehicle. And the motorcycle class is empty. And then finally, we can save the code. All right, so let's now create a new class for testing inheritance. So just right-click on the inheritance package and select New Class. Specify the class name as Inheritance Test, and then select the checkbox to add to the main method. So now, let's start to create a new car object. If you write car object and a dot operator, then you will see the variables max speed, model, and type, and the print method coming from the superclass vehicle. So let's assign car as a value to the type variable, Ferrari as the value to the model variable, and then add the value 320 to the max speed variable. Now let's call the print method from the superclass vehicle. Okay, so now let's run the code, and there you see the results in the console. Type is car, model is Ferrari, and the max speed is 320. All of these properties are inherited from the superclass vehicle. Perfect. So let's start to create a new motorcycle object, shall we? So you see the same properties and methods coming from the superclass vehicle. So let's assign motorcycle as the value to the type variable. Kawasaki as a value to model variable, and the value 180 to the max speed variable. And now let's call the print method from the superclass vehicle. Okay, so let's run the code, and you see the results right here in the console. Type, motorcycle, model, Kawasaki, and max speed 180. Excellent, excellent. Method overriding. So if you define a method in a subclass that is already defined in the superclass with the same name, same parameter, and the same return type, that is known as method overriding. So in this case, the method in the superclass is called an overridden method, and the method in the subclass is called the overriding method. So let's just do a simple example to understand it better. So let's say we have two classes, right? A superclass vehicle and a subclass car. The car class extends the vehicle class. Now, both of the two classes have a common method, right? The void stop. The car class gives its characteristic to the stop method. So it overrides the stop method. It prints the car has stopped instead of vehicle has stopped. Got it? Cool. Let's do up some examples so that you can play along with me and understand the benefits of method overriding. So in the object-oriented programming project, just right-click on the source folder and select New and Class. Specify a package name as Method Overriding and the class name as Vehicle. Now, Vehicle is our superclass. And then let's declare 3 public void methods in the vehicle class. First one is public void start. We print the vehicle has started message using the print method. And then the second one is public void accelerate. So this method takes one parameter that's named speed. And then we can print vehicle accelerates according to given speed. And then we use the speed variable in the print method. And then the last method is stop. In the stop method, we print vehicle has stopped as our message by using the print method. Okay, so remember to save the code. Right. Now let's create a new subclass. So just right-click on the method overriding package and select New Class. Specify class name as car. And in order to implement the method overriding, we have to add extends as our keyword after subclass car. Now our subclass car extends the superclass vehicle. So this means that subclass car inherits all the methods from the superclass vehicle. And the car class is empty now. So the question is, why do we need this method overriding? What we'll do here is let's create a main test class that we'll name override test in the same package. So in the main method, we create a vehicle object. First, we call the start method from the vehicle class. And then we call the accelerate method by passing the value of 80 of speed as a parameter. And then the last we'll call the stop method. Okay, so let's run the code. So you see the results in the console. Yeah? The vehicle has started. Vehicle accelerates at a speed of 80. And the vehicle has stopped. Now let's create a car object to test. And we call the start method and then call the accelerate method by passing the speed value of 100 as a parameter and then call the stop method. Okay, so let's run the code. And you see the same results. The vehicle has started. Vehicle accelerates at a speed of 100 and the vehicle has stopped. But now, do you see it? There is a problem. We wait on properties of car, not vehicle in the second part. So we need to override the methods of the superclass vehicle in the subclass car. So let's override these methods, and you'll see what I mean. Open the car class. Now let's copy the methods of the superclass vehicle, and let's make the changes for implementing the properties of the car class. So we print car has started in the start method instead of vehicle. And we print car accelerates according to given speed instead of vehicle. And then we print the car has stopped in the stop method instead of vehicle. So you see, I'm doing here these three methods have the same name, same parameter, and same return type with methods in the vehicle class. This is a rule for overriding. So remember to save the code. All right, so let's open the main class, override test, and let's run the code. And you see two different messages coming from the methods of classes. In the first part, we display messages from the superclass vehicle. In the second part, since we override the methods of the superclass vehicle in the class car, car has started, car accelerates at speed 100, and car has stopped are the messages that are displayed. So I hope that's clear as mud and you understand method overriding. It's very useful. Super and this keywords. Super is a keyword that's used to access the superclass members from the subclass. Super as a keyword gives us simple access to constructors, fields, and methods of the superclass. So in our example, subclass car class is using a super keyword to access stop method of the superclass vehicle, right? This keyword is used to access the same class members inside the same subclass. In our example, subclass car class is using this keyword to access its own start method. So we can also access other members of this class, such as variables and constructors, using similar methods. Let's see some examples of using the super and the this keyword. So we're going to open the object-oriented programming project by right-clicking on the source folder and then selecting New, Class, and then specify the package name as super this, and the class name as vehicle. So the vehicle class is a superclass. So let's declare 3 instance variables in the vehicle class. We declare 2 variables that are named type and model with a string type, and the variable max speed with int type. Let's declare a public constructor that's named vehicle, and we'll give it 3 parameters, type, model, and max speed. So in the constructor method, we can assign a parameter variable type to the variable type of this class. And we assign the parameter variable model to the variable model of this class. And then the last one, we'll assign a parameter variable max speed to the variable max speed of this class. So we use the this keyword to access the same class variables. So let's generate the public getter methods of these variables to access from the main method. Now, in order to generate getter methods, we can just right-click on the file and select Source, Generate Getters and Setters. And we choose Get Methods of all variables, and then click on the Generate button. And all selected getters methods will be generated automatically. And remember to save the code. Okay, so let's create a new subclass. So right-click on the Super This package, and then select the new class. Specify the class name as car. Our subclass car extends the superclass vehicle. So this means that the subclass car inherits all the methods and variables from the superclass vehicle. Now look at this, we get a compilation error. So if you hover the mouse on the car class, Eclipse will show you a quick fix dialog, and we defined a constructor in the superclass vehicle. So now we must define an explicit constructor in the subclass car, and we must invoke the superclass constructor from this constructor by using the super keyword. So we can add a constructor by selecting the Add Constructor in the Quick Fix dialog of Eclipse. Told you Eclipse was handy. So Eclipse automatically added the constructor with super as our keyword. Okay, so now in the class car, let's declare the variable is automatic with the Boolean type. So its initial value is false. And then we add the variable is automatic to the constructor of the car class as a fourth parameter. And then we assign a parameter variable is automatic to the variable is automatic of this class. Now, we need to generate a getter method again of the variable is automatic in order to access it from the main method, right? And I know you like to do this, so we generate the getter method of the variable using the same way we did before. See, you're getting the hang of it, huh? Remember to save the code. And let's create a main test class that's named Super This Test in the same package. Now, in the main method, we create a car object by passing parameters. The first parameter, car, represents type of car. Second parameter, Ferrari, represents model of car. The third parameter, 320, represents the max speed of car. And the last parameter, true, represents is automatic of that car. So we print the properties of the car class by using the print method. And in the first print method, we display the type of car and invoke the getType method from the superclass vehicle. In the second print method, we display the model of the car and invoke the getModel method from the superclass vehicle. And in the third print method, we display the max speed of the car and invoke the getMaxSpeed method from the superclass vehicle. Now in the last print method, we display the is car automatic or not. So we invoke the is automatic method from the subclass car. Great. So, okay, it looks great. So let's run the code. And you see the results right here in the console. Type is car, model is Ferrari, and the max speed is 320. And these properties come from the superclass vehicle. But car is automatic is true. That's right, because this property comes from the subclass car. Final keyword. It's not the final keyword, but it is final as a keyword. Now, as I hope that you remember, and I'm sure that you understood at the time, in the inheritance subject, the inheritance provides reusing existing codes, but sometimes we need to limit some of the properties for, well, many, many reasons. The final keyword allows us to do this. So think of it as a limiter. In this section, we will look at what the final keyword actually means for classes, methods, as well as variables. The final keyword can be implemented in class, methods, and variables. Final classes cannot be extended. So if we try to inherit from a final class, we get a compile error. Java core libraries have many final classes. Final methods cannot be overridden. So when we design a superclass and we want to make sure that the method in this class won't be overridden, we'll make this method final. Final variables cannot be altered. So we can initialize a final variable, but we cannot reassign a new value. So final variables are used to create constant variables. Okay, great. So let's do some examples so that we can both understand this a little bit better. Just kidding. So in the object-oriented programming project, right-click on the source folder and select New, Class. Specify the package name as final keyword and the class name as vehicle. Vehicle class is a superclass. Now let's declare an instance variable that's named model with a string type in vehicle class. And let's declare a void method, show max speed. And then we print max speed of vehicle is 180 as a message. How? Using the print method. And remember to save the code. Okay, so now we can create a new subclass. So right-click on the final keyword package and select New Class. Specify the class name as car. So our subclass car extends superclass vehicle. So this means that the subclass car inherits the show max speed method and the model variable from the superclass vehicle. Now in the car class, we can override the max speed method of the superclass vehicle. And we can print the message, max speed of car is 320, by using the print method. So remember to save the code. Now we want to limit some properties by using the final keyword. So let's open the vehicle class. For example, if we add the final keyword to a class definition of superclass vehicle, then save the code. So let's open the car class and see we get the compilation error. So let's look at it by just hovering your mouse over vehicle. And the error message is the type car cannot subclass the final class vehicle. So remember, final classes cannot be extended. I thought that sounded familiar somewhere. So we'll select Remove Final modifier of the vehicle class. And now let's open the vehicle class. And you see, Eclipse automatically removed the final keyword. For example, if we add the final keyword to a method definition of superclass vehicle and save the code, let's go ahead and open the car class, and we get a compilation error. So let's look at that. Placing the mouse over show max speed. Okay, so there's the error message. You cannot override the final method from vehicle. So, final method cannot be overridden. You thought I was making this stuff up. So, we'll select remove final as a modifier vehicle dot show max speed method, and then save that code. So now let's create a main test class that's named final test in the same package. And in the main method, we create a car object. So first, let's open a vehicle class and add a final keyword to the variable model. Now we have to initialize this variable. So we just initialize the string with double quotes. And remember to save that code. Now let's open the main class again. So if we assign Ferrari as the value to our variable model, we get a compilation error. So let's look at that by hovering the mouse on the model variable. And the error message is the final field vehicle.model cannot be assigned. So final variables cannot be altered. So now we will select remove final modifier of model and save the code. Now let's call up show max speed. Okay, so run the code. Now you see the result in the console. Overridden show max speed method is invoked and it displays the max speed of the car is 320. Abstract classes. So an abstract class is used to implement common features of related classes. So it's declared with the abstract keyword. If a class has at least one abstract method, then the class must be declared abstract. Also, abstract classes may contain non-abstract methods and variables. You cannot instantiate an abstract class. That means that you cannot create the object of it. So in order to use abstract as a class, we have to inherit it from another class. So you can think of an abstract class as like a template. You must extend it and override the abstract methods. An abstract method is also just a prototype. So it has no body and contains the following attributes: a return type, a method name, and a list of parameters. Methods and members of an abstract class can be defined with any visibility, such as public, protected, private, etc. So in our example, vehicle is an abstract class that contains only one abstract method. Get max speed, right? Remember, it's got no body. Because the implementation of this method is provided by the car and motorcycle classes. You were wondering why that was empty, huh? No body. So the car and motorcycle classes have to override the abstract getMaxSpeed method of the superclass vehicle. Okay, so I heard a couple of pennies drop. So let's do up some examples and we can understand the abstract class a little better. So in the Object-Oriented Programming project, right-click on the source folder and select New Class. Specify the package name as Abstract Class and the class name as Vehicle, and choose Abstract to create the abstract class. The Vehicle class is an abstract superclass. So let's declare two instance variables that are named type and model with the string type in Vehicle class. So let's declare a public constructor that's named Vehicle, and it contains two parameters, type and model. Now in the constructor method, we can assign a parameter variable, type, to the variable type of this class. And then we assign parameter variable model to the variable model of this class. And now we can use the this keyword to access the same class variables. Now let's declare two non-abstract void methods in the Vehicle class. First one is public void start. And then we print the message Vehicle has started by using our print method. So the second one is public void stop. And then we print the message Vehicle has stopped by using the print method. Now we can declare an abstract int method that's named getMaxSpeed with no body. And now we must implement this method in the subclass. And here's where you remember to save the code. Okay, so now we're ready to create a new subclass. So just right-click on the abstract class package and select New Class. And then specify the class name as car. Now our subclass car extends the abstract superclass Vehicle. So this means that the subclass car inherits all the methods and variables from the superclass Vehicle. But wait, we get a compilation error. So what do? We just place the mouse on the car class and Eclipse shows us the quick fix dialog. So we defined a constructor in the abstract superclass Vehicle. So that means we must define an explicit constructor in the subclass car. And we must invoke a superclass constructor from this constructor by using the super keyword. So we can add the constructor by selecting the Add Constructor in the Quick Fix dialog of Eclipse. And look at that. Eclipse auto-magically added the constructor with the super keyword. Now also, if you go back and place the mouse pointer on the car class, Eclipse will show us this quick fix dialog. So we must implement the abstract method getMaxSpeed in the car class. So we select the Add Unimplemented Methods, and then Eclipse automatically added getMaxSpeed as a method with the override annotation. So let me give you a little bit of history. Way back in Java 5, annotations were introduced. So an annotation always starts with the @ symbol, followed by the annotation name. So whenever you override a method of a superclass, it's always best practice to include the override annotation. The override annotation is also used for making code readable as well as avoiding any maintenance issues down the line. So now that we're having fun, let's override some other methods of the superclass vehicle. Now, there's no obligation to override non-abstract methods of abstract superclass vehicle. So let's copy the non-abstract methods of the superclass vehicle, and let's make some changes for implementing properties of the car class. So we use the car has started in the start method instead of vehicle, and we use the car has stopped in the stop method instead of vehicle. So let's add the override notation to these methods. In the getMaxSpeed method, we declare a final variable, max car speed, in uppercase letters, and then assign this variable to 320. Now, it really is good to get in the practice to use final variables using all uppercase letters and underscores as a separator. So now we print max speed of car by using the print method. And then return the variable max car speed. Remember to save the code. Now let's create a main test class that's named abstract test in the same package. So in the main method, we create a car object by passing parameters. The first parameter, car, represents the type of car. The second parameter, Ferrari, represents the model of the car. Now let's call the overridden start and stop methods from the subclass car. And let's call the overridden abstract getMaxSpeed method from the subclass car. Okay, so let's run the code. And you can see the results right here in the console. Overridden start method was invoked, and car has started is the message that we see displayed. And then the overridden stop method was invoked, and the car has stopped message was displayed. And then the overridden abstract getMaxSpeed method was invoked, and the max speed of car is 320 message was displayed. Interfaces. Interfaces are a set of common behaviors that are implemented by multiple classes. Interfaces can only have constants and methods without a body. So the interface really can't do anything, it's just a pattern. You cannot instantiate an interface, so it means that you cannot create the object of it. An interface does not contain any constructors. An interface is not extended by a class. It is implemented, however, by one or more classes. A class can implement multiple interfaces. So basically, an interface simply is saying, I can do these things, right? So we give a promise to the compiler, so to speak. So in our example, we first define drivable as the interface. So this interface has two methods that are named turn left and turn right with no body, right? Car and motorcycle are the classes that implement this interface. So it means that both of the classes can turn left and can turn right. So the turn left and turn right methods, they must be implemented in the car and motorcycle classes. It's an absolute obligation. All right, so I think that's pretty clear. Why don't we do up some examples with an interface? So go back to the object-oriented programming project, right-click on the source folder and select New Interface, and specify a package name. So let's call it interface class. And then the interface name, derivable. So an interface only declares method names without a body. So we must implement all methods of interface. So let's declare two void methods with no body in the drivable interface. So the first method is turn left, and the second method is turn right. Remember to save the code. Okay, so let's create a new subclass. So right-click on the interface class package and select New Class. Specify the class name as car. Now we can add implements as a keyword after the class definition of car. Car implements drivable means that turn left and turn right are the methods in the drivable interface, and they must be implemented in the car class. But hold on, you say, we get a compilation error. So let's hover the mouse pointer on the car class, and Eclipse shows us a quick fix dialog. Okay, so we must implement an abstract method turn left and turn right in the car class. Okay then. So then we select Add Unimplemented Methods, and then Eclipse automatically adds these methods with the override annotation. You thought I was losing my mind. So let's fill the rest of these methods. In the turn left method, we print car can turn left as a message by using the print method. In the turn right method, we print car can turn right as our message by using the print method, and we save the code. Okay, so now let's create a new subclass. Just right-click on the interface class package and specify the class name as motorcycle. And we add the elements keyword after the class definition of motorcycle. So motorcycle implements drivable, means that turn left and turn right are the methods in the drivable interface that must be implemented in the motorcycle class. And now we select the Add Unimplemented Methods to add the methods of interface with the override annotation. All right, so let's fill in these methods just like we did in the car class. In the turn left method, we print motorcycle can turn left for our message by using the print method. And in the turn right method, we print the motorcycle can turn right message by using the print method. And remember to save the code. Now let's create a main test class that's named interface test in the same package. So in the main method, first we create a car object. So let's call the overridden method turn left and turn right from the class car. Secondly, we create a motorcycle object. And then let's call the overridden method turn left and turn right from the class motorcycle. Okay, are you ready? Let's run the code. And look at that. You see the results right there in the console. The car can turn left and the car can turn right. The motorcycle can turn left and the motorcycle can turn right. See, autonomous vehicles are very easy to program. That's just a joke. Polymorphism. So polymorphism, because I promised I'd tell you about it, is used to perform a single action, but in different forms. So in Java, we have two types of polymorphism. The first one is static, and the second one is dynamic. So method overloading is an example of static polymorphism. Method overriding is an example of dynamic polymorphism. So in the slide here, you can see dynamic polymorphism. So for example, we have a vehicle superclass, and it has an accelerate method. And we have two subclasses that override the accelerate method of the superclass vehicle. And accelerate works for any type of vehicle, right? Not only a car, but also a motorcycle. The accelerate action is done different in a different form in the car and motorcycle classes. So when we create an object of the subclass and then assign it to the superclass reference, if we call the overridden accelerate method on the superclass vehicle reference, then the overridden method of the subclass will be called. So let's say if we want to create two objects, vehicle equals new car. Now that's a statement that works because car is a subclass of vehicle, okay? So here the reference variable, vehicle, declared the type of vehicle is pointing to an object of the car class. So in the same way, vehicle1 equals new motorcycle. That works as a statement because motorcycle is a subclass of vehicle as well. So here the reference variable vehicle1 is declared type vehicle is pointing to an object of the motorcycle class. And this very useful feature of Java is named polymorphism. So now to bring it home, let's do up some great examples so that we can understand polymorphism in all of its flavors. So we implemented static polymorphism that includes the method overloading in the method section. So we will implement dynamic polymorphism that includes the method overriding in this exercise, okay? So go back to the object-oriented programming project, right-click on the source folder and select New Class. Specify the package name as polymorphism and the class name as vehicle. And the vehicle is our superclass. So now let's declare a public void method that's named accelerate in this class. And then we print vehicle is accelerating for the message using the print method. And remember to save the code. Okay, so let's create a new subclass. So just right-click on the same package and then select New Class. And then specify the class name as car. So our subclass car extends the superclass vehicle. And this means that the subclass car inherits the accelerate method from the superclass vehicle, right? So now let's override this method. We can start with the override annotation, but it's not mandatory here. We'll write accelerate as the method again to override. Now in this method, we can print car is accelerating for a message, and we save the code. Okay, so now let's create a new subclass. So right-click on the same package and select New Class. Specify the class name as motorcycle. And our subclass motorcycle extends the superclass vehicle. So now we write the accelerate method to override by adding the override annotation. And then in this method, we print the message motorcycle is accelerating, and then we save the code. Okay, so let's create a main test class that's named test in the same package. In the main method, first, create a vehicle object reference by pointing to the car class. And this code works because car is a subclass of vehicle, right? So the class vehicle is extended by the class car, and its method accelerate is overridden in the class car. So in this definition, the reference variable vehicle is pointing to an object of the car class. So if we call the accelerate method, it will print the car is accelerating message. You don't believe me? Let's run the code. And you can see it right here in the console. Car is accelerating is the message you see here displayed. So second, let's create a vehicle 1 object reference by pointing to the motorcycle class. So in this definition, the reference variable vehicle 1 is pointing to an object of the motorcycle class. So now if we call the accelerate method, it will print the motorcycle is accelerating message. Okay, so let's run the code again. And look at that, you see in the console, the motorcycle is accelerating message. What are the odds? Encapsulation. Encapsulation is one of the fundamental principles in object-oriented programming, and it's used to restrict visibility of the class members to the others. So in our example, we have vehicle class, and we define the model and the max speed variables as a private modifier. Now, if you define a variable or method with the private modifier, you can access these components from the current class only. So, we have only one way to interact with class properties, and that is through its public methods. That makes sense. Now, we define the public setter and getter methods of the max speed variable, so it can be accessed from outside the class. But we have no public setter and getter methods of the model variable, so it can't be accessed from outside the class. So why don't I show you some examples, and it'll help you to understand encapsulation. So in the Object-Oriented Programming project, just right-click on the source folder and then select New, Class, and specify the package name as Encapsulation and the class name as Vehicle. Vehicle class is a superclass. So let's declare 2 instance private variables that are named model with a string type and max speed with an int type in vehicle class. Now, private means that these variables are visible to the current class only. So now let's declare a public constructor that's named vehicle, and let's assign 2 parameters, model and max speed. So in the constructor method, we assign a parameter variable model to the variable model of this class. And now we assign a parameter variable max speed to the variable max speed of this class. And now we use the this keyword to access same class variables. Okay, so now let's generate the public getter and setter method of the variable max speed to access from the outside. Now, in order to generate getter and setter methods, we just right-click on the file and then select Source, Generate Getters and Setters. And we'll choose the variable max speed, and then click on the Generate button. So all selected getter and setter methods of the variable max speed are generated automatically. Now, we don't want to generate getter and setter methods of the variable model now, because what we'll do is we'll test it in the main method. Okay? Okay, so let's save the code. Now, let's create a new subclass. Just right-click on the same package and then select New Class. Specify the class name as car. And our subclass car extends the superclass vehicle. And what's this? We got a compilation error. So just hover your mouse on the car class, and what happens? Eclipse shows us a quick fix dialog. And then we define a constructor in the superclass vehicle. So we must define an explicit constructor in the subclass car. And we must invoke the superclass constructor from this constructor by using the super keyword. Now we can add the constructor by selecting Add Constructor in a quick fix dialog of Eclipse. And then Eclipse automatically added the constructor with the super keyword. All right, so in the class car, let's declare a private variable is automatic with a Boolean type. So that means its initial value is false. And now we add the variable is automatic to the constructor of the car class as a third parameter. And then we assign the parameter variable is automatic to the variable is automatic of this class. Now we don't want to generate getter and setter methods of the variable is automatic now because we're going to test it in the main method. So instead, let's create a main test class that's named encapsulation test in the same package. So in the main method, we create a car object by passing parameters. The first parameter, Ferrari, represents the model of car. Second parameter, 320, represents the max speed of the car. And the last parameter, true, represents is automatic of that car. And now we can print the properties of the car class by using our print methods. So in the first print method, we display the model of the car. And then we try to invoke the getModel method from the superclass vehicle. But we cannot access this method because we have no public getter method available of the variable model in the vehicle class. So let's open the vehicle class and generate getter and setter methods of the variable model in the same way. Okay, so Eclipse has added public getter and setter methods of the variable model. So we'll save that code. And now let's open the main class again. And let's try to invoke the getModel method. Okay, so we can access this method. And now in the second print method, we display the max speed of car and invoke the getMaxSpeed method from the superclass variable. So we can access this method because we defined the getter method in the vehicle class. Make sense? So in the last print method, we'll display is car automatic or not, and we invoke the isAutomatic method from the subclass car. Oh, but we cannot access this method because we have no public getter method available of the variable isAutomatic in the car class. So let's open the car class. And here is where we generate the getter and setter methods of the variable isAutomatic, the same way we did before. Okay, so Eclipse added the public getter and setter method of the variable isAutomatic. Remember to save that code. So let's open the main class again. Let's try to invoke the isAutomatic method. All right, so we can access this method. So now let's go and run the test code. And here you see the results right here in the console. Model is Ferrari, and max speed is 320. So these properties come from the getter methods in the superclass vehicle. But car isAutomatic is true. This property comes from the getter method of the subclass car. So now in this section, we will learn wrapper classes, autoboxing, and unboxing. So first up, we're going to learn what the wrapper class is. Then we'll cover conversion of primitive types and wrapper classes. And then we'll go over autoboxing and unboxing concepts that come with Java 5. What is wrapper class? Now there's an obvious joke in here, but I want to stay as serious as can be. Wrapper classes are used for converting primitive data types into objects, like byte to byte, int to integer, char to character, etc. The primitive data types are not objects, so they don't belong to any class, and they are defined in the language itself. So sometimes it's required to convert data types into wrapper objects in the Java language. So the primary benefit of this process is the wrapper class of a particular primitive type can hold a lot of information, and it provides useful functions, such as conversion from one type to another, and all other suitable functionalities, in fact. You can see the wrapper classes of primitive types on this table here. The wrapper classes are defined in the java.lang package. Conversion. So we basically have two types of conversion. First one is primitive type to the wrapper class, and the second one is the wrapper class to primitive type. In the first type, we use two different ways for converting a primitive type into an object of the corresponding wrapper class. The first way is by using a constructor. As you see here in the example, we use constructor of the integer wrapper class to convert int primitive type to the integer wrapper class. So the second way is using a static method of the wrapper class. And as you see in the example, we use the value of static method of the integer class to convert the int primitive type to integer wrapper class. So the value of method returns an instance representing the specified int value. The second type, we use a way to convert wrapper class into a primitive type. So we can use the corresponding methods to get the primitive type. For example, int value, double value, short value methods. And there's some others. With Java 5, this conversion is done automatically by using autoboxing and unboxing. Let's have a look at these concepts. Autoboxing, unboxing. Now, before autoboxing and unboxing, type conversion was being done manually, as you saw on the previous slide. But since Java 5, the whole process happens automatically without having to write any code for conversion. Saves a whole lot of time, frees up your brain for other stuff. Java provides two features called auto-boxing and auto-unboxing. Okay? So let's have a look, see what they are. So when Java automatically converts a primitive type like int into a corresponding wrapper class object, for example, integer, it's called auto-boxing. When Java automatically converts a wrapper class like integer into a corresponding primitive type, for example, int, then it is called auto-unboxing. Pretty straightforward. But let's do some examples with auto-boxing and unboxing, and then you'll see it clearer. So in the exercise project, just right-click on the source folder and select New, Class. Specify the package name as boxing and the class name as auto-boxing unboxing, and select the checkbox for the main method. And now let's declare a variable that is named db with the wrapper class double and assign the value to 12.8. All right, so this is auto-boxing of double. Because the conversion of the primitive double data type into wrapper, the double data type is done automatically. So let's declare a variable that's named d with the primitive double type, and then assign the variable db to it. And now this is auto-unboxing of double, because the conversion of primitive data types into corresponding wrapper data types is done automatically. Automatic conversion. And now let's print the value of the variable db and d by using our print method. Now, in another example, let's declare a variable that's named in with the wrapper class integer, and then assign the value of 5 to it. And this is auto-boxing of int. So let's declare a variable that's named I with a primitive int type and assign a variable in to it. And this is auto-unboxing of integer. And then we print the value of the variable in and I by using the print method. And then in the last example, let's declare a variable that's named ch with the wrapper class character and assign a value, the letter b, between single quotes, and this is auto-boxing of char. So let's declare a variable that's named c with a primitive char type, and then assign the variable ch to it. This is auto-unboxing of character. And then we print the value of the variable ch and c by using the print method. All right, so let's run the code. And look at that, you see the following results in the console. So in this section, we will finally learn, I know you've been waiting for it, strings in Java. First, we'll learn string class in detail, and then we'll learn how to create a string object. Then we'll go over a bunch of useful methods for the string class. And then we're going to cover why string is immutable. And then we're going to introduce string buffer as a class, and we'll learn how to create a string buffer object. And then we will introduce the string builder class, and we're going to learn how to create a string builder object. So here's what you've been waiting for. Let's get to it. What is string? So a Java string is a series of characters, like the word hello or the phrase Java is funny. Okay, a string is created between double quotes. So in our example, It shows a string object in memory. It consists of individual characters, hello. The chars in a string are identified by index numbers. So in hello, the leftmost character, H, is at index 0. The next character, E, is at index 1, and so on and so forth. Good. So we will do a whole lot of examples related to the string index by using some string methods. Creating string objects. Now, there are two ways to create a string object. First one is string literal. The string literal is probably the easiest and certainly the most recommended way to create strings in Java. So in this way, we simply assign the characters in double quotes to a variable of the string class. And then each time when you create a string literal, the Java virtual machine first checks the string pool in the heap memory. If you've been paying attention, you know exactly what I'm saying. But if the string already exists in the pool, a reference to the pooled instance is returned. So if the string doesn't exist in the pool, a new string instance is created and then placed in the pool. So string literal provides memory efficiency, because if the object already exists in the string pool, then no new objects have to be created. So now let's try to understand how objects are created by using string literals and string object by looking at our examples in this here slide. So the first line, string str1 equals hello. And here, the string object is created only in the string pool, as you see in the diagram. And str1 is the object that refers to it. On the second line, string str2 equals hello. And here, a new string object in the string pool will not be created because the string pool already contains the same object with the string hello. So the str1 object refers the same string method in the string pool. Now, on the third line, string str3 equals example. So here, a new string object with the string example is created in the string pool because the string pool doesn't already contain the object with the string example. Cool. Now, another way to create a string object is the string object. We create a string object by using the new keyword. So it creates two objects and one reference variable. So this variable refers to the object in the heap. And as you can see in this diagram in the last line, the new string object with the string Java is created in heap. Also, the same string object is created in the string pool because, of course, the string pool doesn't contain the object with the string Java. However, str4 refers to only the string object in heap, not the string pool. Follow? Well, let's do up some examples with strings. First off, let's create a new Java project and specify the project name as string. Now, don't change any of the other options and just click on the next button. And in this section, just uncheck create moduleinfo.java file and then click on the finish button. So in this project, just right-click on the source folder and select New Class. And specify the package name as string and the class name as string example. And then select the checkbox to add a main method. And now let's create two string objects by using the Java string literal. The first one will declare variable s and assign it a value of Java programming. The second one will declare variable s1 and assign it a value of Java programming again. Now let's create two string objects by using the new keyword. Now we create string objects SOBJ and SOBJ1 by using the new keyword with the string Java programming. So now we print these objects by using the print methods. In the first print method, we will print object S. In the second print method, we will print object S1. In the third print method, we will print the object SOBJ. And in the third print method, we will print object SOBJ1. Okay, so let's run the code. So here you see the same result. Java programming is the value in the console. But I know you want to take a deeper look, so let's compare these string objects by using the equality operator as well as the equals method. Now, while the equality operator matches the references of objects, the equals method matches values or the contents of objects. So both the equality operator and the equals method return Boolean values that are true or false. The equals method returns true if two string objects contain the same content or values. The equality operator returns true if two references refer to the same object. So in the first print method, we will print the result of S equals to S1 by using the equality operator. And then we will print the result of the expression S equals to SOBJ by using the equality operator. Then we'll print that result of the expression S equals S1 by using the equals method. And then we will print the result of the expression S equals SOBJ by using the equals method. And then we will print the result of the expression SOBJ equals SOBJ1 by using the equality operator. Let's do another one. Then we'll print the result of the expression SOBJ equals SOBJ1 by using the equals operator. So let's see. Yes. Okay, good. So let's run the code. And you see the results right here in the console. S equals S1 is true because both S and S1 refer to the same object. S equals SOBJ is false because S and SOBJ refer to different objects. S equals S1 is true because S and S1 have the same contents. S equals SOBJ is also true because S and SOBJ have the same contents. SOBJ equals SOBJ1 is false because SOBJ and SOBJ1 refer to different objects. SOBJ equals SOBJ1 is true because SOBJ and SOBJ1 have the same contents. Useful methods of string class. So the string class provides many useful methods to perform string operations. Just have a look at this table. Char at method that returns a char value for the particular index. It takes an index parameter with the int type. The length method returns the length of a string. It actually has no parameter. The substring method comes with 2 signatures. If we pass only the beginning index, it returns a substring from the begin index to the end of the string. If we pass the begin index and the end index to the method, then it returns a substring given the starting index and the length of the result. The equals method compares the string with the specified string and then returns true if the 2 string objects contain the same contents. Otherwise, it's false. The isEmpty method returns true if the given string has 0 length. If the length of the string is non-zero, then it returns false. The concat method concatenates the specified string, str, at the end of the string. The toLowerCase method returns a string in lowercase. The toUpperCase method returns a string in the uppercase. So why don't we do up some examples with the most useful string methods? In the string project, just right-click on the string package and then select New Class. Specify the class name as string methods, and then select the checkbox for the main method. Now, in this exercise, we will practice with string methods to understand a little bit deeper, a little bit clearer. So we'll start to declare 2 string variables and a string array. So the first one, we declare variable S1 and assign it a particular value, Java programming language. And the second one is we declare the variable S2 and assign it a value of hello. Now we declare a string array that's named S3, which actually has no initial value. So now in the first print method, we print the value of string 1, S1. And then we use the char at method to find the first character of string S1. So the 0 index gives us the first character of string. Then we can use the length method to find the length of string S1. And then we'll use the substring method to get the first 5 characters. Then we use the equals method to compare the objects S1 and S2. Then we'll use the isEmpty method for checking string S1, see whether it's empty or not. Then we use the concat method to concatenate the strings S1 and S2. Then we use the toUpperCase method to get the string S1 into uppercase letters. And then we use the toLowerCase method to get the string S1 into lowercase letters. Then we can use the split method to split the string S1 based on space. In the split operation, we assign the result of the split method to the string array S3. And we can use the for each loop to print all the characters of a string. And then finally, we can use the replace method to replace part of the string with some other string. In the replace example, let's say we want to replace the letter V in lowercase to the letter V in uppercase. Cool. Now in the print method, we can use the backslash character and the letter N. So it's used to insert a new line into the text at this particular point. All righty then. So let's run the code. And you see the following results right here in the console. The value of the string is Java programming language. The length of the string is 25. That means that a total number of characters of the string S1 is 25. Substring is programming language because the first 5 characters of the string are cut by the substring method. And is equals is false because S1 and the S2 objects have different contents. Is empty is false because string S1 has no content. Concat is Java programming language hello. We concat string S1 and S2 objects. Uppercase is Java programming language in all uppercase letters. And the lowercase is Java programming language in lowercase letters. Now look at this. After the split method, Java programming language is displayed without a space. And the last one, after the replace method, remember we changed the letter V in uppercase in the first word, Java. So yeah, in this lecture we did some examples to understand differences with string methods. The string class also has lots of methods, and I would really recommend that you should do some more exercises with them. Get to know them. They'll be your best friend. Immutable string in Java. So in Java, string objects are immutable. Immutable just means that you cannot change the object itself, but you can change the reference to the object. Once a string object is created, its data or its state can't be changed, but a new string object is created. So let's try to understand the immutability concept by the example here in this slide. So we declare a string object S with Java as its value. This new string instance is created and it's placed in the string pool. So what if we use concat as our method to append the string with the program value at the end? Also, new object is created and placed in the pool. And as you see here in the figure, 2 objects are created, but reference variable S still refers to Java, not Java program. Because, say it with me, strings are immutable objects. So we'll introduce with string buffer and the string builder classes, which are also immutable, in the upcoming slides. String buffer class. Java string buffer class is used to create mutable or modifiable strings. So at any point in time, it'll contain some particular sequence of characters, but the length and the content of the sequence can be changed through certain method calls. So it's the same as the string class, except it's mutable. So the value of the string buffer object can be changed. It also means that it can be assigned to the new value. In our example, we define str buffer as an object with the Java value, and this object is stored in heap memory, and its value can be changed. And we can use the append method of the string buffer class. And what that does is it appends the value program to the end. And then it modifies the value Java program, which is allowed in the string buffer. So why don't I show you some examples with the string buffer. So in the string project, right-click on the source folder and select New Class. Specify the package name as string buffer and the class name as string buffer example, and then select the checkbox for main method. So in this exercise, we will practice with the string buffer methods to understand more clearly. So why don't we just create a string buffer object and name it buffer with its value as welcome to. And then we use the append method to append the value Java. So the append method always adds these characters at the end of the buffer. Now, string buffer objects are mutable, as we were talking about before. That means they're changeable. So, after the append operation, the object buffer points out, welcome to Java. So why don't we go ahead and learn some other useful methods of the string buffer by using them in the print method. So in the first print method, we'll print the value of the object buffer. Then we use the length method to find the length of the object buffer. The length method is the same as the string length method. Then we can use the insert method to insert the value world into a string of this string buffer by adding the length method. The insert method adds the characters at a specified point. So we used the length method of the buffer as a specified point. So the value world will be added to the end of the buffer. Make sense? Then we use the reverse method to reverse the value of the string buffer object. The string class in Java does not have a reverse method. However, the string buffer and string builder class have built-in reverse methods. So then we can use the reverse method again to get the original string. Then finally, we can use the delete method to remove the first 11 characters in a substring of this string buffer. All right, I think we're pretty well set, so let's run the code. And you can see the results in the console. The new value of the buffer object is welcome to Java. The length of the buffer object is 15. Then after the insert method, the new value of the buffer object is welcome to Java world. And then after the reverse method, for the last value of the buffer object, the reversed string is displayed. So we used the reverse method again to get the original string. The original value of the buffer object is displayed. And then after the delete method, the first 11 characters are removed from the original value of string, and the last value, Java world, is displayed. So yeah, in this lecture, we did some pretty fun examples to understand the string buffer methods. And the string buffer class also has a whole bunch of methods. So I would advise you that you should do as many exercises as you can muster with all of them. It does get fun. String builder class. So string builder is kind of the same as the string buffer. It stores the object in heap, and it also can be modified. The string builder has the same methods as the string buffer, but each method in the string buffer is synchronized. That is, the string buffer is thread safe. So the main difference between the string buffer and the string builder is performance. The string builder is faster than the string buffer because the string buffer is synchronized. So in our example, we create str builder as an object with Java as its value. And this object is stored in heap memory, and its value can be changed. And we use the append method of the string builder class, and then this method appends the value program at the end, and it modifies the value Java program, which is allowed in the string builder. So why don't we do up some examples with string builder? So in the string project, just right-click on the source folder and select New Class. Specify the package name as string builder and the class name as string builder example. And then select the checkbox for main method. Now in this exercise, we will practice with string builder methods in order to understand them in depth and in better clarity. So we will not write these methods again. What we'll do is we'll use the string buffer methods because they have the same methods, right? So let's copy the code from the string buffer example class and paste it to the string builder example class. Now let's change the string buffer with string builder in object instantiation and comment on the code part. Eclipse has a quick shortcut for us to change the names of variables at the same time. So if we hit Control and 1 from the keyboard on the buffer word, Eclipse gives us suggestions for fixing problems. So we'll choose the Rename in File option and change the object name buffer with builder. So you can see this way is just perfect for changing names of fields. And what do you see in the code? All the methods of the string buffer class can also be used in the string builder class without any other change. Okay? So let's run the code. And there's your proof. The same results are in the console. So let's have a look at the differences between string, string buffer, and string builder. The string object is stored in the string pool, but string buffer and string builder objects are stored in heap. The string object is immutable in Java, but the string buffer and string builder are mutable objects. The performance of string and string builder is fast, but string buffer is slow. Because, do you remember? String buffer is a synchronized class. The string builder and string buffer are almost the same. The main difference is that the string buffer is synchronized and the string builder is not synchronized. So that means that the string builder is faster than string buffer, but the performance difference is negligible for small programs. Their functionality is the same. So if your program is used by multiple threads, then it's probably best to use string buffer. If your program is used by a single thread, then by all means, go ahead and use string builder. So when you learn the thread subject of Java next time, I certainly hope that you'll understand it better. But it's an advanced topic for what we're covering now. So congratulations, you have made it to our fourth project that we're doing together. So in this project, we will write a Java program that finds the reverse of a given string. So in the string project, right-click on the string package and select New Class. Specify the class name as reverse string, and then select the checkbox for the main method. And of course, we will use the scanner class so that we can get input from the user in Java. Now first, of course, we need to import the scanner class. So we choose Import Scanner Class in the java.util package to import the scanner class. And we get a message to enter the string by using the print method. So we declare a variable string with string type and assign the next line method of the scanner class to this string. Now the next line method is used to read the whole line. And we declare a variable length with the int type and assign the length of the string by using the length method. So let's declare another variable, reversed string with the string type, and its initial value is empty. Now we start to write a for loop. Now in for loop, we declare a variable I, and we assign length 1 as the expression to this new variable I. The loop condition is I is greater than or equal to 0, and I is decremented by 1. We use the char_at method to extract characters from the given string and then concatenate them in reverse order to reverse the string. So in the print method, we will display the resulting value of the reversed string. And we can close the scanner object. Okay, are you ready? Let's run the code. So let's enter the string Java is easy. So yeah, our string is reversed and displayed. What do you think? So in this program, we read a string from the user. Then, in for loop, we obtain the characters of the original string from the end by using char_at as the method of the string. and then we concatenate them into a new string by using the plus operator. And then finally, we print the reversed string. So in this section, let's talk about exception handling in Java. First, we're going to learn what is an exception, and then how to create exceptions in Java. Then we'll cover the difference between errors and exceptions. And then we'll talk about the types of exceptions. Then we'll learn try-catch block. Then we'll learn finally block. Then we'll learn how to use throw and throws as keywords. And then to wrap it up, I'll give you some useful exception methods. What is exception? An exception is a special type of error. So during the execution of a program, that means a runtime, it's something that disrupts the normal flow of the program's instructions. Abnormal conditions that occur while executing the program will cause exceptions. So while writing the program, these conditions are not known, right? So if you don't consider these conditions, the execution can be terminated abruptly. For example, division by 0 will cause an error in a program. The Java language provides an excellent exception handling mechanism. So these mechanisms minimize the chances of a system crash or abrupt program termination. So for this reason, Java is known as a robust language. The difference between error and exception. So an error is a critical condition that cannot be handled by the code of the program. An exception is the exceptional situation that can be handled by the code of the program. So the important difference between error and exception is that an error is caused due to the lack of system resources, and an exception is caused because of your code or program. But that's what you're here for, and that's what we're going to learn. So let's study some other differences between errors and exceptions along with a comparison chart. So let's have a look at these differences between error and exception in the table. So as you can see here on this table, in Java, errors are defined in java.lang.error as a package, and exceptions are defined in the package java.lang.exception. So an error is caused due to a lack of system resources, right? An exception is caused because of the code. So it's impossible to recover from errors, but you can recover from exceptions by handling them through try-catch blocks. So errors are classified as an unchecked type. Exceptions are classified as a checked or unchecked type. So if we want to give some examples of errors, the Stack Overflow error and an out-of-memory error is certainly a couple of the major ones. And if we wanted to think of a couple of examples of exceptions, we'll call it a class not found exception and the null pointer exception. So come along, I'll explain what I mean. So let's take a closer look at the hierarchy of the Java exception class. And as you can see here in the diagram, Object is the topmost class in Java. All the classes extend the Objects class by default in Java. That's why it's known as a superclass. So here, Throwable is the topmost class of the exception classes, and it's located in the java.lang package, Now, throwable has two subclasses, error and exception. And exceptions have been further categorized in two ways: built-in exceptions and user-defined exceptions. Now, all checked and unchecked exceptions are built-in exceptions of Java. So let's learn these exceptions in detail. Types of exceptions. There are three types of exceptions in Java. The first one is the checked exception. Checked exceptions are mandatory to handle. You've got to deal with them. Checked exceptions are generally caused by faults outside of the code itself, such as missing resources, networking errors, stuff like that. These exceptions are checked at compile time, so these are also called compile time exceptions. For example, that file not found exception. That is a checked exception, and it occurs when a file with the specified path name does not exist, or if the file does exist but for some reason is not accessible. The second one is unchecked exceptions. Now, they are not checked at compile time, but they are checked at runtime. So these are also called runtime exceptions. Now, when an unchecked exception is thrown, it is usually caused by a misuse of code, passing a null or otherwise incorrect argument. For example, arithmetic exception is an unchecked exception, and it occurs when you make an arithmetic error, such as dividing a number by 0, like we mentioned earlier. The last one is the user-defined exception. Now, in some cases, we need to define our own exception class for a special purpose based on particular application requirements. For example, let's suppose we have an account in a bank and we have $100 in this account. Now, let's suppose that we attempt to withdraw $150 from our account. And of course, we can handle this scenario by using the arithmetic exception in Java. But it's not particularly meaningful for the user. So in this situation, it is nice to display an error message that is related to insufficient funds. You get the meaning? So we can create our own exceptions in Java. We just need to extend the exception class in order to create our exception. User-defined exceptions are also called custom exceptions, and we'll do a bit of an exercise about these exceptions later. Try-catch block. So if we want to handle the exception ourselves, we can use a try-catch block. In Java, a try block is used to enclose the code that may throw an exception. So a try block consists of a set of executable statements. During the execution of these statements, exceptions can be thrown. Now, a method that may throw an exception can also be enclosed by the try block. So a try block is always followed by a catch block, and we handle the exception in the catch block. So one or more catch blocks can follow a try block. Now, in a catch block, we can use the exception object to print details of the exception. And as you can see here in the diagram, first, the try block is executed, and if the code in the try block throws an exception, the catch block is executed. Multiple catch blocks. So we use multiple catch blocks after a try block. A try block may be followed by any number of catch blocks. Each catch block handles a particular type of exception. Now, before Java 7, we used to catch multiple exceptions one by one, as shown in this slide. But with Java 7 and beyond, if a catch block handles a multiple exception, we can then separate them using a pipe And in this case, the exception parameter is final, so we can't change it. So this feature actually reduces code redundancy. Final block. So the Java final block is used to execute important code such as a closing connection, stream, etc. If an exception occurs in the program, the currently executing method may stop without completing execution. So in that situation, some codes, such as closing a connection, will just never get called. Java provides the finally block to deal with these exceptions. The finally block is always executed whether or not the exception is handled, and the finally block follows try or catch blocks. Now, sure, the finally block is optional, but this block is placed after the last catch block. And if you have a look at the diagram right here, first, the try block is executed, and then if the code in the try block throws an exception, the catch block is executed, and the finally block is executed. And then if the code in the try block does not throw an exception, the finally block is executed again. So let's make some of our own examples with exception handling so that we can deepen our understanding. So first, let's create a new Java project and specify the project name as exception handling. And don't bother changing any of the other options. Just click the Next button. Now in this section, just uncheck the Create Module Info.java file, and then press the Finish button. So in this project, just right-click on the source folder and select New Class. Specify the package name as Exception, and the class name as Exception Handling, and then select the checkbox to add to the main method. Now let's declare three variables with the int type. First, number 1, and assign it a 0. Second, number 2, and assign a 0 to that. And the last one, result, and assign that a 0. So we will use the scanner class for getting input from the user. And first, we need to import the scanner class. So we'll choose Import Scanner Class in the java.util package to import the scanner class. And we see a message to enter the first int number by using the print method, and assign the next int method of the scanner class to variable number 1. And we see a message to enter the second int number by using the print method. So let's assign the next int method of the scanner class to the variable number 2. Okay, so let's assign number/number2 as an expression to the variable result. And then let's print the value of the variable result by using the print method. And then finally, we should close a scanner object by using the close method. Okay, so you ready to run the code? So on the console screen, we'll enter 12 for the first number and 2 for the second number. The result is 6. All right, so let's run the code again. We enter Java as the text for the first number instead of an integer number. And there it is. See, so we got an exception that's named input mismatch exception. So you see that the program was terminated. So you see what's going on here, right? The next int method could not read the Java text that we entered as an integer, so it threw an input mismatch exception object. Now, the second print method message, enter second int number, was not executed. So we want to catch this error and then display our message in the console. Now we do that by using the try, catch, finally blocks. And a try block encloses a code which may throw exceptions. So let's enclose that code and let's see if it will throw an exception with a try catch block. The exception that might be thrown here is a input mismatch exception, and so a catch block has been provided to handle it. So we copy input mismatch exception from the console and paste it within the parentheses following the catch keyword. And then we import this class. We must declare an exception type object that's named E. And we will use this identifier to display an error in the next exercises, E for error. So in the catch block, we can display please enter valid number as our message by using the print method. Now let's run the code again. And in the console screen, we enter Java again. And the try catch block handles the exception, and the please enter valid number message is displayed. Cool. So let's run the code again. And in the console screen, we enter 12 for the first number and 0 for the second number. And there it is. We get an exception that's named arithmetic exception. So let's handle this exception in the second catch block. And we'll write arithmetic exception within parentheses following the catch keyword. Arithmetic exception, that's a class that is predefined in the java.lang package. So we don't need to import this class, right? So back in the catch block, we display second number cannot be 0 as a message by using the print method. Now let's run the code again. In the console screen, we enter 12 for the first number and 0 for the second number. The try catch block handles the exception, and the second number cannot be 0 message is displayed. Now, if any exception occurs except these two exceptions, we can use a superclass of all the exceptions that are named exception in order to handle it. So let's handle this exception in the third catch block. So we'll write exception within the parentheses following the catch keyword. The exception class is predefined in the java.lang package, so of course we don't need to import this class. In the catch block, we'll display an exception occurred message by using the print method. And then let's add the finally block after the last catch block. The finally block, by the way, is always executed. So in this finally block, we'll display this statement is always executed as our message by using the print method. So now we can run the code again. And in the console screen, we enter 12 for the first number and 2 for the second number, resulting in 6, and there is no exception. Finally block is executed and the message is displayed. So let's run the code again. And in the console screen, we'll enter Java for the first number. It worked so well before. Now the related catch block handles the exception, and please enter valid number is our message displayed. Also, the finally block is executed, and this statement is always executed is the message that's displayed now. So let's enclose the code with a do-while loop. First, we declare a variable isFlag with a Boolean type. Its initial value is false. And we use the variable isFlag in the while keyword. This loop continues until isFlag is true. So back in the code, after printing the result, we'll assign true to the variable isFlag, and if an exception occurs in the code, then the value of the variable isFlag will not be true, so the while loop will continue. Of course, if there is no exception in the code, then the value of the variable is set to true, and the while loop will be terminated. Okay? So why don't we run that code again, and let's enter Java for the first number. The catch block handles the exception, and the please enter valid number message is displayed. Also, the finally block message is displayed, and the while loop continues and asks us to enter the first number because the variable isFlag is false. So we enter 12 for the first number and 0 for the second number. The catch block handles the exception, and the second number cannot be 0 message is displayed. And also the finally block message is displayed, and the while loop continues and asks us to enter the first number because the variable isFlag is still false. So we enter 12 for the first number and 4 for the second number, resulting in 3. Division operation is done successfully. The variable isFlag is set true, and the finally block message is displayed, and the loop then terminates, because the value of the variable isFlag is true. Throw keyword. So we can use the throw keyword to explicitly throw an exception from the code. We can throw either checked or unchecked exceptions this way. And the throw keyword is used in the following method. We'll look at a basic example about throwing an exception from the method. So what you see here is a divide method that returns a double value in this slide. Now, in the method, because we can't divide a number by 0, we'll add throw arithmetic exception and pass a single string constructor parameter, which is the exception message divider cannot be equal to 0. So in our program, we can handle this exception by using our try-catch block. So why don't we do an example with the throw keyword? So in the exception handling project, just right-click on the exception package and select New Class. Specify the class name as throw exception, and then select the checkbox for the main method. Now, outside the main method, let's declare a static double method divide with 2 double parameters, x and y. So in this method, we will check the value of the variable y. So if the value of the variable y is 0, we'll throw the arithmetic exception by using the throw keyword. We pass the divider cannot be equal to 0 message to the constructor of the arithmetic exception class. If the value of the variable y is not 0, we return the x division y. So let's call this method from the main method. In the main method, we declare a variable d with double type, and we call the divide method with parameters 8.5 and 0, and assign this method to variable d. Okay, so let's run the code. Look at that. Out of the gate, we got an exception that's named arithmetic exception. The divide method is invoked because the remainder is 0. The arithmetic exception is thrown. The message that is passed to the constructor is displayed in the output, and the program is then terminated. Just as we expected, right? So now we have to handle this exception by using a try-catch block. So in the main method, let's enclose the code that may throw that exception with a try-catch block. And we'll copy the arithmetic exception from the console and paste it within the parentheses, following the catch keyword. Also, we'll add the object e. So in the print method, we use the exception object e to display the message and the exception type. Okay, so let's run the code. And the catch block handles the exception and the exception type by displaying the error message, divider cannot be equal to 0. So let's change the parameter 0 with 3.4, and let's print the value of the variable d by using the print method. Okay? Good, let's run the code. The result is 2.5. The catch block is not executed because there is no exception. Throws keyword. So we use the throws keyword in the method declaration. If we know which exceptions can be thrown from this method, we use the throws keyword in the method definition. If you are using a risky piece of code without implementing the try-catch, well, you declare that it throws an exception. So the caller method might handle these exceptions with the try-catch block. But if we call this method from the main class, we can handle these exceptions there. So in our example, we have the void divide method that has no parameters. We throw two exception classes. The first one is number format exception, and the second one is the arithmetic exception. The first, parse int, is the method that throws the number format exception because 8b is not a number format. In the division operation, if the first number is in a number format and the divider is equal to 0, it throws the arithmetic exception. So let's see what that looks like with an example of the throws keyword. So in the exception handling project, right-click on the exception package and select New Class. Specify the class name as throws exception, and then select the checkbox for the main method. Now, outside the main method, let's declare a static void method, divide, that has no parameters. So this method throws the number format exception and the arithmetic exception followed by and separated by a comma. In the divide method, we declare the variable a and assign it parseInt method of the integer class with the value 8b. And we declare the second variable b and assign the parseInt method of the integer class with the value of 0. Now, the parseInt method is used for parsing a string argument into an integer object. And we declare the last variable c and assign it a divided by b. Now we display the value of variable c by using the print method. In the main method, we call the divide method. Now we need to handle these two exceptions that the divide method throws. So let's enclose the code that may throw an exception with a try-catch block. We use the try keyword above the divide method in the main method. And in the first catch block, we handle the number format exception. In this catch block, we'll display the invalid number format message by using the print method. And in the second catch block, we'll handle the arithmetic exception. And in this catch block, we'll display that you cannot divide a number by 0 message by using the print method. Okay, that looks just about right. So let's run the code. So the divide method is invoked first, 8b, and the first parseInt method is not a number format, so this method throws the number format exception. So far, so good. The first catch block handles this exception, and the invalid number format message is displayed on the console. So now let's change the value 8b with 8 in the first parseInt method to test the other exception. And let's run the code again. The divide method is invoked, and because the remainder is 0, the arithmetic exception is thrown. The second catch block handles this exception, and you see it as well as I do, right? You cannot divide number by 0 is our message displayed in the console. So let's compare throw and the throws keywords by using a table to understand it better. The keyword throw is used to explicitly throw an exception. The keyword throws is used to declare an exception. Throw is followed by an instance. Throws is followed by a class. The keyword throw is used within the method, and throws is used with the method's signature. Also, we can declare only one exception at a time with throw. But with throws, we can declare multiple exceptions at one time. Useful methods of throwable class. Java exceptions and all of its subclasses don't really provide any specific methods. The throwable class includes all of the methods. So you see 3 useful methods of the throwable class here in the slide. The first one is the getMessage method, and this method returns the string message of the throwable class. And this message can also be provided while creating the exception through its constructor. So this message is null if the exception object is created with no error message. The second one is the toString method, and this method returns a short description of a throwable. And the third one is the printStackTrace method, and this method prints the stack trace information. So are you ready to make some examples with the useful methods of throwable class? I think you are. So in the exception handling project, just right-click on the exception package and select New Class. Specify the class name as throwable method and select the checkbox for main method. And outside the main method, let's declare a static double method divide with two double parameters, x and y. So in this method, we will check the value of the variable y. And if the value of the variable y is 0, we will throw the arithmetic exception by using the throw keyword with no constructor message. Now, if the value of the variable y is not 0, we return x divided by y. Okay, so let's call this method from the main method. And in the main method, we declare a variable d with double type. And we call the divide method with the parameters 5, 0.6, and 0, and then assign this method to variable d. Now let's enclose the code that may throw the exception with a try-catch block. In the catch block, we will handle arithmetic exception. So in this catch block, we'll display the divider cannot be equal to 0 message by using the print method. Okay, so let's run the code. So the catch block handles the exception, and the divider cannot be equal to 0 message is displayed. Excellent. So let's try to use other useful methods of the throwable class in the catch block. The first one is getMessage. So let's write the getMessage method in the print method for testing. Now this method returns the string message of throwable class. In the divide method, we didn't pass any message to the constructor of the arithmetic exception class. So this method returns null. Null is simply a value that indicates that the object reference is not currently referring to an object. So let's run that code, and there's the result. You see the result is null. Now, in order to solve this problem, we'll need to pass a message to the constructor of the arithmetic exception in the divide method. So we pass the arithmetic exception occurred message. And all right, so let's run the code again. And yeah, there it is. So the arithmetic exception occurred message is right there in the console. Now the second method is the toString method. So let's write the toString method in the print method for testing. And this method returns a short description of the throwable class. So let's run the code. You see the type of exception with its package and its message. And now the last method is the print stack trace. So this method prints the stack trace information and returns nothing. So we cannot use this method within the print method because it is predefined with void. So we will call it directly in the code. All right, so let's run the code again. And there you see the result. This method helps to trace the exception. So by using this method, we can see which method causes the exception in which line number. All right. So on the console screen, if you choose the method that causes the exception, Eclipse automatically selects the line in the code. All right, can you handle it? We are doing our 5th project. Yes. So in this project, we're going to develop a menu-driven application to manage a simple bank account. So this application will help us to deposit and withdraw money, and it'll show us our current balance. Now, also in this project, we will create our own exceptions and use them in the program. So first, let's create a new Java project and specify the project name as Bank Account Balance. Now, again, don't go and change the other options. Just click the Next button. And in this section, uncheck the Create Module Info.java file, and then press the Finish button. So in this project, just right-click on the source folder and select New Class. Specify the package name as Bank Account and the class name as Insufficient Fund Exception. Nobody likes to see that, I know. Insufficient fund exception is a type of user-defined exception. Remember, we were talking about that. So now we're going to use it. We can, of course, create our own exceptions by extending the exception class in Java. So our balance exception class extends the superclass exception. All right, so in this class, we declare a private variable message with the string type. And also we create a constructor for displaying an error message. So let's declare a public constructor that's named Insufficient Fund Exception. And give it the parameter message. And in the constructor method, we'll assign the parameter variable message to the variable message of this class. And now let's create a getter method of the variable message. So for that, we right-click on the file and select Source, Generate Getters and Setters. And we choose the get method variable and then click on the Generate button. And the get message method is generated automatically. Okay, so we completed our exception class. Remember to save the code. All right, so now let's create a new class. So right-click on the bank account package and select New Class. Specify the class name as Bank Account. Now first, we'll declare a variable balance with double type. And we declare a constructor that's named Bank Account. So in this constructor, we initialize the variable balance with 0.0 as our value. And we create a public void method, deposit, with 1 double parameter that's named amount. So in the deposit method, we will assign balance plus amount to the variable balance. And of course, that means that if we deposit the money into the account, we will increase the balance by the added amount. So we create a public void method withdraw with one double parameter that's named amount. And in the withdraw method, if the amount is greater than the balance, then we will throw the insufficient fund exception with insufficient balance. And the withdraw process couldn't be completed will be our message. So in the throw part, we get a compilation error. Now just put your mouse on the insufficient fund exception class, and what does Eclipse do? There it is. So this dialog provides a list of possible corrections. So now we have two ways to handle the insufficient fund exception. We can add throws as a declaration, or we can surround with the try-catch block. If we choose the first option, we have to handle this exception in the main method. And if we choose the second option, we can handle this exception with the try-catch block here, and there's really no need to handle it in the main method. So actually both options are possible. But let's just choose the first option here and go on. So Eclipse automatically inserts the throws declaration in the main method signature. If amount is less than the balance, then we assign the balance minus amount to the variable balance. And that means if we withdraw the money from the account, we will decrease the balance by the subtracted amount. So now let's create a getter method of the variable balance by using a shortcut that you did in the exception class. We'll use the getBalance method for getting the current balance. Remember to save the code. Good. So let's create a main test class that's named test in the same package. So in the main method, we will develop a menu-driven application for choosing a process from the bank account menu. Now first, we create a bank account object that's named account by using the new keyword. And then we need to take inputs from the user by using the scanner class. We choose the import scanner class in java.util package to import the scanner class. Now let's declare a variable choice with no initial value. Now let's start to write the do while loop. Now in loop, in the first print method, we write a title for the program output. So its name is bank account menu. That's right, with all uppercase letters. Now let's copy the print method by using the shortcut and change the code. So in the first option of menu, it's deposit. The second option is withdraw. Third option is show current balance. And the last option is quit. Now in the last print method, we give the select and option message to the user. And we assign the next int method of the scanner class to the variable choice. Now, generally in menu operations, we use the switch case statement. The conditional switch expression is the variable choice. And then this loop is executed until the choice is not equal to 4. So if the user enters 4 from the menu, the loop is terminated. So now we add the while keyword with the choice not equal to 4 condition. And in the first case of switch, we ask the deposit amount from the user by using the print method. And then we call the deposit method from the bank account class by using the object account, and we pass next int method of the scanner class as the parameter. And then we add the break keyword. Now in the second case of switch, before withdrawing money, we'll show the current balance to the user by using the print method. And then we ask the deposit amount from the user the same way. And then we can call the withdraw method from the bank account class by using the object account, and we pass the next int method of the scanner class as the parameter. Hey, did you see that coming? So we got a compilation error. So if you just hover the mouse on the error, Eclipse will show a quick fix dialog. And I'm going to steer you in the right direction. We'll choose the second option to handle with the try-catch block. So we'll change the throwable method with the toString to show the exception type and message. And then we add the break keyword again. In the third case of switch, we'll show the current balance to the user by calling the getBalance method from the bank account class. We add the break keyword again. And in the last print method, we show the message buy to the user. If the user enters 4, then this message is displayed. All right. Yes, that's good. That's good. So everything looks correct to me. So let's run the code. And look at that. You see the bank account menu. It's right there on the console screen. So we'll enter 1 for menu choose. It asks the deposit amount. We enter 500, and the menu returns. So let's enter 2, and we see the current balance is 500, and it asks withdraw amount. So let's enter 400 and go back to the main menu again. Now let's enter 3. We see the current balance is 100. So the withdraw process is successful. Now, because we have enough money in the account, right? So let's turn back the menu again. Now let's enter 2. And we see the current balance is 100. So now let's enter 200 for the withdrawal amount. And wait for it. There's the exception message. So yeah, the insufficient fund exception is thrown and the insufficient balance withdrawal process couldn't be completed message is displayed, but it is as expected. Don't feel too badly. So there it is. We've completed our project successfully. Congratulations and very well done. But you see how useful this is. So I would advise you then to add some new control methods in the bank account class and test the controls using that bank account menu. Installing Emulator. Hello everyone. Now before we start development with Android Studio, we're going to need to install one more program. This program is called Emulator. Okay, so when we develop an Android application, we're going to need to test it on an Android device. But there are various models of Android mobile devices in the market. So each model has various specifications, as you might have guessed, through all the API levels, right? So you're going to need to test your application on different models of Android devices. For example, you're going to need to test your application on a mobile device that has a big screen, and also a device that has a small screen. Also, you're going to need to see how the application works on whatever tablet. So that's why you're going to need various mobile devices, or Android Studio gives us a convenient tool here. You can create a virtual Android mobile device to test your applications. Cool, huh? So one of the most important features that should be considered when developing Android applications is testing of those applications, and I will show you how to install a virtual mobile device. So here we are opening Android Studio now. So when we design an application on Android Studio, we need to click the Run button to test the application. And when we click the Run button, a window will open. Now, if you do this for the first time, you will not see any virtual devices, but I've already installed some virtual devices before, and you can see these devices here on my computer. For example, I've already downloaded a virtual device with the name Nexus 7, and this device has Android version API 28. So now we're going to click Create New Virtual Device, and then after clicking, a new window will open. And you'll see different types of Android mobile devices in this window. Didn't know there were so many, huh? You're going to see phone models, tablet models, Android TV models. So on whatever device you want to test your application, you can create that device right in here. So we're going to create a virtual mobile phone in here. And when I click on the phone section, I'm going to see different phone models that, well, every model has a different type of screen size and resolution, right? So it's another good reason to have this here, because I certainly wouldn't be able to keep all these things in my head. Let's see. So I'm going to choose Pixel Model Phone, and you'll see here that this model screen size is 5.0 inch, and the resolution is 1080 by 1920. Also, you can see all the information on the schema on the right-hand side here. So when I've decided which device I'm going to create for, then I click Next. So now we should choose the Android operating system version type. So of course, every version type has an API level. So if I choose Oreo, its API level is 27. If I choose Android Pie version, its API level is 28. So whichever version you choose, your virtual device will have this operating system version and API level. So when I choose Android Pie, it will start to download. Okay, so it's about 864 megabytes. So I'm going to click Cancel because, well, I am one step ahead of you, right? So I've already downloaded an Android Oreo version. and I'm going to use this version. So after I choose the Oreo version, I'll click Next. Okay, so now the time has come to give a name to the virtual device. So Android Studio gives a name automatically, Pixel API 27, but if you want, you can amend or change that to a name, I don't know, that's a little more creative, whatever you want. And now we will choose the phone startup orientation right here. So this is the default position that you're going to choose. So also you can change this position later, but for now I'm just going to choose portrait and click Next. So after I click Next, Android Studio will start to create the virtual device. And now you can see this new virtual device on the list. So I'm just going to click OK, and my virtual device will start to open. Now, this part may take a little while the first time, and no, you'll see after the first time it's going to open a lot faster. Okay, so now all the features that you need on a real Android phone can be found right here on this virtual phone. You can test all of the features of your application right here on this device. I'll give you a little tour. For example, the location, battery, camera, phone calls, microphone, fingerprints, sensors, and, everything else. Also, you can create virtual devices as many times as you want. So finally, we will create a virtual device and we can continue to Android Studio. Perfect. See you next time. General information about Android Studio. Hello, everyone. We're going to now get to know Android Studio right now in this section. So we've already opened our first project in the last video. And in Android Studio, you will see a design page. This page looks like a phone screen. So in other words, whatever we design in here, our application will look exactly the same on Android phones. So everything we design on this page will be saved as an XML file. So we can see XML codes by clicking the text button here at the bottom. You can also see XML codes in here. Now everything on the front is actually generated using XML codes in the background. So what I'll do is I'll click the design button again and we can see the design page. Now everything we need in Android application, for example, buttons, text, images, etc. So we're going to put this on the design page. But now how are we going to do that? All right, we're going to do this in the form of, wait for it, drag and drop. Yeah, it's that easy. We will choose whatever we want to put on the left side, and we're just going to drag it and drop it right here on the page. And then after we put the components on the page, Android Studio will produce XML code in the background. How's that for nothing? Also, we can do the same thing writing XML codes ourselves in the background. It's up to you. But drag and drop is pretty easy. In fact, it's the easiest way to design an application, and they've made it so easy. Why do anything else? Because you want to be an expert developer and make perfect applications, right? Let's keep going. For example, here I'm going to drag a button on the page, and you can see when I drop it, XML codes for this button will be generated in the background. And, of course, if I delete this button on the front page, the XML code will be deleted by Android Studio. So, that's the design page. Now, also there's an other page that is, what did we talk about before? The Java code page. So we're going to write Java programming language codes on this page. So after you design the front page that users are going to see, you're going to need to write Java codes on the Java page. So this page is the main activity.java file, and you can see Java codes on this page. So right now, I'll tell you straight up, that Android Studio separates the design part and the Java programming part. Now, it's kind of convenient, right, when we develop Android applications. So why do you suppose that they would do this, provide you with this kind of convenience? Well, that's because if you're a team or you're working for a team, two people can work on a project together. For example, a designer can design the first part, the front end, and a coder can then go in and write all the Java code. So these two sections are separated in most large projects. But if you want to be a good Android developer, you're going to need to learn both parts. And that will make you a well-rounded Android developer. And that's not just somebody that sits behind their desk eating donuts while they code. You get me? These two parts are also very important because if your application does not have a good design, people are just going to go look at something else. Ooh, I like the look of this. All right, so your application needs to have good UX, UI design. UX means user experience. UI means user interface. Now, I'm going to explain these topics in the next videos, but even if you have a good design, you also need to write Java code smoothly because if your codes are not well written, your application will not work properly. And that's just going to crash and burn everywhere, every time. Who needs it? So after I explain these topics, we can continue on working in Android Studio. You can see the menu on the top. There's the Run button here, and on the left side, you can see the manifest folder. So this folder is important. I'm going to explain it in another video. I just want you to be able to find it. Also, you can see the Java folder on the left side, and inside that Java folder, here is the main activity.java file. So our design page is under the res folder and layout folder. It's the file here. You'll see activity main.xml. And also you're going to see Android components on the left side between the folders and the design page. So they're buttons, text views, radio buttons, image views, etc. Don't worry, I'm going to explain these components with all of the details that are fit to print and talk about, and you're going to know everything about. Okay, so this video was basically just to show you around Android Studio. So now you know about it. We're going to speak about the Gradle file in the next video. I can't wait to see you then. So until then, have a nice day. General information about the Gradle build system. Hello everyone, I want to give you some information about the Gradle build system in this particular video, and before we start, I want to show you some Gradle files in Android Studio. So let's move on to Android Studio. I should add some reverb in there. Okay, so you can see the Gradle files on the left side here. And there are two important Gradle files for us, and that's level here. So these are build.gradle project. It's my first application file, and build.gradle module app file. Now, before we, really get in depth about these files, I do want to say something about Gradle. You're going, Gradle? Gradle is a build system that automates the build of Android application development. Gradle makes testing and building, debugging, releasing much easier. Gradle also makes adding new libraries into our project in Android Studio a whole lot easier as well. So here's the first page. It's my first application page. It's the version of Gradle system. My Gradle version is 3.3.2. Now, the most important page for us now is what build Gradle module app page. So this page is application, it's features, and you can see some of the values in here. I want to explain these values and what they mean. So the first one is compile SDK version. So this value determines which API level features we can use. For example, if this value is 25, we won't be able to use API 28, right? So if this API level is higher, then our application will also have more advanced features of higher API levels. Now, the second one is the application ID. This is a unique value. So for this application, it is com.example.myfirstapplication. Now, when we upload this application on Google Play, it will be known with this particular ID by Google Play. And the third one here is min SDK version. So this value determines which API level and above can work in our application. So it's a lower value, so it's a minimum value for this application. It is 22, and that means that this application will not work below API level 21, right? Now the other one is the target SDK version. This value indicates that my application will work well at this API level in particular. Now, we should give the minimum SDK value as small as possible, and the compile SDK as big as possible, right? And also the compile and target SDK should be the same value. That's what I recommend, and I'm sticking to it. Now, another value is the version code. And you're going to use this code when you publish your application on Google Play. It has to be an integer value, like 1, 2, 3, and it continues on and on. Now, after you publish your application on Google Play, if you change something in your app and you want to upload your new version, you must increase this value. Otherwise, Google Play will not accept your new version of your application. And wouldn't that be a shame? So the version name is when people want to update the app on their phone and they see this value. This is unimportant for Google Play, but people will see this value. It can be 1.0, 1.1, and continues on and on. And when you update your app, you should give the new version name for the people who will download your app. And then when you change some value in Gradle, you will now see a sync button. And after you click this button, it will change everything or synchronize everything to the new values. And then lastly, should tell you about dependencies. So this is the part in Gradle that is reserved for libraries. And if you want to add a new library to your project, you will begin here. Android Studio and Gradle make it very easy to add new libraries, as I told you before. Now, before Android Studio wasn't like this. It wasn't so easy. But now you just add library code dependencies in this section and then click the Sync Now button. I won't even tell you about the history, but just remember that everything in your library will be added to your project automatically. All right? So I think this is about enough with Gradle, because this is not a Gradle course. I want to thank you very much for listening, and I'll see you in the next video. Or you'll see me. No, you'll see we're going to do a lot in our next video, so let's just get to it. So here's an introduction to the manifest file. Hello, everyone. I want to speak to you today about Android manifest file. Now, the Android manifest file is an XML file. It is one of the most important parts of Android application projects. The basic information of our application can be accessed from this file. And we also get the basic permissions for the application in this file. So we can continue on to Android Studio, and here I'll open Android Studio, and you can find the manifest file under the app folder on the left-hand side of Android Studio. Now, when I open the manifest file, you can see that its extension is .xml. Now, if you look at this file carefully, you'll see the package name. It is com.example.com, my first application. And we spoke about the package name before, right? Also, there's a line in the manifest file that is an Android icon. Now, it's second line under the application line, and we'll determine the icon of our Android application on the phone in this line. So we'll choose a picture for our Android application, and then after that, we'll put this picture in the map folder, and then we'll write the picture name on this line. Now, if we do not choose a picture for our application, Android Studio chooses a default icon, and that is the Android robot icon. Now, the other important line is the Android label line. And you see that the label is my first application for this project. And this line is for how our Android application name will be seen on the phone itself. So if we change this label, then our application name will also change on the phone. Also, all of our activity files are defined in the manifest file. So we have just one activity for this project right now. As you can see, it is defined in the manifest file in the activity line as a .main activity. And it's defined as a launcher activity in the category line. Now, if we create new activities and want one of these activities to be a launcher activity, then we should determine it to be a launcher activity in the manifest file. So launcher activity will, of course, launch first, and then we'll open the application on the phone. There's another important thing that I want to tell you about this Android manifest file. It's about user permissions. So when you develop an Android application, it will use some of the device features, such as camera and Wi-Fi, phone numbers, microphone, location, all that kind of stuff, right? So you cannot reach these features without getting the user permission. So that means, being a good developer, you have to first ask permission of the user. And then you just write it into the manifest file. And you can see it here, which permission you get from the user, such as access Wi-Fi. And this permission gives you access to the device Wi-Fi connection. Now, if you take network state permission, your application can use the device mobile internet. For example, if your application makes a phone call, you have to get the phone call's permission. You can take all of these permissions from the manifest file, but when you take these permissions from the manifest file, the user will see these permissions before downloading the app on Google Play. Now, the other topic is screen orientation for this level. And when the user opens your app on the mobile device, your application will appear vertical or horizontal. Now, you can specify this in the manifest file. If you choose the screen orientation portrait, your application will appear vertical. And if you choose landscape, it will appear horizontal. And also, you can change your application activity theme in the manifest file. So by that, I mean right here, by theme is the top section of the activity. So you can see this is my first application part, and it's replaceable. And you can change the text color, the background color. You can add icons, a whole lot of things. Everything I mentioned that you can specify in this theme. And you can create a new theme, and then after that, you can change it on the manifest file. So we're going to do some examples about all of these topics and more in the coming videos. I just wanted to give you a quick rundown of all the information. It's enough for this level. So until then, see you in the next video. Introduction to resources. Hello, everyone. I want to tell you about some of the resources in Android Studio in this particular video. So let's get to Android Studio without losing any more time. Now, you know that we've opened a project on Android Studio, and we were going to give some information about our project file within Android Studio. So you can see the resources folder, which is here on the left side of Android Studio. And as it's called, it's a res folder. Now, there are 4 folders within the resources or res folder. These are the drawable folder. You say that 3 times fast. The layout folder, the mipmap folder, and the values folder. Now, first of all, we're going to speak about the drawable folder. Now, this particular folder holds, of course, pictures for our project. And I'll just right-click on the drawable folder and click Show in the Explorer. And I can see this folder in the Explorer. Now, there's an XML file inside it. And I'll put some pictures, icons, and logos in this folder for using within my Android Studio project. And when I need these pictures, I can call it up, giving this folder path. Right? And then I'll just copy a picture from another folder, paste it in the drawable folder. And after I close this folder, and you can see now that this picture is under the drawable folder in Android Studio. And if I click it, it will open. And then I can use this picture in my project, such as a background image. Now, another folder is the layout folder, and the layout folder holds XML activities files for our Android application. Now, you know that we have one activity now for this project, and its name is main activity. But there is a second part of this activity. So one is the XML file, the other is the Java file. All right, so the layout folder holds the XML file of the main activity. The main activity Java file is in order under the app Java com.example.myFirstApplication folder. So if we had other activities, their XML files would have been under the layout folder, and then we could work on each activity individually, whichever one we want. Now, another folder is the mipmap folder. The mipmap folder holds pictures and icons like the drawable folder. So I know what you're thinking. If the mipmap folder holds pictures like a drawable folder, then why do we have 2 different folders for the pictures? But the mipmap folder is not the same as the drawable folder. So I'll open up the mipmap folder on Explorer, and then you can see here that there are 6 different mipmap folders. They are mipmap HDPI, MHDPI, XHDPI, XXHDPI, and, well, etc. You can read them yourself. So why are there 6 different mipmap folders? So if you look at it carefully, you will see that there is the same picture in each of the mipmap folders. Now, if you recall, we spoke about Android applications. And before you can develop Android applications, you have to determine screen sizes, because you can develop Android applications for different screen sizes. In fact, you can develop Android applications for small screens, big screens, tablets, or Android televisions. So when you are developing these applications, if you use the same pictures for every screen resolution, of course, the pictures won't appear very well in your application. And we don't want that. It's going to look bad. So to solve the problem, Android Studio uses a mipmap folder. And then what you'll do is you will use copies of the same image in different resolutions, and they'll all be stored here. So whichever size of the device that you're going to be running your application, it will use the required photo from the Android Studio mipmap folder. For example, if your application runs on a small screen device, your application will use pictures in the MHDPI folder. Or if your application runs on a big screen device, it will use pictures in the XHDPI. Now, your application will make this decision automatically, but you also need to write some code for this operation to be successful. It doesn't work just by putting the pictures in the folder. I wish. Well, okay, maybe you wish. So we're going to see some examples about how to do this in the next couple of videos. This video is just giving you the general overview about Android Studio and what you can do in Android Studio. So we'll move on to the last folder, which is the values folder. And now you can see that there are 3 XML files in this folder. And their names are colors.xml, strings.xml, and styles.xml. Now I'll click and open the colors.xml first. Now you can define colors for your project right here in this XML file. And as you can see, there are 3 colors in here, and every color has a code. So this code is XML code. And you can define colors, of course, using XML codes. And you can find every color XML code on the internet. So I don't have to go over that here. I don't know how familiar you are with XML code. So you can choose a color and put its code in this file. And then after that, you'll need to give a name to your color. So in here is your color primary, and color primary dark, and color accent. And then when I need this color, I'll call it by its name. For example, let's say that I want to change my main activity background color. I'll go to the main activity, XML, and I'll choose background in the attribute section right over here on the right side of Android Studio. Now after that, a window opens and I can see the names in the color section in this window. Also, there are other basic colors in here, but there are millions of color codes and you can't find every color in Android Studio. Now, because of this, you may want to use a new color. So you can define that color in the colors XML file. So then after that, you can give this color a name, and then you can use this name whenever you need to. And you don't need to remember the color code. You just write in here its code and then use it everywhere you'll need. I will add a new color here as an example. So I'm going to copy the last line and I'll paste under it. And after that, I'll change the name of the color to black. Also change the color code 60 for black. Okay, so now that it's added, I'll go back to the main activity and try to change the background again. And I will see this new color on the list as a color called black. Okay, so now another XML file is the string XML file. And you can give a name to every string word or sentence. So when you need this string or sentence, you can call it with its name. Also, you can add arrays here. And after that, you can call it from the Java file. Also, we're going to use this file to design our application for multilingual. For now, I'm not going to explain it in this video, but here you can see that there are a whole lot of things you're going to learn. Now, the last XML file is the styles XML file. This file is for themes. And there is a theme in here, and its name is app theme, appropriately enough. Now, if you want, you can create new themes. And for this theme, there are 3 different colors in here. So the theme is for the app bar on the application. The app bar is also known as the action bar. So here in the color primary, dark defines the color of the top section of the app. And here you can see there is a clock in this section, and the color primary defines the color of the application where we write the name of the application section. So you can see that there is the app name. And when you change these colors from the styles XML file, all of the application activities app bar colors will change automatically throughout. Also, you can create a new theme in here, and whichever activity you want to use, you just change the theme from the manifest file, and it will change. So I think that's enough for this particular video. I don't want to blow your mind, not all at once anyway. So I'll see you in the next video. r.java file. Hello everyone, I will speak to you today about the r.java file. So this is going to be a heck of a video. It's going to be general information about the r.java file, but you really need to know about it. So please pay attention to every single detail. Okay, so the r.java file is an auto-generated file by Android Studio. Now, you know that there are 2 parts of an Android application project. First one is the XML file. The second one is the Java file. I love it when you say it along with me. So, we do all of the design in the XML file. All the designs we made in the XML file are translated into Java code by Android Studio. And then Android Studio gives an ID to every component you designed in the XML file. So these IDs are kept in the r.java file. These IDs can be used in the Java side to perform any action on the XML files. So now if we go to Android Studio, you can see here all the project files, XML design side and the main activity Java side. Now first, I want to show you where that r.java file is. I'll choose the project option on the left side of Android Studio. And the R file is respectively under the My First Application folder, App folder, R folder, Com folder, Example folder, My First Application folder. So my Android Studio version is 3.3.2. Now, it could be different places in different Android Studio versions, but you do not have to know where the R file is. You will not do anything in this particular file. You just need to understand the concept of the R file, right? So when I open the R file, you will see it is generated automatically. So even if you delete this file, Android Studio will still generate it. It'll just regenerate. It'll respawn. Now you see that right here, it should not be modified by hand. For example, this is our main activity, and its name is activity_main.xml. We define this XML file in the Java side as a r.layout.activity_main. Activity_main is its ID. You can see this ID in the R file. And this procedure is for every XML file under the res folder. So if I go back to the Android project file, you're going to see everything under the res folder, such as the drawable folder, map folder, layout folder, and values folder. Okay, so now, for example, we have a text view in here, and its text is Hello World. And now I will give it an ID for this particular text view. Its ID is denim, and you can give any ID you want. But now you see this text view is an XML file, and you can see its XML codes in the text section. And now I will call this text view on the Java side. First, I will define this text view here. I will give a name to this text view. The name is the text that I gave, but you can give it any name you want. And after that, I will call this text inside the onCreate method, and I will call it from the R file. So I'll write here r.id.denim, and it is now identified. So I can do any operation on this text view using the text name. I can change its background color or its text size using Java code. We call the activity layout using the same method. For example, if I write here r.layout, it will call XML files under the layout folder. Also, if I write r.string, it will call strings inside the string XML file. So what do you think? I think this is enough for the R file in this particular video. See you in the next one. Layouts. Hello, everyone. So we're going to speak about layouts in this video. So we can start to design levels in Android Studio. But we should learn layouts in order to design Android applications. So just what exactly is a layout? A layout is an interface that we use to place Android components on the Android application. So we're going to use layouts to establish components in a particular order. These components are buttons and text views, radio buttons, and anything you can pretty much think of. There are varieties of layouts, and these are linear layout, relative layout, table layout, and constraint layout. So these are the main types of layouts, and we'll speak about the first three layouts in this video. I'm going to reserve the constraint layout to another video. But most of the projects, we're going to use the linear layout and the relative layout. But if you have a table design in your project, you can use the table layout. Now, because I want to stay on topic, we're going to speak about Android Studio. So let's go to Android Studio, and you'll see what I mean. Okay, so you may recall that we have a project, and its name is My First Application. So when we open a new project in Android Studio, it creates a main activity XML file. So we will design right here on this page. And this page's default layout is constraint layout. Now, we will not use the constraint layout. We will start by using the linear layout. Now, if you look at the component section, you will see the layout types under the layout section. So first, I'm going to delete the constraint layout. I know, just delete it. And instead of the constraint layout, I will write linear layout. And I will do this using XML code. So I'll open the text side, delete the constraint layout, After that, I will write in linear layout. Okay, so now our layout is linear layout. But also, we're going to need to specify its orientation. Now, there are two types of linear layouts. One is horizontal. The other is vertical. You can specify it by writing this code. Now, I'll first choose the vertical orientation. So in this layout, components are placed from up to down. If you choose horizontal orientation, the components will be placed from left to right, just so you know. So for example, I'm going to put text view here, and you can see it started from up here. And then after that, I'm going to add a button, and you see it's placed under the button. And if I add another button, guess what? It'll be placed under that first button. So now I'm going to change the orientation of my linear layout, make it horizontal. And now if you look at the design page, you'll see everything is placed from left to right. So I'm going to change the layout width. I'll change it to wrap content. And then you can see that the buttons and text views are sorted from left to right. Now if I add one more button, it will take its place after the second button. You know what? I should mention to you about the layout width and the layout height here. They are match parent and wrap content in here. So when you choose match parent, the layout will cover the entire screen. But if you choose wrap content, the layout will be big enough to enclose its content. Right? Makes sense? Also, you can give a numerical value in here. So by that, I mean you don't have to choose just match parent or wrap content. For example, let's give a layout width of 400 dp and layout height of 500 dp. Now also, you can add more than one layout. So now I'm going to choose layout width and height match parent. And I'm going to add another layout, but this time its orientation will be horizontal. Now I added this under the vertical linear layout, and I will add two text views under this horizontal layout. And I will choose layout width, wrap content for horizontal layout. And now you can see these two text views are side by side. So in the same way, I will choose layout height, wrap content for horizontal layout. And now you can see the button too. So now these two text views depend on the horizontal layout, and buttons depend on the vertical layout. So actually, buttons and horizontal layout are elements of a vertical layout. Also, horizontal layout has two more elements that are text views. So now let me just add one more button here, and it will take its place under the other button. Now also, I can add one more layout. Now this layout is also going to be a horizontal layout. So this layout is an element of the vertical layout. I will connect these two buttons to this new layout, and I will do this with, over here on the XML code side, and I will cut these two buttons XML codes and paste inside the layout. But also I should choose layout with wrap content for this layout. Great, so now we have one main layout and its orientation is vertical. And also we have two child layouts and their orientation is horizontal. And then every horizontal layout has two child layers, and these are buttons and text views. Now, after the linear layout, we can continue with the relative layout. And I'm just going to delete these components, and I will change linear layout to relative layout. So, how does the relative layout work? Probably the best way is to show you. So components are placed right in each other's position within the relative layout. I'm just going to add two buttons to show you how relative layout works. You can see that these two buttons took place on top of each other because we haven't given them any position. So now I'm going to change the first button text to be a capital letter A, and its ID will be a lowercase a. And for the second button, I will change its text to be capital letter B, and its ID will be lowercase b. So now let's go to the XML side, and I will first find the button and add a new line of XML code. And this code is layout center horizontal true. Now button A takes a place center of this row. And I'm going to add another line of code. So this time, center vertical is true. Now button A took place center of the screen. And now I will give a place to button B according to button A, or relative to button A. Yeah, see where we're going? And I'm just going to add a new line of code in the XML code of button B. And this code is layout below IDA. Now button B will take its place under button A. Now, if I want button B to be in alignment with button A, I should just add a new line of code. Layout center, horizontal, true. And now button B is under button A. Now, if I want to put button B above button A, I should just write the layout above IDA. And now button B is above button A. So you see in the relative layout of the components, they all take their places according to each other's position. Okay, so now we can have a look at the table layout. In the table layout, components take their places by means of a table position. So in the table layout, there are rows and columns. And now I'm just going to delete the relative layout and write table layout. Now also, we need to add some rows in this table layout. So I'll add 3 rows. And then after that, I can add 3 buttons for each row. So now we have 9 buttons on the table layout in a table position. So where can I use a table layout? Let's say, for example, I want to design a calculator. We can use the table layout. So I'm going to change these button texts to 1, 2, 3. You see where we're going. And of course, you can use more than one layout in your design. So I think that wraps this video. We'll continue in the next one. See you then. Text views. Hello everyone, it's time to talk about text views in this video. So we spoke about components in Android Studio in the last video. We mentioned some layouts, and right now we're going to talk about which Android components to place on these layouts. One of them is text view. So what exactly is text view and what can you do with it? So text view is a component to show text to the users. I know it seems elementary, but stay with me. You can use text views as labels or to print some results on the screen or to print some notifications on the screen and that kind of thing. Text views can be used in a lot of different areas. So it's pretty much the most commonly used component. So we'll go back to Android Studio and have a look at how text views work in practice. Now we can add text views 2 different ways to Android applications. And of course, the first one is to drag and drop it into the Android Studio like this. All I'll do is drag text view, drop it under the relative layout. And now we have text view and its text is also text view. So we can change this text whenever we want to. This was the first way. Also, of course, there is another way, always another way. And I'm just going to delete this text view and create a new one using XML code. And I'll go into the XML side by clicking the text bottom of the page. And now I'm going to write text view XML code inside the relative layout. And I'm writing here text view, and Android Studio will autocomplete it. Now I just need to give some values for the layout width and height. And I'll just write wrap content for both of them. Now this will define height and width of the text view. Now we have a text view here, but we don't see it because we did not write some text. So I'm going to add a new line of text inside the text view using XML code. I'll write inside text view hello world And to do this, I will just need to write Android:text, and inside the quotation marks, I will write text. So whatever I write inside the quotation marks, the text of the text view will be what I write. So now the text of text view is Hello World. So I choose wrap content for height and width of text view. And then setting a text view size to wrap content will force it to expand only far enough to contain the values it contains. Right? So if I add new words to the text, the size of the text view will be bigger. And if I change it to a bigger number size inside the text view, the height of the text view will also be bigger. When I change text size to 20 dpi, and the text view size gets smaller, of course. So when I change text size to 40 dpi, text view's size gets bigger, way bigger. Now, on the other hand, I can choose the width of text view as a match parent. So when I write match parent here, text view will cover all of the device screen from left to right. And then also when I write match parent for layout height, the text view will cover all of the device screen from top to bottom. So now I'll choose wrap content for layout height. Now, of course, also I can give numerical values for height and width. So let's give 150 dpi for width and 75 dpi for height. And also I'm going to drag text view to the center of the screen. So when I click text view, I can see the attribute section on the right side of Android Studio. And I can also see all of the operations I can do right here, everything that I can do to text view. For example, I can change the layout margin here. And then when I change the layout margin, text view position will change on the screen. Now, if I write 250 dpi here, text view's position will go down. If I write 150, it'll go up. And I can give numbers from here for left, right, top, and bottom. Layout margin defines the position of the text view. Also, there's another attribute here. It's called padding. If you're not familiar with padding, padding defines the text position inside text view. So if I write 25 in the left box, see how the text will go 25 dpi from left to right. So if I write 10 in the top box, the text will go 10 dpi from top to bottom. Also, I can change the text size in the attribute section. So if I choose 24 dpi, the text will be bigger. When I choose 14 dpi, the text will be smaller. Now, all the changes that we made in the attribute section will be added in the background as XML code. Now, if you want, you can write XML code to do the same operations, or you can use the attribute section. So let's see what else we can do in the attribute section. We can change the background color from here. I will choose color accent as a background color. And now the background of text view is changed like so. Also, there is clickable stuff here. It means that when you click on the text view, some operation can be done. You can change true or false here. There's gravity here. You can define text position automatically inside the text view from here. So I'll choose center, and text will take the center position vertically and horizontally. But if I choose this, I'll need to change gravity to 0. See? And now we can change text color from here as well. So for example, let's say that I want to choose white, and the text color will be white. We can do a lot of operations from here. But also we can do these operations on the Java side. You don't think I was going to leave that out, do you? But before we work using Java code, we will need to give an ID to this text view. You remember when we talked about it before? So on the Java side, this text view needs to be given an ID in order to be recognized. So I'm going to give it text example as an ID. And now our ID of text view is text example. And text of text view is hello world to the human. So let's go to the Java side. And now I can just delete these codes that I wrote before. First up, I need to call TextView as my class and give a name to this text view. And I'm going to use this name on the Java side. You can give it a name, whatever you want. I gave the name text. You know, I'm creative that way. Now, after that, I do need to call this text in the create method. So I will write text equals, and then inside parentheses, text view again. Now this is typecasting in Java. And I will write find view by ID. And I will call text view from the XML side using its ID. And I'll write inside the parentheses r.id.text example. So see, now we have assigned text view to the text we created on the Java side. Now I can do all of the operations that I've done on the XML side here, but how will I do this? I'll just write text here, and I will add point here. Then after the point, I can see all of the operations automatically. And I can set a new text from here. So there are plenty of operations here that I can choose from. For example, I can choose set text color. So I'll choose a color, writing color.black. And then when I write this code, nothing has changed on the XML side. The changes will be applied when I run this application on the device. So I'll click Run, and I choose a virtual device and click OK. And then, after the device opens, I can see the changes in the application. So it'll take some time to get to the device online. There we go. Now you can see that the text color is black. Cool. Okay, so also I can change the text using set text code. I'll write text.setText, and inside the parentheses, I will write new text. I want to change, and I will write this as an example. But you should be careful now. You need to write text inside the quotation marks. Right? And I'll just run it again. There you go. Now you see that the text has changed. So in addition, we can add a feature to text view. And if we click to text view, we can start the operation. So for example, when we click onto the text view, we can open a new activity, or we can change the text size or text color. So let's try it like this. How are we going to do this? I will add a click listener to this text view. You see it? I will write text.setOnClickListener, and then inside the parentheses, new view on click listener. And I will write new codes inside the onClick method. Now, of course, these codes will work only when I click to the text view, right? I will write inside the onClick method text.setBackgroundColor color.white. Click Run again. And after a while, the device is running. And now you can see here that there's not any changes in the text view. How come? After I click on the text view, the code will work and the text color will be white. So let's change the background color of the text view. I will write text.setBackgroundColor color.black. And I'll click Run again. Now you can see that after I click Text View, the text color will be white and the background of the text view will be black. So we can do a ton of other operations here. But for now, that's enough for one video. Believe me. There are other components that we need to learn. So make haste. I'll see you in the next video. Buttons. Hello, everyone. I want to speak about buttons in this video. No, not the ones on your jumper, your sweater, anywhere else, your shirt. Buttons on Android components. So when you click on buttons, buttons will do specific operations. Buttons are one of the most useful components, and I'm thrilled to be able to tell you about them. So if I want to count 3 of the most used components, I'll definitely say buttons, text views, and edit texts. So in the last video, we spoke about text view. This video is about buttons, and we're going to speak about edit text in the next video. I know, I'm transparent, aren't I? So let's go ahead into the Android Studio without losing any more time. So we have an open project from the last video, and we have a text view in this project. So now we're going to add a new button to the project. And as you perhaps remember before, we can add a new button in 2 ways. First one is drag and drop. Boom, I added a new button. And of course, I can drag it wherever I want and change my mind. And that's because I use relative layout. It just snaps like that. Now, the second way to add a new button is by using XML code. So why don't we add a second button using XML code? Now, just go over to the XML side, and you can see here XML code that I've added a button before. I'm going to write button here, and Android Studio will autocomplete it. Okay, so now I need to define height and width. And I'll choose match parent for two of them. And you can see here we have a second button, but it covered the whole screen. So I'm going to change height to wrap content. Okay, so now the button covered the screen just from left to right. Now we need to give some text to this button. And I'm going to write here Android text, and inside the quotation marks button 2. And now you can see the button and button 2. So why don't we change the width of button 2 to be wrap content? And now we have two buttons. The first one is created by drag and drop. The second one is by using XML code. Now we can do a lot of operations with these buttons, right? We can do these operations in the attributes section. So we can define height and width here. We can specify layout margin from here. Also, we can define padding here. You remember that I mentioned that before, right? Padding defines the text position inside the button. So let's just go over it again. If I write left 20, text will go 20 dpi to the left. Also, when I write 20 dpi, text will go 20 dpi down. Now I can change the button text from here too. So I'll just write in here quickly, do your magic, and you can see the button got bigger because the button width is wrap content. Okay, so when the text gets longer, the button will get bigger in order to cover the text. And I can change the background color of the button from here as well. And I'll choose a color from here, and the button color will change. Now also I can choose the button to be clickable or not. Now you can probably think of why I put a button in the project, and I didn't do it to be clickable. So if I do not click the button, why did I put a button there? Well, this is important because you can do regulation on your project, and you can do your buttons to be clickable after some other operation. So in other words, before these operations happen, the button will not be clickable. You get me? For example, if you design a game, and inside the game there is a next section button, but you don't want the player to pass on to the next section before they, I don't know, make a, specific score. Well, you can specify that after the player collects a score, the next section button will be clickable. So then the player can pass to the next level after they make the required score. Also, we can change the text color from here. We can change the text size from here. Also, another important thing, we can do our button to be visible or invisible. Now you get it. So if I choose invisible, the button will not be seen. So this feature, of course, can be used for the same purpose and that I mentioned about being clickable or not clickable. Inclickable, I almost said. Inclickable. All right, so now we need to give this button an ID to be able to work on the Java side. So Android Studio gave this button an ID. It is button. All right, so if you want, you can change it. But you know what? I'm going to change it, and I will give it the ID do magic. Great. So now the ID of this button is do magic, and the text of the button is do your magic. So are you ready? Let's go over to the Java side. So there are some codes here before we wrote. So I'm going to delete some of it. And now I need to define that button in here. So I expanded import part above. And you can see here when I define text view, Android Studio imported android.widget.textView. Now you must import it in order to work with TextView. And in the same way, when I write here button and I do not choose autocomplete, the word button will be read because we did not import the button class inside the project. So that means I'll just need to import the button class. How am I going to do that? See here, when I write button, and then after that I press Control and space at the same time on the keyboard. After that, Android Studio will show me what I can import. And then I'll just double-click Android.widget as my option. And you see here, Android Studio imported Android.widget.button. And the button word is not read anymore. So now I need to give a name to this button in order to work here on this button. Let's see, I'll give the name button, but you can give whatever name you want, of course. Also, I'm going to need to define this button inside the onCreate method. So I'll write button equals find view by ID. Now, before I continue, I need to explain something. Not that. When I defined text view, I wrote text view again inside the parentheses for typecasting. You remember? So in the old version of Android Studio, you needed to do typecasting. But in the new version of Android Studio, you do not need to do typecasting. Right? So after you get that explanation, I can continue. So after I write find view by ID, I will write inside the parenthesis r.id.doMagic. Because the ID of my button was doMagic. So now I've defined the button on the Java side. I can do everything in here. So I will write button after dot, and you can see the operations that I can do. Now I will add a click listener and then work inside this method. I will write set on-click listener, and inside the parentheses, new view on-click listener. And then after that, I write inside the on-click method will be executed when I click the button. And I will write inside the on-click method button.set background color, and inside the parenthesis color.black. So this code will then change the background color of the button after I click that button. I mean, that's a predicted result. We'll run it and we'll see. Whew, boy, it is working. You can see that, right? Cool. So we can do operations on other components from here as well. For example, we can change the text of the text view from here. So let me write text.setText and inside the quotation marks, I have done my magic. Okay, so let's run it. And you see when I click on the button, text of the text view has changed. Now also I can do invisible for this text view. So I'm going to write text.setVisibility view.invisible. Let's run the app. And you can see, or you can not see, that it is working. So when I click the button, text view gets invisible. So in other words, you see that it is working because you don't see. Well, okay, well, never mind. You see that invisible is visible. No. Okay. Now I will do the invisible button itself. For my next magic trick, so you see here that there is another button, but when I click it, it doesn't work. Why? Because we haven't written codes for this button. Now, of course, we can do many more things here, but I just want to point out another topic about buttons. I know, I'm button crazed. I'm obsessed. The design of buttons is as important as its codes. So because of this, you need to learn different types of button designs. Do I need to say it again? Button types or button designs are as important as its codes. For example, you would want to shape a button to be oval or circular or rectangular. And then when we want to change the button design, we'll need to create a new XML file. So I will right-click the drawable folder, and then after that I will choose New, Drawable Resources File, and it will open in a new window. Now I need to give a name to this new XML file, And I will give the name button shape to this file. Click OK. And now we have a new XML file, and its name is button shape. Stay with me. There are some codes here, and these are the codes that when we click each button, how its design will be created. So I will delete these codes because I will not work with this right now. I just want to change the shape. So I'm going to define the shape, writing Android shape oval. Now also I need to choose a color for this button. So there are two types of colors, basically solid and stroke. I will define a solid color, and I will choose the color accent, but you can choose whichever color you want. I'm not looking, so go ahead. So we defined the button shape, but has anything changed on the main activity XML page? Because we need to set as a background, we created the button shape XML. Now, how will I do this? I'm going to go back to the XML side of the activity main page, and I will change the button background. I will add the button shape XML file under the drawable folder that we created before. And now you can see the button has taken the oval shape. But we defined the width and height to be wrap content. Need to change that too. So I'll change two of them to 150 dp. Button, yes, took the shape of a ring. So you can do this square or rectangular. It's up to you. Go, play. You're going to have a great time. It's enough for this video. I will see you in the next one. Edit text. Hello, everyone. Today we're going to speak about edit text in this video. So edit texts are Android components, and it's used to basically get data from the users. You can see edit text in many Android applications, and they get the data from the users, such as name and surname, password, address, all that kind of stuff. Now, there are different types of edit texts, and we're going to see these types in this video in practice. So we'll go to Android Studio, and let's have a look around. All right, so here you can see edit texts on the left side of Android Studio in the palette window. And under the text section, its name is plain text. And under the plain text, there are other types of edit texts, such as password input, email input, phone number input, date and time, multi-line input, etc., etc. Now, before we start getting into edit text, let's change the relative layout to the linear layout. And now we can learn how to work with linear layout. So what I did was I deleted relative layout from the XML side and wrote linear layout here. Also, the orientation of the linear layout is vertical, and you can see that here. So what I'll do is I'll drag and drop a plain text under the linear layout, and there we go. We have an edit text. Now the idea of this edit text is edit text, and the text of edit text is name. So when we run this application, the users will enter data from here, such as name, right? So let's just run it and see what happens. Application running now, so you can see here users will enter their data from here. Now I'm going to delete the word name that we wrote before, and I can just write everything here. Also I can always enter numbers from here as well. So let's add another edit text. Let me add password edit text and numerical password edit text and numerical edit text that you can just enter numerical numbers from here, and also the multi-line edit text. And we'll run the application with these edit texts. Great, so the first one is standard edit text, and you can enter numbers and characters. The second one is the password edit text. So when you enter password in this enter text, numbers and characters will not be seen, right? And you can enter this password edit text, numbers and characters. It's alphanumeric, just like you would want it to be. And the third one is also a password edit text, but users can only enter numbers and not characters. Also, numbers will not be seen in this type of edit text. And let's have a look at the fourth one, the number edit text. And then here, of course, users can only enter numbers in this edit text, but the numbers will be seen in this edit text. Now, where can this edit text be used? For example, if you want to, grab a phone number from the user, you can use this edit text, or you want a user to enter his or her age. So when you want the user to enter digits only, this is the type of edit text to use. Now, the last one here is the multi-line edit text, and the user can enter more than one line of information in this type of edit text, obviously. So I will write here some text, just to show you how it works. And then you can see here, after the first line, the second line continues under the first line, just auto-magically. For example, you can use this type of edit text to get user comments or address, address a complaint even. There are not going to be many of those, but whatever you need it to do. But in the first one, when the user enters more than one line, after the line has finished, the head of the line will not be seen. Of course, we are not done yet. We've just placed the edit text here. So we need to get the information and use it somehow, right? And we will do this on the Java side using Java code. So let's do up an example, shall we? So I'm just going to delete the edit text except the first one. Now also let me add a button and a text view. So I will develop an Android application, right? And the user will enter the name from the edit text, and after they click on the OK button, the name will be seen on the text view. So I'm going to delete the text of the edit text, but it will not be empty. And I will add a hint to the edit text. Now the hint, of course, is a tip given to the user to understand what the user will write in the edit text. I mean, unless you're making a guessing game, but for this example, we're just going to write in the hint section, please write your name. And I'll change the text of the button as an OK. And I also deleted the text of text view. So let's change the design of the application a little bit. Now I'm going to give a layout margin here of 50 dp from top to the edit text. And I will give some space between the edit text and the button, about 30. And in the same way, the button and text view. And let's do, 30 as the height of the text view. And I'll change the width of the edit text. And let's make it 200. It's a little too small. Let's make it 300. Yeah, that looks okay. So in the same way, I'll just change the width of the button to 300. Now, for the text view, I just do the same. So that means I will place these three components into the center of the screen horizontally. So how can I do this? That's when I select linear layout. And then after that, I'll go to the gravity option from the attribute section, and I'll choose center horizontally, and then all the components placed in the center. Now I will add a text on the text view. Could be, result. And I'll change the background of the linear layout. And let's change the background of the other components too. And I'm going to choose white for these three components. Yeah, that button looks a little big, huh? So let me change it to 200. And now I'll give an ID to these components. So edit text name is for edit text. Button OK is for the button. And text view result is for the text view. So I think it's okay. Let's have a look. We'll run it and we'll see it on the phone. Okay, so the application is working. Now you can see the hint in here. And I write Arnold here, click OK. Arnold should be seen on the text view instead of result. So the application is not doing this right now. Well, because we have not written the Java code, right? That's what you were thinking. So why don't we go over to the Java side and write some code? So the first thing I need is to define these three components. And I'll define edit text. Now, when I write edit text and choose from the autocomplete, Android Studio imports the required class android.widget.editText. So after I wrote edit text, I'll just need to give a name to this edit text. Let's just call it name, just to be clear. Okay, so secondly, I'll do the same thing for the button and give a name, okay. And the last component is text view. I'll just call it result. So now I'm going to assign XML components that I designed before to use these names using the find view by ID code inside the onCreate method. So here I'm going to write name equals find view by ID r.id.editText name. On the second line, OK equals find view by ID r.id.button OK. And in the same way, the result equals find view by ID r.id.textViewResult. Yeah, you with me so far? Because it's so far so good. So now I'm going to add a click listener to the OK button, right? So OK.setOnClickListener, and inside the parenthesis, new view on click listener. And autocomplete will take care of the rest. And I'll write code inside the onClick method. And I'll get the data that the user enters in the edit text. But how am I going to do that? You tell me. You're the one who's teaching the course. Okay. What I'll do is I'll write it here, name.getText.toString. So this code will take that text that the user enters in the edit text, and then it converts it to the string, right? So now I'm going to write this string to the result text view. But before I do this, I'm going to need to define a string container, and we'll call that username. I will assign the text that I took from the edit text and put it into this username string. So because of this, I will write here username equals name.getText.toString. And then I can set the username on the text view. And I will write here result.setText, and inside the parenthesis, username. Right, so this is very important, and I hope you understand this. So rewind, set it up again in case you miss something. So what I did was I defined a container, and its name is username. After that, I took the text that the user entered and converted it to a string. And then I assigned this text to the username. And then lastly, I set this username to text view. So let's run the application and see how it works, or not. All right, so the application opened, and I'll just write here a name and click OK. Good, so it's working, right? So it takes the name I wrote in the edit text and then writes it to the text view instead of result. So I think that's plenty enough for this video. I hope you understood the edit text. Like I say, if not, just rewind and do it again. You'll get the hang of it. Until then, see you in the next video. Image view. Hello, everyone. So today we're going to talk about image view in this video. So image view is an Android component to, guess what? Display images. Now, you know that showing images is really important for your Android application. And if you use good photos, good graphics, and all that, your design's going to look great. And because of all this, image view is important to master. So let's get to Android Studio and learn image view and practice. Okay, so you know that we have this project from before and we'll continue to work on it. So I will add an image view in this project. So where do we find image view? It's inside the palette window under the widgets on the left side of Android Studio. And I will drag image view and drop it in the linear layout. Now, first I'm going to rearrange this so that I put it as first component. Now this is a linear layout and its orientation is vertical. Now because of this, all the components will get their place from up to down, top to bottom, right? So when I drop image view, a new window opens. And this window is the resources window. And what I'll do here is choose a picture for the image view. And I'm just going to choose a picture that's inside my project that I had before. And I'll click OK. So now I can see this picture on the phone, but see there's a problem because I cannot see the other components. And the reason is the sizes of image view are match parent and wrap content. So the size of my image is too big. And then when image view uses the wrap content for height, the image covered all of the screen from top to bottom. So I will change the layout height and width to 300. And now you can see all the components. So image view is now in the center of the screen horizontally. Now because I chose layout gravity center horizontal for my linear layout in the last video, all the components are placed in the center of the screen horizontally. Now, if you look carefully, you can see that the image is placed inside the center of image view. So if you want your image to cover all of image view, you should just choose the size of the image exactly the same size for image view, right? So for example, if the size of image view is 300 by 300, then the size of your image should also be 300 by 300, or vice versa. But also, we can do some arrangements within image view. So when I click on this button, some attributes will open and I will go to the scale type. Okay, and we'll choose from here. We've got a few options. So if I choose Fit Start Image, will take place at the start position. And if I choose Fit Center, the image will be seen in the center. And if I choose Fit End, guess what? It'll take its place from the end position. Now, if I choose Fit XY, image will cover all of image view. But the image will be enlarged and it doesn't necessarily look good. So because of this, Fit Center is a good option. However, of course, it's up to you as the designer of your application. Alrighty then, so these are the things that we can do on the design page. We can also do something on the Java side using Java code. But before we go to Java side, I need to give this image view an ID, right? So let's give the image view example as an ID. And now let's go to the Java code side. So what can we do here? Well, let's say, for example, when I click on the OK button, the image in image view will change, right? So then we'll see another image inside image view. So how do we do this? Well, first, I'll need to decide and define this image view on the Java side. And I will write the image view image. I'll give it a name such as image, and you can give a name whatever you want. And now I'll need to define its ID inside the onCreate method. And I'll write image equals find view by ID, and inside the parenthesis r.id.image example. I can do every operation on the image view using image word, and I will write operation codes inside the OK button, click listener method. And let me just delete these codes that I wrote before. Now I'll write image.setImageResource. But before we continue, I'll need to do one more thing. You know what that is? I'll need to add a second image in my project. That's right. So I will right-click to my drawable folder on the left side of Android Studio and choose Show and Explore. Drawable folder opens, and inside the drawable folder, I have one picture, and its name is A. So I will add a new image to this folder and call it B. And now when I close this folder, I can see my picture B in my project. So now I can call this image. And I'll write inside the parentheses r.drawable.b. All right, everything's okay now. So when I click the OK button, the image will change to image B. Good. So let's run it and see if it's working or not. Application opens. When I click OK, image changes. So you see how you can do a lot of operations like this, but I think it's enough for this video. Play around with that, and I will see you in the next one. Checkbox. Hello, everyone. Today we're going to talk about the checkbox. It's very important. That's why I've devoted a whole video to it. So the checkbox is yet a different type of component in Android Studio. It is a kind of a button. It just accepts two positions, checked or unchecked. And it's often used as a component while developing Android applications, so we need to talk about it. Let's say, for example, that we want to develop a survey application or even a note-taking application. We'll pretty much want to use that checkbox, right? So let's go to Android Studio and see it in practice. before we lose any more time. So we have an earlier Android project from before, yes, and we will continue to build on this project. And what I'm going to do is add 2 checkboxes to this project. And the checkbox is under the buttons section in the palette window. And I'll just drag 2 checkboxes and drop them here. Now, what should we do with these checkboxes? Okay, so let's say, for example, asking for the gender of the user, right? So we'll have 2 checkboxes. One is for male, second one is female. Whichever one the user checks, we will write its gender into the text view here. And let's look at some of the features of the checkboxes. So we can define its height and width from here. And I can change the layout width from the match parent to the wrap content. And now its width is wrap content, but it's placed in the center, right? So that's because we defined gravity of the linear layout center horizontal. So let's do the same for the second checkbox. Okay, so now the 2 of them are placed in the center. So let's ask a question to the user. And for that, I will need to change the text of the text view and write what is your gender, and then the user will give an answer to this question, male or female for now. This is just an example. And I will change the text of the first text box to male and the text of the second box to female. All right, so what do you suppose we can do in here with these checkboxes? First off, let's define the default position for the checkbox from here. We can choose checked or unchecked as a default. And let's continue. So I'll change the text color of the checkbox to white. And I'll do the same for the second checkbox. And let's make the layout margin from the top 10 dp for the first checkbox. Yeah, do the same for the second. If user checks male, text of the text view will change to male. And if user checks female, text of the text view will change to female. Okay, so now we'll need to give an ID to these checkboxes. So I will give the ID checkbox male for first checkbox, and checkbox female for the second. Okay, so now we got to go to the Java side. And I'll go to the main activity. Okay, so first up on the Java side is define the checkboxes. So I will write right here, checkbox. And, you know, if I click here, it will import the checkbox class. But I don't want to do that, so don't get ahead of me. So before the import checkbox, it's red. So I want to show you yet another import method. So when the checkbox is red, you can see a small lamp here. You see that? When I click this lamp, I can see the import class option. So I'll click the import class option, and it will import the checkbox class. And that way I can put names to these checkboxes, male and female. So these names are my choice. Of course, you can give the names to be whatever you want. And now I need to assign these IDs to these checkboxes. And I will write mail equals find view by ID r.id.checkbox mail. And for the second checkbox, female equals find view by ID r.id.checkbox female. Then after that, I'm going to add a click listener to the mail. So when the user clicks the checkbox, it will do these operations. And I'll write them here. Mail.set on click listener, new view on click listener. So now I can write my codes inside the on click method. And now there are two options for the mail checkbox, checked or unchecked. And I will write if mail dot is checked, this will control the checkbox is checked or unchecked. So if it is checked, it will return true. And if it's unchecked, it will return false. Okay, so quiz time. If it's checked, what's going to happen? I want to write mail to the text view. So I will write result.setTextMail. Now, why did I write result? Because we gave result to the text view as the name from before. So if it's unchecked, I will write this question again, and I will write else, and then inside the brackets, result.setText. What is your gender? And I can do the same thing for the female. Female.set on click listener, new view on click listener, and inside the on click method, if female is checked, result.setTextFemale. And if female is unchecked, result.setText, and question again, what is your gender? Right? So now that I break it down, it's pretty simple, right? So let's run it and see what happens. So the application is opening, and it's fully open, and you see if I check mail, text of the text view is changing to mail. Now let's uncheck mail. Text of the text view is changing to the question again. And if I check female, text of text view is changing to female. And if I uncheck female, text of the text view is changing to the question again. But I don't know if you see, we seem to have a problem here. What if I check both of them? Right? So for this example, I really don't want to let the user check both of them. So what am I going to do? How do I avoid this? We're going to need to write some extra code. So I'm going to do this here. If male is checked, female must be unchecked. So I'll write female dot set checked false. And then this code defines the position of the checkbox. If it's true, checkbox will be checked. If it's false, checkbox will be unchecked. So with this code, if the male is checked, female will be unchecked. And I will do the same for the second checkbox, right? So this time I'm going to write male.setCheckedFalse. If female is checked, the male will be unchecked. So let's run it again just to make sure. Okay, so there you go. It's working now. So when I check male, female is unchecked. When I check female, male is unchecked. Okay, so I think that's enough for this video, don't you? See you on the other side. We got another video coming up. Radio buttons. Hello, everyone. I want to talk to you a little bit about radio buttons for this video. Radio buttons are similar to checkboxes that we spoke about in the last video. Radio buttons are inside a group, and the user can choose one option from this group, one option only. So radio buttons are separate from checkboxes with this feature, right? So, for example, you can use radio buttons on a test application, but there's only one answer. The user can choose only one option from the answer, yeah? You can use radio buttons to get information from the user, sort of like checkboxes. But the checkbox, there's two options for one checkbox, right? It's either checked or unchecked. But for radio buttons, the user has to choose one option from the group. Also, one option is chosen by default. So let's go into Android Studio and see it in practice. All right, so we had a project from the last video. Let's continue on that one. And the radio buttons are under the buttons section. But before we add radio buttons, we will need to add a radio group. And I'll choose radio group from here. Just drag it into the text view. And now we can add radio buttons under the radio group. And I'll add 3 radio buttons here. And now you can see radio buttons, but the other components cannot be seen. So let's check the layout width and the height of the radio buttons. All right, so you can see here that the layout width and the height, the radio buttons are wrap content. So we should see the other components normally, but if you check the layout height of the radio group, then you can see it is match parent. So because of this, we cannot see the other components. So let's change it to wrap content, and everything's fine. Now, when I choose wrap content for layout width, the radio buttons will take their place center horizontally. Why? Because we chose gravity of the linear layout center horizontal from before. So what do you suppose we can do with these radio buttons? All right, let's make an example of this. I will give these radio buttons some colors. And when the user chooses a color from the option and clicks the OK button, the background of the main activity color will change to whatever the chosen color is. So let's write the text of the first radio button, green. And for the second one, I'll just write in red. For the last radio button, I'll write yellow. And then when the user clicks OK, the background will change. So let's change the text color of the radio buttons to white. And I can do that from here. Also, I need to give an ID to these radio buttons. So for the first radio button, I'll make the radio button green as an ID. For the second one, I will write radio button red. And for the third one, I'll just write in radio button yellow. Now also, I will define the first radio button to be chosen as a default. And I can do that from here. And I clicked checked option. So after we finish the design, we can then go to the Java side. Now, first of all, we will need to define these radio buttons and the radio group here. And I'll write radio group and give a name, and we'll just call it radio group. And then after that, I'll need to define the radio buttons. So I'll just write in radio button green. When I write radio button, Android Studio imports the necessary class. And then I'll put red for the second button, yellow for the third radio button, and then after that, okay, so I'll need to define IDs for these radio buttons and the radio group. Write in radio group equals find view by ID. But before we continue, I will need to give an ID to the radio group. So we'll go back to the XML page and give it an ID here. And I gave group as the ID. So now I can write r.id.group, and then here, green equals find view by ID r.id.radio button green. And for the red one, red equals find view by ID r.id.radio button red. And lastly, for the yellow, yellow equals find view by ID r.id.radio button yellow. Great, so we have now defined our radio buttons. Okay, so what do you want to do after that? So when the user chooses a color and clicks OK, the color of the layout will change, right? Now to do this, I will add a click listener to the OK button. So we've already defined the OK button here. So I will write here OK.set on click listener, new view on click listener. And then inside the on click method, I will write my conditions. If green dot is checked, and again, before I continue, I will need to give an ID to the linear layout. And I will give linear as the ID. And also, I'll need to define this linear layout on the Java side. And I'll write that here. Linear layout. And inside the create method, layout equals find view by id r.id.linear. And now I can change the background color using layout. So I'm going to write here inside the brackets, layout.set background color, and then inside the parenthesis, color.green. And of course, that's my first condition. If the user chooses the green radio button, background color will be green. And then after that, I can write the second condition. Else if red dot is checked, layout dot set background color, color dot red. And for the third condition, else if yellow dot is checked, layout dot set background color, color dot yellow. So far, so good. So let's run it and see if it's working or not. Application opens. So when the green radio button is selected, click OK. Background color is changed to green. And now I'll choose red and click OK. Uh-oh, the background color is red. Shall we go 3 for 3? I choose yellow and the background is yellow. Now, you should see that I can only choose one option on these radio buttons, right? So pretty much the use of radio buttons is easy. And again, I think it's enough for this video. See you in the next one. Toggle button. Hello, everyone. We're going to speak about toggle buttons in this video. The toggle button gives us two options. Well, technically, it gives two options to the user. It will be on or off. That's the position of a toggle button. The thing is, you define what needs to be done whenever the user turns the toggle button to the on position. It is easy to use, so we'll go to Android Studio and we'll give it a go, see it in practice, because you know what? Time is running. Okay, so we had a project before. Let's continue this project and we will add a toggle button. Now you can see the toggle button under the button section. And I'll just drag a toggle button and drop it under the image view. The layout width of the toggle button is match parent. I'll change it to wrap content. And it's centered horizontally. Now you know that because layout gravity of the linear layout is center horizontally. And now the toggle button will basically have two positions, two options, if you will. I will define what will happen in the on position as well as in the off position. So, what can we make it do when it takes the on position? For example, when it's flipped on, we can make it hide this image. And when it's flipped off, we can show the image again. Also, I going to want to change the text of the text view to image is hidden when toggle button is in the on position. Okay, so after that, I will change the text of the text view to image is shown when toggle button is in the off position. So let's do this. Before we start, we can change the text of the toggle button. Where do I do that? Well, you know that we've all changed all of the text of the buttons from text attributes, but we're not going to do that for this toggle button. There's another text attribute, and it is text off and text on. Pretty handy. So we will define a text in the text off section when the position of the toggle button is off. And also we can define a text when the position of the toggle button is on. And I will write hide image for the text off and show image for text on. So also we're going to need to give a name to this ID and to this toggle button. In other words, we need to give it an ID. So I will give toggle button show as an ID. So now I can go to the Java code section. Now, first of all, I will need to define this toggle button on the Java side. I will write toggle button and toggle button again. Now, of course, you can give it another name if you want to. But then after that, we will define its ID inside the onCreate method. And I will write here toggle button equals find view by ID, and inside the parentheses r.id.toggle button show. And in order to do the operations on the toggle button, I need to add a listener. Now, normally I would just add a click listener, but for a toggle button, I will add checked change listener. So I'll write it here, toggle button dot set on checked change listener, and new component button dot on checked change listener. And I will write my code inside the onCheckedChange method. So when the checked position of the button is changed, the listener will detect this change and then apply the codes that I wrote here. Now it can take two positions, of course, checked or unchecked, or on or off. So it means that when the toggle button is on, it takes the checked, and the toggle button is off, it takes the unchecked position. So I'll just write it here that if it's checked, and inside the brackets, I will hide image. Okay, so how do I do that? Well, if you remember correctly, or if I remember correctly, we defined the image view here before, and its name was image. So I will write here image.setVisibility view.invisible. Now also I will want to change the text of the text view. We have defined text view here already, and its name was, you remember, don't rewind, result. So I'll just write it here, result.set text image is hidden. Okay? So after that, we can write the else condition. So that means that when the toggle button takes the off position again, I will write here image.setVisibility view.visible. Also, result.setTextImage is shown. Okay, so let's run it and see if it's working or not. And now the application's open. So you see here on the toggle button, the text is hide image. When I click the toggle button, image is hidden and text of the text view is changed. Cool. Also, the text of the toggle button is changed. So when I click it again, the image is shown and text of the text view changed again. Also, the text of the toggle button is changed to the hide image. So that's, I don't know, I think it's easy. I hope that you think it's easy too. But in any event, it is enough for this particular video. I've got another one coming up, so see you then. Spinner. Hello, everyone. Today, I want to speak to you about Spinner in this video. Spinner is an Android component that we use in Android application development. Spinner opens a list, and then the user can choose an item from the list. So when the user selects an item from the list, some operations can start by choosing the selection. So why don't we go to Android Studio and get to work and do some practice? All right, so remember we had a project before. We'll just continue with the project so that we can see the progress on the build. And we're going to do an example in this video. So let's set up the example project just like this. There's a list of countries. And when the user selects a country from the list, the country name will be written here on the text view. So for example, if I want to select Germany, then text view will display Germany. If I select the Netherlands, on the text view, it will write Netherlands. Right, so this is how Spinner works, basically. So why don't we start to do this in the application? So first of all, we need a spinner. But before I add Spinner here, I want to add a new horizontal linear layout here. And I added this layout under the image view. I'll add Spinner under this layout, and Spinner is under the container section. Also, I'll add a text view. So this text view will display and explain what the user will do with this spinner. And you see that the other components are not seen. And here I can change the height of the new linear layout to the wrap content. And now you can see the other components. So also, I want to change the width of the spinner to wrap content. And now we have a text view and a spinner. So I'll change the text of the text view. I will write it here to select a country. I'll also change the text color of text view to white. Okay, so now we need to give an ID to the spinner. All I do is write spinner country. And then after that, I just need to fill in the spinner. Now to fill in the spinner, I will create an array. I'll do this under the values folder in the strings XML file. I'll just open the strings XML file and write here string array. Now I need to give a name to this array. The name could be, I don't know, countries. And I will write between the string arrays items. I'll write an item here. And I will write the country names between two item XML code. So every item is an element of the array. All right? So the first country should be England. Second is Netherlands. Third is Belgium. Fourth is Germany. And fifth is Finland. Okay, so now we have 5 items inside the countries array. All right, so the spinner is ready, and also the array is ready. So now we can go over to the Java side. So first, I'll define spinner. And I'll just write here spinner. Also, the name could be spinner again, doesn't matter. Well, I mean, for me it does because I like clarity. And then inside the onCreate method, spinner equals find new by idr.id.spinner country. All right, so now I need to take a moment to explain a very important bit here. We have a spinner and we have an array. To transfer information from the array to the spinner, I'll need to create an adapter. So in this case, what is an adapter? So let me just show you with a picture, because it's very important. I want you to have a look at this in detail. We will use the adapter in some of the other components as well. So now we're going to use this adapter for the spinner, but we'll also use it for the list view and the grid view for some of the next videos. So we will call the adapter, and then what makes a connection between a data set and a view. In this example, the data set is array list and the view is spinner. Then we need to create an adapter between the array list and spinner. And I'll just do this in the main activity using Java code. So I'll write here array adapter, and its name is adapter. And I'm going to define this adapter inside the onCreate method. So here, the adapter equals array adapter.create from resources. Now I need to define 3 parameters in here. First is context, and I will write here. All right, that's right. So this means that this adapter will work in this class. The second parameter is array ID. And I'll write r.array.countries. And I'll define array ID to the adapter. Now the third one is the spinner layout. I need to specify how each item looks inside the spinner. So I'll write android.r.layout.simpleSpinner item. So now I need to specify the drop-down layout. I'll write adapter.set drop-down view resource. And then inside the parenthesis, android.r.layout.simple-spinner drop-down item. And now the adapter's ready. I'll just need to assign this adapter to the spinner. How do you do that? I will just write spinner.set adapter and adapter. So now these codes will fill in the spinner with the countries array. Now, let's check it just to make sure that we have done this so far so good. You with me? Okay, so the application is open. And in the text view, writing select a country, spinner filled in with the country names. So what have we done up until this point? We have created a spinner and a data set, and then we have connected the spinner and the data set using the array adapter. And then after that, we needed to do one more thing. When the user selects a country from the spinner, the name of the country should be written in the text view. So let's continue. I'll need to add a listener to the spinner. And this listener is set on item selected listener. And inside the parenthesis, new adapter view dot on item selected listener. So when I write this code, two methods are created by Android Studio. First one is on item selected. The other one is on nothing selected. So I'll write my codes here. When the user selects an item from the spinner, this method will work. And I will write here parent dot get item at position. And inside the parenthesis, position. Okay, so now what will this code do? It will take the text of the item in the selected position. And then after that, I will assign this text to a new string. So I've created a new string, and its name is country. And lastly, I will write result.setText and country. And now this code will get the country name and write it on the text view. All right, so let's run it again and look. Ooh, I get excited, I know. Okay, so the application is open, and when I select Netherlands on the text view, it will write Netherlands. And when I select Germany, it will write Germany on text view. And which item I select from here, it will write the name of the item onto the text view. And that's the way the spinner works. So I think that's plenty for this video. I will see you next video. Toast message. Hello, everyone. In this video, we're going to talk about toast messages. And before you pick up that drink, listen to me. The toast message is used to show short time information to the user. So in other words, let's say that when a user clicks a button or opens a new window, or you want to give some kind of information to the user, that's when you use the toast message. So let's go to Android Studio and see it in practice before we lose any more time. You can pick up that drink now. All right, so you know that we have a project that we've been working on, so let's continue working on this project. But before we start, let me just show you a toast message. So you see here when I click the OK button, a toast message displays. And the message is, this is a toast message. So after a while, the toast message disappears. You can show this toast message whenever you want. I display it whenever the user clicks the OK button, but you can display it when the user, clicks an image or downloads something. So why don't we look at how to actually do it? So displaying the toast message is pretty simple. We don't have to do anything on the design page. We'll do it just right here on the main directory.java page. So what I want is when the user clicks the OK button, the toast message will be displayed, right? So I'll just add a click listener to the OK button. And I defined the OK button before. You can see it here. And I'll just write inside the onCreate method, OK.set on click listener and new view on click listener. And after that, inside the onClick method, toast.makeText. And after makeText, it will get 3 parameters. The first one is get application context. Second one is message, and I will write a message inside the quotation marks. So what I write inside the quotation marks will be shown as a message. Message is, this is a toast message. Now the last parameter is how long the toast message is shown for. There are basically 2 options here, toast.long and toast.short. So I'll just select the first one, and then after the parenthesis, I will write .show. And guess what? That's it. Your toast message is now ready. So why don't we run it and see? The application's open, and when I click OK, the toast message displays. And then after a while, it's gone. So I think that pretty much covers the toast message. I'll see you in the next video. Snack bar message. Hello everyone, in this video we're going to talk about the snack bar message. Now, okay, before you start going to the obvious, like I wanted to, the snack bar message is a message method to, well, impart information, not wisdom, just information to the user. So it kind of looks like a toast message, but it's a little different. So it's displayed at the bottom of the device screen, and it has a close button in order to close the message whenever the user wants. So let's have a look at it in Android Studio. And of course, you know by now that we have an Android project here, and I'll just continue building this project. But before we start to create the snack bar message, I want to show you how it's going to work. So when I click the OK button, it'll display on the bottom of the screen, and when I click the close button, it will close, right? So in here, this is the message that is what we call the snack bar message. So you can give a message to the user here. You can see the difference between the toast message and the snack bar message here. So in the toast message, the message is shown, and after a while, it disappears. Also, the user cannot close the toast message. But in the snack bar message, the user can close the message whenever the user wants. All right, so let's create a snack bar message. It's pretty similar to the toast message. There's not much on the design page, and we will create it on the Java side. So what will we do? Okay, so let's say that when the user clicks the OK button, the snack bar message will display. And to do this, I'll just add a click listener to the OK button. And what will I write here? OK.set on click listener. New view on click listener. And I will create a snack bar message inside the onClick method. And before we continue, we will need to add a library to the project. I'll just open the build.gradle module app page and check a library. So it is inside the dependencies implementation com.android.support design 28.0.0. And if you already have this library inside your project, you don't have to do anything. If you don't have it, you will need to write this line and click Sync Now. And then after you click the Sync Now button, it will add this library inside your project. And then after that, you can create your snack bar message. All right, so after this, we need to do one more thing. We need to define where we will show this snack bar message. And let's just show it on the main activity layout and on the linear layout. So I'll need to define the linear layout on the Java side. Now to do this, I'll need to give an ID to the linear layout. Now, of course, I've done this before, and the ID is linear. But also, I define linear layout on the Java side with this ID, and its name is linear layout. Okay, so after I do that, I'm ready to create the snack bar message. And I'll just write snackbar.make. It'll take 3 parameters inside the parentheses. So let's see, for the first one, that's where I will show this message. And I want to show it in a linear layout. So I will write here linear layout. The second one is message. So I will write my message inside the quotation marks. The message is, how about this is a snack bar message. And the third one is how much time the message will be displayed for. So here it gives you 3 alternatives: long, short, and indefinite. So in the long and short, the message will disappear after a while. But in the indefinite, the message will not disappear until the user closes it. All right, so I will choose indefinite, and I will write snackbar.length indefinite. And then after that, I just write .setAction. Now, this also accepts 2 parameters. The first one is text of the close button. And let's just give it some text for the close button. And I'll write here close, but you can, of course, write whatever you want. And the second is click listener. Now, I'll need to define a new click listener, because when the user clicks the close button, the snack bar message needs to be closed. So when I add click listener, Android Studio understands this is for close snack bar message. And I don't need to write anything inside the click listener. And then after that, I will add here.show. And that should do it. Snack bar message is now ready, so let's run it. Okay, so the application opens, and I'll click the OK button, and the snack bar message is displayed. And then when I click the Close button, the snack bar message disappears. So let's see what happens if I choose snackbar.length short. Let's run it again. So this time when I click the OK button, the snack bar message displayed, and then after a little while it disappeared itself. So this is how snack bar message works, and I think it's enough for this video. So I will see you in the next one. Dialog messages. Hello everyone. This is the video where we're going to talk about dialog messages. So a dialog message is another message type to give information to the user. Now, of course, unlike the other messages, the user interacts with the dialog message. So in the dialog message, a small window opens, and the user is informed. And then after the information, the user decides what's going to happen next. So you can see how the dialog message, how it's going to work in a lot of different applications. You probably already recognize it. Let's say, for example, if you want to delete something, a dialog message opens and then asks you, hey, do you really want to delete this? And then after that, if you really want to delete it, you can click yes. Or if you don't want to delete it, you can click no. Another example could be if you want to close an application. A dialog message is shown, and then after that, you can choose to close it or not. So dialog messages are probably one of the most used messages, so why don't we just get to it and open up Android Studio and see how to create it. Now, of course, you know that here we are back in our project, and we will continue to build it. And this is what we'll do. So we have a button here. Its text is delete text of text view. And also we have a text view here. So when I click this button, it will show me a dialog message before it deletes the text. So then after that, if I click yes, it will delete the text. If I click no, it will not delete the text. Now before we start, I just want to show you what it will look like. Okay, can you see? When I click the delete button, it's asking me, do you want to delete text? And there are two options, yes and no. And when I click no, it disappears. When I click yes, it's deleted. So let's create it. So we create dialog messages on the Java side. So where will I write my code? When I click the delete button, I want to create a dialog message. And this is the delete button. We defined it before. Its name is OK. So I added a click listener to this OK button. So now I can create a dialog message inside the click listener. I'll write a method. Its name is show dialog message. And I will call this method here. But I'm going to write this method below because I don't want to mess in the onClick method, right? So I can do it in two ways. First one is I can write this method myself here. The second way is I can click this red lamp and choose create this method. So after that, I'll need to choose the main activity here. And it created this method automatically. So now I will create a dialog message in here inside this method. Name of the dialog message is alert dialog. Okay? And then I'll write here alert dialog.builder. And after that, I'll need to give a name to this alert dialog message. And I'll write alert dialog equals new alert dialog builder. And I'll write inside parenthesis. So when I wrote this here, I defined the context. So it will work on this activity. So I created a dialog message and give it a name, alert dialog. Okay, so now I need to define its features. So I'll write here alert dialog dot set title. And then whatever I write here will be shown as a title. And you can see that here. Delete is the title. So now I need to define this title. And I'll write inside the quotation marks, delete. Okay, so I'll continue. I write here dot set message. And I will write here my message that I want to show to the user. You can see here, message. Message is, do you want to delete text? Okay, so far so good. So after the message, I will define the yes and no button. And how will I define these buttons? I'll write this here, set negative button. Negative button is no. So now I need to define the text of the button. I will write inside the quotation marks, no. And then after that, I need to add a listener to this no button. Because when the user clicks no, it needs to sense that and trigger some operations. So I'll write after the comma, new dialog interface dot on click listener. So now when the user clicks on no, I'll write down what I want it to do. Also, I need to define the yes button. So I can just write that here, dot set positive button. And inside the parentheses, I will write the text of the positive button, yes. And I'll add a click listener to this yes button as well. Now when the user clicks on yes, I'll write down what I want to do. And then after that, I'll just write here dot show. And then what that does is it shows the dialog message. Oh, and lastly, I will write alert dialog dot create. So that should be pretty clear. It's a few steps, but I hope you understood. I created the alert dialog here. And I defined the title here and defined the message here and defined the yes button here. And then added a click button to this yes button. Now also, I defined the no button here and added a click listener in the same way. And I added here the show and writing alert dialog dot create. Alert dialog is now ready. So after that, I'll need to specify what will happen when the user clicks on no, right? So when the user clicks no, the alert dialog will be closed. So what will I do? I'll write here dialog.cancel. So also I'll need to specify what will happen when the user clicks yes. When the user clicks yes, text of the text view will be deleted. So we defined this text view before. Its name was result. And now I'll just write it here. Result.setText. And I won't write anything inside the quotation marks. And that way the text will be deleted. So why don't we have a look? Let's run it and see. Applications open, and when I click the delete button, the alert dialog opens. And let's see what happens if I click no. The alert dialog is closed. If I click yes, it deletes the text. Great, so this is a fairly simple but accurate example of two buttons for the alert dialog. So there are other types of dialog messages. We learned this type, and we will see some other types in the next upcoming videos. So I'm excited. I hope you are too. I'll see you in the next video.